Hey guys, welcome to this session by Intellipaat. Unless you've been living under a rock for the past couple of years, you would have come across this term called machine learning. Machine learning has had a huge impact on every sector, from security to scientific computing. It has helped in tackling and solving a lot of problems which were considered hard and even impossible to solve. But it is a little intimidating to get started with because of all the dense mathematical jargon associated with it. Which is why in this session, we'll be helping you to get started with it and also get a good grasp of what machine learning is. And before we start this session, please subscribe to our channel so that you don't miss our upcoming videos.
So let's take a quick glance at the agenda. First, we'll start off with the introduction to machine learning, and then we'll be looking into the machine learning algorithms. Once that is done, we'll look into a machine learning project in which we'll be using the Python programming language. After that, we'll be looking into mathematics for machine learning, that is basically statistics, and then building machine learning classifier in Python using a Sckit-learn package. Once that is done, we'll be looking into hyperparameter tuning in machine learning. After that, we'll be looking into machine learning on Kubernetes. Once we learn all of this information about machine learning, comparing artificial intelligence with machine learning and understand what exactly they both are. Once that is done, we'll be looking into the machine learning engineer job, salary, and the career prospect. And finally, at the end of this session, we'll be looking into interview questions on machine learning so that you can clear the next interview you get into. Now, without any further delays, let's begin with it.
We'll begin by taking a look at what is machine learning. So machine learning is a fairly loaded term. Many people use machine learning to mean a lot of different things. So in this session, what we'll be doing is we'll first try and understand what machine learning is, because that is the basis of the concepts that we'll be building things on. So machine learning is the branch of computer science that deals with using data and mathematics to help computers learn rather than being explicitly programmed. Now, this is like the quintessential machine learning definition. So to help understand it better, let's first understand what the traditional programming model is. So machine learning has helped developers build tools and systems that could not have built by using traditional programming models. So the reason why traditional programming models don't work is because we would explicitly have to come up with rules and put them in our system. So to give you an example, if I were to ask you to create a machine learning, not machine learning, but create a system that would, using traditional programming models, recognize what a particular image, what is the digit that is contained inside a particular image. Does it contain a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? Now, using that, you could probably define some constraint that the image needs to be 8 by 8 pixels. It could only contain black and white. But even with all those constraints, the variation is so much that it becomes really difficult for us to use traditional programming models to hard code some of the rules that will take in an image and will spit out the correct answer. So to give you an example, if I were to give you a quick understanding of how this works, you would have to take the entire image, then take the data on each pixel and use that data somehow to understand what exactly is the number inside this image. That is really difficult to do using traditional programming models. While traditional programming models are good for several things, including building applications that could respond to particular events, particular data streams, and a lot of other things, they're not good at changing with the requirements at the pace machine learning allows them to. So for instance, if I were to use machine learning, then our computers can actually generate some statistical models that will specify how confident it is that it is one of the following numbers from 0 to 9, which is a single digit number, which is the problem that we're trying to solve, and it will solve it quite easily. So that's why we use machine learning. It allows developers to build programs that traditional programming models couldn't. In traditional programming models, we would take in the data, run it through the entire program, in which we will use data transformation and if-else statements and many other programming constructs. And using those, we'll figure out what the user wants and give them the output. While in machine learning models, what we do is we take an algorithm, machine learning algorithm, we take some data and we create a model, which then will take in the data and fit out the output. So it's machine learning on its own the rules instead of us having to explicitly type out what the rules should be. So we'll take a look at types of machine learning. So there are three kinds of machine learning algorithms available, or three broad categories in which machine learning algorithms can be divided. These categories are divided based on the criteria of what kind of data we give them and how they learn and what kind of problems they solve. So the first one is supervised learning. So if you take a look at supervised learning, it basically means that we take supervised learning is used to help machines learn how to map input to output based on the input output pairs that we have given to them as examples. So to give you an idea of what supervised learning is, in supervised learning, we give machine learning algorithms some data. That data already has the x variables and the y variables. Now, x variables are the things that the machine learning model expects to be fed into it, and the y variable is the thing that we're trying to predict. So, to give you an example, if you're trying to build a model that could predict the temperature of the upcoming 7 days, let's say upcoming week, then the x variable would be the conditions that you're feeding into the data, and these could be several different things. That really depends on how you're training the model. So for an example, if you're trying to train a model, try and understand what are the different kinds of things that can affect temperature. So for instance, the altitude of the place that you're at, what was the temperature previous days, how were the weather conditions, what's the atmospheric pressure, and all these kinds of things. These are all combined into a row, and that row is called the x variable. And when we make a prediction on it, it will give us a temperature, which could be in Celsius or Fahrenheit, depending on how you've trained the model. If you've trained a model with the Celsius data, it can't predict Fahrenheit. You would have to convert it yourself. And if you have trained it in Fahrenheit, it can't predict Celsius. You would have to convert that yourself. So basically, in supervised learning, what we do is we give machines some data in which the input and output are already present. The machine learning model then has to take a look at the data and understand how the input relates to the output, come up with the rules on its own, so that when we feed in new data, it's able to predict the output, or at least predict it close enough. So a good example of this would be if we show machine learning, for instance, when we're learning how to read alphabets, the first thing that they do is they show us a lot of alphabets, how to write it. And so after this, we have unsupervised learning. And unsupervised learning is quite easy to understand as well. Unsupervised learning is a machine learning technique which allows a model to work on its own to discover patterns and information that was previously undetected. To give you a bit of context here, in unsupervised learning, let's say that you have been given a lot of customer data, how customers have interacted with your websites, and how, let's say you have an e-commerce website, and how many customers have bought what kind of things, and what are the kind of things that they've bought together. So some customers may have bought shirts and pants together. Some customers may have bought gaming consoles and games together, these kinds of things. So what were these kinds of things that they bought together? And then after learning that, you could come up with a strategy on creating offers. So if you are building that kind of a model that can just take a look at the data and then figure out some sort of pattern that's inside it, the data that you're giving doesn't contain the data, doesn't contain the pattern that you want it to find out. That's the main difference between supervised and unsupervised learning. In supervised learning, we give it all the data and all the outputs that we need from the data, and it essentially works out a pattern to map the input from the output. In unsupervised learning, we just give it a lot of data and just tell it, okay, figure out some pattern that could help me out in building my business strategy, or creating or understanding how the data works and how the trends are going, and that way you can use that. So now what we have to do is, after unsupervised learning, let's take a look at an example of unsupervised learning algorithm. So for instance, just like I've told you, you can build a model that can help you generate offers. You can also build models that can help you group customers. So for instance, given a customer and his buying habits, you can group them into premium customers. You can group them into customers that you could follow up on to share exciting offers with, or share reward points or something like that. So that also helps you out in case you're using machine learning. Then comes reinforcement learning. Now this is quite an important kind of a thing. In reinforcement learning, what we're doing is we're teaching our models how to make decisions. Now these techniques allow they use an agent, and what it does is that it takes a look at a machine learning algorithm. It takes a look at the data set, then it tries to create a decision for it, and every time it makes a wrong decision, a penalty is introduced, and whenever it makes a right decision, the penalty is decreased. Okay, someone has asked, do we also have data and reinforcement learning, just as we have supervised and unsupervised learning to train our machine? Yes, we do have data. So many different kinds of data can be there. So you could also use reinforcement learning to train a robot. So for instance, whenever we're trying to create a robotic interface, we're trying to create a robot that can take decisions, that can go someplace and do something, reinforcement learning takes into place. So what it does is that it takes a look at the data, that how a person moves, how a person interacts, and understands how to move according to that. After that, what it does is that it takes a look at, okay, what are the different situations and how does a person move in those. If the road is wet, how does a person move? If the road is not wet, it's quite dry, then how does a person move? If the road is slippery, how the person moves. And using that, if the agent that's supervising the reinforcement learning algorithm figures out that the robot is deviating from the way it's supposed to move, it incurs a penalty, and the model is supposed to decrease the penalty, so it tries to not repeat the problems that happened before. All right, so let's take a look at the next topic. But before we do, since I have told you that since I've told you that this is an interactive session, I have a question for you. So in a moment, you guys will be able to see a poll, and I'd like you to answer those polls. All right. All right. I've launched a poll, and I would like you guys to answer the questions. I can see the results coming in, so don't worry. Just keep answering the question, even if it's wrong. It's totally fine. It doesn't really matter. I'd like you to keep answering the poll so that we can understand what it actually is that you guys have understood from the thing that we have understood. So just keep answering the polls. Don't worry about it. It'll be fine. Okay. So I've gotten the answer. 42% of the people have said reinforcement learning. The question for those of you who have not seen the question is, what type of machine learning is used by systems that can play games, that can learn how to play games? So a very good example of this is the AlphaGo that was created by DeepMind, which is a company owned by Google, and it beat the world champion. Out of 4 rounds, it won the 3 rounds from it. So that kind of system is built using reinforcement learning. So majority of people has answered reinforcement learning. Now they do use some supervised learning concepts inside with reinforcement learning. So you are right there as well. So those of you who have answered reinforcement learning are completely right. Those of you who have answered supervised learning, you are close, but you're not correct. And unsupervised learning is just not the right answer. So with that, let's continue with the session. All right. So now let's move ahead. So now let's take a look at what is classification, because that is the kind of model that we'll be building. I'd like to help you understand what classification is. For those of you who are unaware, classification is a machine learning technique that comes under the supervised learning technique. In supervised learning technique, you can build regression models as well as classification models, and we'll be taking a look at classification. I'll also explain what regression is. So let's take a look at what is classification. So in machine learning, classification is simply an activity that consists of putting things into the categories based on the similarities or common criteria. If I give you a lot of people who have applied for the loan, who have applied, if you're working in a banking industry, you need to help understand them what are the kinds of transactions that could lead to fraudulent transactions, and to do that you can take in some data about the transaction, the date, the time, the username, the user's credit score, so on and so forth, and using that you can figure out whether or not this transaction is fraudulent or not. So that is the classification problem, when you already have some categories defined and you want to place the incoming data into one of the categories. So there are a fixed set of outputs that your input can map into. So for instance, our digit recognition is a classic example of classification, in which what we do is we take in an image, we analyze it, and we figure out whether or not it contains which number does it contain from 0 to 9. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, any one of those. So there are 10 possible classes that our input could go into, and that's what we do in classification. So that's what classification is. Another problem could be regression. Regression is basically when you're trying to predict a continuous value. So think of it this way: when you're trying to predict a continuous value, um, a continuous value would be you're trying to predict the temperature, you're trying to predict the housing price based on the features that you have, you're trying to predict the stock market price. These are continuous values because it could be a number in fraction, it could be a whole number, it could be a lot of things. There's no particular categories that you can put this into. So that's regression, and we're learning classification here. So that's the difference between those.
Typically, when we talk about ML, right, you can broadly sort of categorize your ML journey into two major paths. One is called as supervised learning, and the other is called unsupervised learning. Right? They almost are the kind of problems that we have. Okay. So let's talk a little about what supervised and unsupervised learning really is all about. I'll give you a couple of problem statements, and I think with those problem statements, it'll become more and more evident as to how these two are really different. So problem statement one is the problem that we spoke about a while earlier, which is the student dropout prediction. The student dropout prediction. Right? I am interested in predicting if a particular student is going to drop out or not. Right? I'm interested in predicting if a particular student is going to drop out or not. The second is, let's say, employee churn prediction or employee attrition prediction. Yeah? Think of it. It's a very similar problem. I'm interested in predicting if an employee is going to quit my organization or not. Right. The third problem, which is, let's say, we call it churn prediction. Let's say an insurance company is trying to predict if you are likely to if you're likely to quit their services, or let's say a telecom company is likely to predict if you're going to quit their services and join their competitor. Right? If you kind of think of it, these three are very, very similar problems. It's just that the context is different, the domain of the problem is very different. While this is university and student data, this is employee data, this is customer data. These are three different domains, but the underlying problem is more or less the same. The underlying problem is trying to predict if a particular activity is going to happen or not, or will the person quit or not. Right? That kind of a problem. Let's take another example. Predicting rainfall in, let's say, in a location. We're predicting rainfall. Here also I'm predicting, but in this particular case, I'm not predicting if a particular activity is going to happen or not, but here I'm actually predicting the value of the rainfall in itself. Right? I'm saying there will be 20 centimeters of rainfall today in Hyderabad. Right? And this is very apt as of now because Hyderabad is almost drowning in rains. But anyways, that's the fifth one is, let's say, predicting sales of an organization. Right? Let's say I run an automobile company or an automobile dealership, right? And I'm interested in predicting how many automobiles am I likely to sell, or what will be the revenue generated at my dealership this year. So again, here I am actually trying to predict the actual dollar value or the rupee value, so to say. So again, this is not predicting if something is going to happen or not. While these are saying a yes or no kind of problems, these are predicting the actual value in itself. The value, the actual currency value, the dollar value, or let's say the actual rainfall value in itself. Okay. Sixth, predicting. Let's say I'm interested in predicting the stock price, right? Or let's say I'm interested in predicting what will be the I'm interested in predicting fuel consumption. Right? Let's say I run a mining company, and one of the most important things for me is one of the most important expense for me is fuel, and I'm interested in identifying what will be the fuel consumption in the next 1 year. And because based on that, I can sort of make an estimate of how much cost I might end up spending. So predicting fuel consumption. Now, all these problems that you see right now, right? All these problems that you see right now, they are all trying to predict a particular outcome, right? While the first few that you see, the first few, while these three are trying to predict a certain outcome, which is like a yes or a no, a discrete outcome. They're trying to predict a discrete outcome, like a yes, no sort of an outcome. These are predicting a continuous outcome, right? So firstly, and more importantly, all these problems have a defined outcome that you're trying to predict, have a predefined outcome that you want to predict. So these are all different problem statements. A few problem statements are trying to predict a discrete outcome. A few problems are trying to predict a continuous outcome. But more importantly, all these are trying to predict a predefined outcome. There is a predefined outcome. I'm interested in predicting a certain kind of a value. I want to predict churn. I want to predict sales. I want to predict rainfall. I'd like to forecast the stock price, blah, blah, blah. All these are trying to do the same exact thing. They're trying to predict a specific outcome. Problems where you have a predefined outcome, problems wherever you have a predefined outcome, they are all called as supervised learning problems. The reason why we call them supervised is because your analysis has a direction. I am not interested in predicting, in this case, I am not interested in predicting the number of marks the student is going to achieve. My analysis is focused. My analysis is to predict a certain kind of outcome. My analysis is supervised by a certain problem statement that I have up front. So whenever you have a predefined outcome for your analysis, or whenever you have a predefined problem statement, such problems are referred to as supervised learning, right? And in supervised learning, right, there are two broad categories. One where you're making a discrete prediction. Whenever you make a discrete prediction, or you're predicting a categorical outcome, a yes or a no, right? Or let's say looking at an image, you're predicting, is this a cat or a dog? Such kind of problems are referred to as classification problems, right? Classification problems. And the other category, wherein you're trying to predict a numeric outcome, when you're trying to predict a continuous outcome, we call these as regression problems, right? So broadly put, whenever you talk about a problem statement, if your problem statement has a predefined outcome, right? Whenever you have a predefined outcome that you're chasing, or when you have a certain kind of an outcome that you're chasing for analysis, such problems are referred to as supervised learning problems. And if when you're predicting something, if the predictions are discrete, we call these as classification problems. And if the predictions are continuous, then we typically refer to these as regression problems. Okay, so that's essentially what a supervised learning problem is. Then that brings us to the question: if this is supervised learning, then what is unsupervised learning? Right? I'll tell you what unsupervised learning is. Unsupervised learning is slightly different. Under the unsupervised learning bucket, the problem statements could look slightly different. Right? Let me try to explain how the problem statements in an unsupervised learning problem could look like. First one, extract or identify patterns, identify purchase patterns in customers. Let's say you're running a supermarket, and all that you're interested in identifying is you're interested in identifying how your customers purchase your products, right? You're simply interested in extracting some kind of cool patterns, extracting some kind of insights from how these transactions happen. Okay. Let's say you are State Bank of India, or let's say you are whatever you are. Let's say Goldman Sachs. You have a ton of customers with you, and one of the most important things for you is because you're looking at so many customers and you have a ton of customers with you, it becomes very difficult for you to know who your customers are, because if you have, let's say, 100,000 customers, or let's say 1 million customers, beyond a certain point it becomes very difficult for you to know who your customers are. So extract patterns on who the customers are, who our customers are, right? Are my customers young? Are my customers old? Are my customers young and make a lot of transactions? Are my customers old and make more transactions? Are my customers based out of so and so location? Blah blah blah. Yeah, this is all basically, again, extracting patterns about whom your customers really are. Again, yeah, very similar problem statement. Right. Third, same thing. I have a lot of employees with me, and I'm interested in identifying how my employees, again, similar problem, who my employees really are. What kind of employees? What's my mix? What's my employee mix today? Right. So I want to extract patterns around that. Okay. Let's say I have many images with me, and automatically group um, let's say I have images based on features that I have, right? Because I have a lot of data, I have a lot of images, a lot of let's say photographs of a lot of people, and I'd want to automatically group them, right? Again, the key point that you have to understand over here is, with these problems, unlike your supervised learning, they don't have a predefined outcome. There is no clear target that you're really chasing. And when you don't have a target, and when you're not really supervised by a certain outcome, such problems are typically referred to as unsupervised learning. Right? Because if you look at these problems, I want to identify some patterns about my customers. I want to identify how my customers are making purchases in my supermarket, or I'd want to automatically group my records based, or group my images based on the features that they have. There's no one variable that I'm trying to predict on. There's not really a clear distinction about what I want to achieve as an outcome from this whole analysis or the whole activity that I'd like to perform. When you don't know, and if your problem statement is extremely open-ended like these, we call these as unsupervised learning problems. But when your problem is nicely defined, well scoped out, you know what you want to achieve, such kind of problems are referred to as supervised learning problems. Okay. If you and supervised learning problems can be broadly identified into two categories called as classification problems and regression problems. As far as unsupervised learning is concerned, again, there are a lot of techniques under unsupervised learning, but broadly you can classify these as clustering, also referred to as segmentation, association or frequent pattern, let's call it association rules, or market basket analysis. We call it as a market basket analysis. And there are a ton of other techniques as well, like for example recommender systems, etc. They all come under this category, so to say. They all come under the unsupervised learning category. Point being that whenever you try to solve a data science problem, it more or less comes under an unsupervised learning problem or a supervised learning problem, either an unsupervised learning problem or a supervised learning problem, right? The distinction between a distinction between an unsupervised learning problem and a supervised learning problem has got to be around uh, do you have a target variable or not? If you have a target, when I say a target variable, what do I mean? A predefined outcome. We also call this a target variable. Like for example, in the case of the student prediction, dropout prediction, dropout is the target variable, target column. That's what I'm trying to target as a part of my analysis. Okay. In the employee attrition, will an employee quit or not? That's my target variable. So whenever you have a target variable, and in a lot of places you would read it as this as well. A lot of people would say if you have a target variable, it is supervised learning. If you don't have a target variable, it is unsupervised learning. That is essentially what we are saying here as well. Target variable simply means a predefined outcome. If you have a predefined outcome, then it is referred to as supervised learning. If you don't have a predefined outcome, then it is referred to as unsupervised learning. Okay. So that's in short about what supervised and unsupervised learning is. So now coming back to the digging a little more into the jargon.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Which of the following are machine learning methods? A. Based on human supervision. B. Supervised learning. C. Semi-reinforcement learning. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Okay, we're going to dig a little more into this jargon of supervised and unsupervised learning, and let's try and understand where all these terminologies really fit in. So we're going to solve either a ML for now is broadly into two categories, either a supervised learning or an unsupervised learning problems. Under supervised learning, we've identified two major categories again called as regression or classification. And under unsupervised learning, there are another, a few problems, like for example, recommender systems, and then it's also about recommender systems, and then association rules, clustering, and so on and so forth. These are a few techniques. Under the regression and classification problems, here is where a lot of interesting, a lot of interesting techniques are there. Again, as I said, under regression, what is regression? What is classification? Regression is where I'm predicting a continuous outcome. And under classification, we're predicting a categorical outcome or a discrete outcome. A discrete outcome. Okay. Under the classification and regression, right? Especially under the classification, there are under these two, there are a bunch of techniques that we're going to learn. For example, under regression, we're going to learn techniques called as linear regression. And under classification, we're going to learn something called as logistic regression. I know we are using the term regression under a classification, but that's okay. There's a reason why we do that. We'll come to that at a later point. But we're going to learn something called as linear regression, logistic regression. And then we're also going to learn about things like, in here, we're going to learn about decision trees, random forest, and so on and so forth. There are a ton of techniques under this. Similarly, even this has a few set of techniques under this. While of course each of these has a wide variety, the list of techniques under each of these is very, very large. The point is that each of these techniques that you see, decision trees, logistic regression, linear regression, all that they're trying to do is they are just mathematical approaches or mathematical / algorithmic approaches to automatically extract patterns from historical data. So you're going to pass some historical information. So you're going to tell, so the way these algorithms are going to work is think of them as these black boxes. What you're going to teach to them is you're going to pass some historical data to it, historical information to it. What historical information are you going to pass? You're going to pass information about, firstly, right? Let's say you're trying to solve the churn prediction in a telecom company, or let's say you're trying to predict employee attrition. Right? Will an employee quit a particular organization or not? Or let's say, for example, a very common problem that a lot of companies solve is, I see that so and so particular student has signed up on my portal. Will he take up a course or not? Intellipaat would probably be interested in solving that problem, don't you think? Yeah. The point is about the employee attrition, or let's say take for example the employee attrition problem. I have a ton of information with me about the employee, right? Like, let's say, for example, the skill set, the salary, the experience of the employee, right? The age of the employee, all of that information. And I also have time spent in the current organization. And historically, I have information about, has this person quit? Yes or no? Yes or no? Right? I capture all of this information for historical data. So I have a historical set of data, and I have attrition, a column called attrition. I have a yes or no column. This is historically acquired data. That means right now, as I stand today, I'm going to pass information about whatever has happened in the last 2 years or last 3 years of data. And I'm going to pass this information into this whatever model, into this algorithm. Let's call it an algorithm, an ML algorithm. In this case, an ML classification algorithm, because I'm trying to classify if a record is going to be yes or no. So what this does at the background is it basically takes this data and it does some kind of it does some magic at the background. We'll come and we'll learn what that magic is. What this algorithm basically does is it firstly learns how to separate, or what kind of patterns lead to somebody staying back, and what kind of patterns lead to somebody quitting the organization. So it learns those patterns. So it says if the skill is so and so, if the salary is so and so, and if the experience is so and so, then the person is likely to leave the organization. If the person has not received a hike in the last 3 years, he's definitely likely to leave the organization. The person is likely, if has received a hike, extremely large amount of hike, and has a very good skill set, then he's also likely to leave the organization. So what this does is, based on the data that you've passed, it learns all those interesting patterns. So it sort of generates all those cool patterns, and it remembers all those patterns. Now, every time, now the next what you do is you pass a new record to it. Now you pass information of a new record to it, and this fellow automatically spits a yes or a no. It'll say, will this customer or will this employee quit or not? How is this fellow able to say this? How is this model able to say this? Because this fellow has learned patterns from historical information. This fellow now knows who is likely to quit and who is not likely to quit. So now if I simply pass just one of these records, it'll automatically predict if the person is likely to quit or no, yes or no. It'll simply make that prediction for us. This is all that we're going to learn. What we are going to learn as a part of our learning is we're going to learn how are these patterns really extracted. Okay, this could be a classification problem or a regression problem, whatever, it doesn't matter. So you learn from historical data and you try and predict what is likely to happen in the future, right? Based on, so you learn historical data, you pass the present data and predict for future. This is what is the whole ecosystem. Okay, so if I were to sort of visually show this to you in a much more visually appealing manner, this is how it works. So you input some raw data to it, to the algorithm. The algorithm goes back, right? You pass the training data set. We call this data set, this data set that I just showed you, this data set is called as the training data set and the outcome. You pass the training data set to it. The supervisor is simply nothing but the algorithm. So the supervisor learns how to distinguish between the categories. Yes, no, maybe, or whatever are the categories. It learns to distinguish these three. The moment it learns to distinguish all these three, now your algorithm is smart. Now this fellow has become really smart now. So now you simply, instead of passing raw data, you just pass any new record now. Now this fellow will simply be capable of putting it in any of these three categories. Right? That's a simple workflow of how a supervised learning model really works. Right now, what we're going to do is we're going to learn how we could automatically classify our data points. We're going to learn how a supervised learning ML model works. Okay. Quick differences between supervised and unsupervised learning models. Input and output variables will be given in a supervised learning model. I mean, let me put it this way. Nobody will give you the input variables. I would love to correct this. You will know what the output should be. Input has to be figured out by you. Okay, as in you the data scientist are supposed to figure out what the input variable should be. So if you're trying to predict if somebody is going to quit an organization or not, their shoe size is not going to be of any value. So you have to put on your thinking hat and you have to identify the right variables that will cause that particular outcome, or that could have any kind of causation to that particular outcome. Okay, labeled data is used. When I say labeled data, that means every record is pre-labeled, pre-tagged as a yes or a no. There's a target variable is already available. We call those as labeled data as well. The third one is training takes place offline and the training data should be available. Yeah, I mean, when I say training takes place offline, what that means is, learning is something that you can learn. I mean, training is something that can happen at the background. And once it is learned, you can sort of make use of those patterns and then perform some kind of predictions in real time. You can basically store those patterns and use those patterns for a later point. That's essentially what we mean by this over here. What is classification? Yeah, I mean, what an example for a classification, isn't it? The point is the idea of trying to put the right data point into the right bucket. Let's say if you're trying to predict, given a piece of garbage, which bucket it needs to go. That's classification. Your brain is trying to classify, right? That's essentially what classification is all about. Types of classification. These are a few examples. Logistic regression, decision trees, random forest, k-nearest neighbor, naive Bayes. As a part of our course, we're going to learn these 5 techniques. Decision trees and random forests and these are structurally very different techniques. I'm not saying these are the only 5 techniques. These are very popular techniques, 5 popular techniques, but mind you, there are a ton of other techniques as well. And I'm going to probably tell you what are the other techniques, and I'll tell you what you need to go back and learn as well. But at least these are definitely, as a part of the part of the course, at least these 5 techniques are available, and I'm going to concentrate on these 5. The idea, of course, is, for example, in the case of a logistic regression, what we are trying to do is we're trying to learn some kind of a line that classifies 0 and 1. Okay. So structurally speaking, what we are trying to do is, if you kind of think of, if I were to kind of give you a graphical, idea about what we mean by logistic regression, this is how it looks like. Let's say I have age, and I have, let's say, income. Let's say I have information about loan takers and non-loan takers. Okay, so right now what you see is the X's are the ones who typically take loans, and let's say the reds are the ones who are loan takers. Let me simply draw this here. This are loan takers, and non-loan takers. Right. The reds are the ones who take loans. The blacks are the ones who don't. The black data points that you see over here are the ones who don't take loans. So what a logistic regression tries to do is, I'm just giving you a very high level just painting a very high level, broad brush strokes right now. We'll dig into the details later on. But simply put, what what your logistic regression tries to do is it basically tries to draw that line, right? So it simply tries to draw a line that tries to classify your x's and your red points and your black points that you see over here. Okay. So when you draw a line that classifies and remember, this line will have its own equation, isn't it? This line will have its own equation. So this line will have an equation which says y is equal to, or rather something like, y is equal to mx plus c, kind of an equation this line is, right? And based on whatever you substitute in the age and the values of income, it will predict what the value of y is. So it will simply predict if the data point should be on this side or if the data point should be on this side. So simple. So we're just trying to identify what that line is, and based on that line, we try to predict if a data point falls on the other side or on this side. Okay, that's what a logistic regression simply is. We'll talk more about it later on. A decision tree, on the other hand, is slightly different. The decision tree takes a tree-like route. What it tries to do is it tries to kind of break your data into multiple parts. So it tries to extract minute patterns, right? Microscopic patterns. It says if the age is greater than 30 and if the person eats a lot of pizza, then the person is fit and person is unfit. If the age is less than 30 and the person does not eat a lot of pizza, then the person is fit. Age is greater than 30 and the person exercises every day, then the person is fit. Greater than 30 and he does not exercise every day, then the person is unfit. So if you observe, based on the age and if he or she exercises or not, and the person if he or she eats pizza or not.
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
I am trying to identify, so based on 3 features, I'm trying to identify if the person is fit or not. No, the output, what is the output variable here, everyone? What am I trying to predict here? Fit or unfit, exactly. So my input variable is age, pizza and exercises. I'm trying to predict if the person is going to be fit or not. Your input variable is age. Age is one of the input variables, not the only one. Okay, there are 2 others as well. I need to know if the person eats pizza and if he or she exercises or not. So we kind of create a tree-like structure to identify if we kind of classify the data point into a yes or a no, or a fit or unfit in this case. Okay. Instead of building one single tree, what a random forest does is, this is a tree. So what is a forest? A tree is a singular. So forest is many trees. So instead of building one single tree, I build many trees. Right? I build multiple trees, and based on all those trees, every tree is going to make a prediction, and based on those predictions, I take a majority vote in a way. That's what a random forest is all about. While a single tree tries to make a prediction, in the case of a decision tree, a random forest is many decision trees put together. That's what this is. And there's detail into it. Like for example, there's concepts like bagging and stuff like that. We'll learn that later on. But the idea is, instead of building one single tree, I can build many trees. Right? I can build many trees. I can extract many patterns. I let every tree predict, and based on what each tree predicts, I'll make a final prediction based on the voting that I do. Okay, simple. Yeah, this is one of the most simplest algorithms, k nearest neighbor. It's a very simple thing. So let's say, for example, I'll take a simple, I'll try to give you a simple explanation to this, and then you should definitely be able to understand. Let's say there is a class, right? And there are students who are being seated here, right? Let's say there are student 1, 2, 3, 4, 5, 6, 7, 8. Each of this is, let's say, a student, and this is a blackboard, whatever, blah, blah, doesn't matter. So now, if let's say I know the marks of this student, I know the marks of this student. I know the marks of this fellow. This fellow scored 25. This fellow scored 30, and this fellow scored, let's say, 28. How can I know the marks of this fellow? Let's say I don't know the marks of this person, and how can I? What will be my best bet for this person? Yeah, it'll be somewhere around between 25 and 30. How do you come up with that assumption? I calculate an average, right? Simply put, the idea over here is that if a particular person, if I don't know his or her information, my best bet is look at his neighbors. Right? I look at this fellow's neighbors. The nearest neighbors of this fellow are these three people. So based on this fellow's nearest neighbors, who in this particular case are this person, and this person, I'm going to try and take their details and compute an average of those three persons' predictions. That is exactly what a k-nearest neighbor algorithm is all about, right? So to take this one step ahead, what I'm simply going to do is, let's say there are two employees. I have the age, income, and let's say loan. Simple example. Age 25, income 40,000, loan, yes. Age 28, income 30,000, loan, yes. Age 30, age let's say 39, income 90,000, loan, no. And let's say I have a new person whose age is 25, or let's say whose age is 26, and this person's salary is let's say 42,000. Just saying, will this person take a loan or not? How do I compute this? Again, the idea is very similar. The idea is the age and income of this particular person are closest to whom? This person's age and income are closest to this fellow and this fellow. The two nearest neighbors are the first and second observations. This fellow is far away from this particular observation. Do you agree? Because his age is 39 and the salary is 90,000. But in this case, this fellow's age is 26 and the salary is 42,000. So the closest two neighbors to this fellow are yes and yes. So based on two nearest neighbors, my outcome is yes. Got it? Yeah. That is what you mean by k nearest neighbor, KNN algorithm. That's exactly what KNN is all about. There is more detail in how we compute who a nearest neighbor is. Right? Visually right now, because just there are two variables, I'm able to identify that the nearest neighbor of this person is the other two. But if, let's say, for example, I have 20 variables or 15 variables, then how do I compute who a nearest neighbor is? On what basis do I compute it? That's where we will probably take the help of a little more math. But the intuition is as simple as that. Right? There is a simple intuition. Okay, that's essentially what a k-nearest neighbor is all about. Okay. Then we're going to learn about something called as naive Bayes. Naive Bayes is a little more interesting. Naive Bayes is based on a concept called as Bayes theorem. And Bayes theorem is a simple probability-based algorithm. What this tries to do is it tries to give us information about what the outcome is going to be based on some kind of probabilities, right? For example, in this particular example, whatever you see is the probability that somebody gets a disease is 10%, and the probability that somebody gets a disease does not get a disease is 90%, right? And you can take this one step ahead. Simple, right? Let's say somebody has a disease. The probability that somebody has a disease is 10%. Probability that somebody has a disease is 90%. What we are trying to predict is the probability that somebody gets, the probability that somebody gets an AIDS, given that they have this disease. Let's say the disease is, let's say, pneumonia or whatever, I don't know. The probability that somebody gets AIDS, given that they already have a pre-existing disease, is 80%. The probability that they would not get AIDS, given that particular disease exists, is 20%. Similarly, Similarly, on the other hand, I have, let's say this is some other disease, let's say. I can come up with these conditional probabilities. We call these as conditional probabilities. So based on historical data, I can always extract these conditional probabilities. While in the earlier cases, I was just looking at data points and if they're near or not, and if they're close or not. In this case, what we're computing is we're computing probabilities. Right? We take the help of a simple probabilistic technique called as naive Bayes, and then we come up with these insights. Very popular technique, actually. Naive Bayes is one of the major applications of naive Bayes is search engines, right? Simply put, so take for example, if you kind of one of the applications of naive Bayes is when you use your mobile phones, right? Or let's say, for example, I'm doing some kind of a search. What is the best? So what is the best way to buy a laptop? What's the best tire for my car? So these are all type aheads. These are called as type ahead. So based on whatever word I type, I'm trying to predict what are my next few words going to be, right? So these are search engines. So naive Bayes is something which is very, very popularly employed in search engines and applications related to text and so on. So we'll learn about naive Bayes as also as another technique, a very popular technique and a very successful technique as well. Okay, so those are so broadly put, these are a few simple, I mean, these are broad brushstrokes, guys. You don't have, if you haven't understood any, if you haven't really understood any of these techniques, it's absolutely okay. We're going to dive deeper. This is just a very, very high level 1,000 feet view about what we are going to learn. Okay. Just like how we looked at classification techniques, this is a regression, and we kind of discussed about regression. If you remember, we kind of discussed about regression when we did our statistics session back in back probably a month or so ago. I don't even think it's a month, almost it's a couple of months ago when we did our statistics sessions. That's where we discussed about regression, right? And we spoke about a technique called as regression, where the idea is just like how we are predicting a discrete outcome like a yes or a no in classification. In regression, I'm trying to predict a numeric outcome. Okay, I'm trying to predict a continuous outcome. Like I'm trying to predict rainfall, I'm trying to predict the amount of sales, I'm trying to predict, let's say, the the revenue that a particular customer is going to generate in the next 1 year, or the volume of products that I'm going to sell in the next one month, and so on and so forth. So in all these cases, I'm trying to predict a continuous outcome, and predicting these continuous outcomes is what is typically referred to as a regression problem, right? Temperature, so look at this, predicting temperature as a function of number of cones sold at the street shop, and based on the rainfall, I'd like to predict how many cars will be sold, and based on the snowfall, I'd like to predict how many skiers are going to come. These are all interesting problems, right? These are all interesting problems to solve, and solving such problems wherever there's a numeric outcome is what is referred to as is what is typically referred to as regression. One of the regressions that we already spoke about was logistic regression. But if you remember, logistic regression is a classification algorithm, but for some reason we call it regression, and we'll talk about why it's called as regression, because logistic regression is heavily based on a very popular regression technique called as linear regression. And that's the reason, though logistic regression is a classification problem, it has the term regression in it. So that is one of the reasons why we have two broad techniques called linear and logistic regression. Primarily, we're going to learn about linear regression. So if you see continuous variables, categorical variables, solve regression problems, solve classification problems, straight line S-curve. Okay, the whole purpose of linear regression is again just to fit that one single straight line that can cut through all the data points. Like for example, if I have data that looks like this, if you take, for example, this is, let's say, yield of a crop, or let's say the rainfall and yield of a particular crop, whatever may be the crop, right? So historically, let's say I've gone ahead and I've collected this information across various years. So I've collected the amount of rainfall each year, and I've collected the yield of paddy or whatever may be the crop. I've collected all that information historically, and I've brought that information. I'm simply plotting it over here, right? Let's say I'm simply plotting all of that information over here. Clearly, what it is telling me is as the rainfall increases, your yield of the crop also increases. But let's say if I simply give you the amount of rainfall in a given year, if I simply give you the amount of rainfall in a given year, can you predict what the yield is going to be? Right now, with this, what regression tries to do is regression tries to come up with this particular prediction. It tries to come up with what this value is going to be. And the way linear regression does it is linear regression tries to fit that straight line across all your data points, and it fits that straight line in such a way that it is as close as possible to all the data points. And because this is a straight line, the straight line will have an equation which looks like yield is equal to 5 plus 10 times the amount of rainfall in a given year. I'm just saying. And it's a straight line, right? Straight line typically has a y is equal to mx plus c kind of a equation. So I can simply substitute the rainfall and I will be able to predict the yield. Simple as that. So what linear regression tries to do is linear regression tries to come up with that equation. This equation is what linear regression is going to do all.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Machine learning is a field of AI consisting of learning algorithms that A. improves their performance, B. at executing some task, C. over time with experience, D. all of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
But ideally, what we're doing in a linear regression is we're just trying to predict the yield based on the rainfall. In this case, just rainfall, but in reality, it can be just more than just rainfall. For example, instead of just rainfall, I have, let's say, a ton of other information as well: rainfall, quality of the soil. I have information around the amount of water that is available, the financial background of that particular farmer. I have information about the kind of fertilizer that was being used, and so on and so forth. The time when the seed was sown, blah, blah, blah. I have all of that information, let's say. So the outcome of this particular exercise is to predict a numeric value of the yield, a point estimate of the yield. I'm not trying to predict a yes or a no, fit or unfit, or good or bad. I'm not trying to predict anything like that, but I'm simply trying to predict a numeric outcome in this case. And hence we call this as linear regression. Hence we call that as a regression problem. And because we're fitting a simple single line or a linear equation, we call this as linear regression. That's it. It's a regression problem because I'm predicting a numeric outcome. It's linear regression because I'm trying to predict that numeric outcome via a single straight line, via a simple straight line or a simple plane, so to say. That is what we mean by a linear regression.
Common machine learning algorithms. Okay, so we will be discussing some popular algorithms that are useful for machine learning purposes. So basically, as you can see here, in machine learning, we are having two kinds of learning. Okay, the first one is the supervised learning, and the second one is the unsupervised learning. So what does supervised and unsupervised means? As the name suggests, supervised learning means that we are supervising our model. Okay, we are training our model on top of some data set. Okay, and after training our model, then we will try to predict, we will try to test our model. Okay, and we will see if our model is able to predict the future outcome or not. Okay, and if you talk about the unsupervised learning, so in unsupervised learning, we, as the name suggests, unsupervised means we will not supervise our model, we will not train our model. The model will get to know about the data set itself only. Okay, if you basically here we don't provide any learning to the model, to the machine. Okay, we will just provide a data set to the model, and after providing the data set, the machine, with the help of some algorithms, it can able to understand what the data set is trying to say. Okay, basically we will be analyzing the data. Okay, so let's discuss supervised and unsupervised in detail. So first, let's talk about the supervised algorithm. Okay, so in supervised algorithm, the first set of algorithm that we will talk about here is linear regression. Okay, so what is linear regression? See, basically in supervised algorithm, we are having two kinds of problem. The first problem is the regression problem. Okay, the second one is the classification problem. So what is regression and classification? If you talk about the regression problem, then regression basically deals with some kind of, you can say, continuous set of data. Okay, let's take an example here. If you're having some data set, okay, and in that data set, you are having some like a list of houses, okay, and then I want to predict what is the retail price of those houses. Okay, so the price, there will be a continuous set of numeric values only. Okay, so here we are talking about some regression problem, because we have to predict some numeric value, okay, of those houses. So that is why that problem come under the linear regression problem. Okay, so here we will talk about like we have to predict some value. Okay, some value that is not categorical. Okay, categorical means like if you're having some yes or no kind of value in your data set. Okay, let's suppose let's take an example. If you talk about some like if that particular customer is churning out of any company or not. Okay, so this is kind of a categorical set of values. Okay, but here in this linear regression problem, we will only deal with the uh, exact values. Okay, the salary of any person, or you can say the price of the houses. Okay, so this is what we talk about in linear regression. Only like they are having continuous set of values we have to predict. Okay, now if we talk about the other algorithm, that is the logistic regression. So as the name is have the logistic regression is having the name as regression, but in logistics we always work with classification data. Okay, the regression name is only present in the logistics part, but we always work with the classification problem. So what is classification here? Let's take same data set only. Okay, the data set that is having list of houses. So in logistic regression, we will try see there will be some retailed price of that particular house. Okay, let's suppose there is a house and that house is having a retail price as $10,000. Okay, so if with the help of logistic regression, we can calculate, or you can say the model can predict that that particular value, that particular house has been sold at a higher price or the lower price. Okay, if you talk that particular house is there. Okay, let's say house number 1 is there. Okay, and in house number 1, you want to like I want to predict, okay, that particular house has been sold at a higher price or a lower price. Okay, so this is what a categorical value is there. Okay, if it is sold at a higher price or a lower price. If you take another example, let's take heart disease data set. Okay, we are having heart disease. So there are many set of customers, many set of patients, the values, the data sets that is having all the value of the customers. Okay, so uh, for that data set, for the heart disease data set, we have to predict, okay, if I'm having these kinds of symptoms, then that particular customer is having heart disease or not. So this is also a kind of classification problem. Okay, because we have to calculate that either that particular customer is having heart disease or not. So this is a categorical value. Okay, so this is what we talk about in logistic regression. We always talk about the classification problem. Okay, that is the categorical values. Then again, our next set of algorithm in supervised algorithm is decision tree. Okay, so if we talk about decision tree, so as you can say, the decision tree means we will be talking about some tree structure here. Okay, So basically, a decision tree is also a kind of, in decision tree, we can work with classification problem also and regression problem also. Okay, if we want to calculate exact value, or we have to calculate the categorical value, that either that particular customer is having heart disease or not. Okay, so these things we can calculate in decision tree. So let's take an example for explaining the decision tree. So let's suppose there is a bank, okay, and that bank, like I want to build a decision tree so that how my model can able to like there are some customers that want to have their loan approval. Okay, so I want to build a model so that my model can able to analyze, okay, if this particular customer is coming to me and that particular customer wants to have a loan, okay, so if I give loan or not to that particular customer, okay, so it will build a decision tree. Okay, like it will see their past loan credentials. Okay, it will see, okay, that particular customer has paid the previous amount of loan or not. Okay, if he has paid, then okay, I will go to the yes part. Okay, I will go to the yes part, and then it will see, okay, if I'm having higher loan or lower loan. Okay, higher means like if that particular customer wants higher amount of loan or lower amount of loan. If yes, if that particular customer is having higher amount of loan, then it will not give the loan. If the particular customer is having lower amount of loan, then it will give the loan. Okay, so this is what decision tree is. It will make some decisions regarding the past history of the data. Okay, it will see the past data of those customers. Okay, so this is what our decision tree is. Then if we talk about our fourth algorithm, that is the random forest. So again, in the random forest, I'm having multiple sets of decision tree. Okay, so if we talk about the random forest, so basically random forest combines the output of multiple randomly generated decision trees. Okay, and it will give our final output. So basically, random forest is a group of decision trees. Okay, in decision tree, we will only build one tree only. But in random forest, we can make 100 trees or 300 trees or 400 trees. And with the help of all those trees, with the help of the combination of all those trees, we can able to predict, okay, if I want to give that particular customer a loan or not. Okay, so this is what our random forest is. If we talk about our naive Bayes, so basically guys, in naive Bayes, we will be dealing with some kind of like you can say data set that is having you can say in naive Bayes is also a kind of the classification problem. Okay, so naive Bayes basically deals with some probabilistic classifiers. Okay, so if I want to, you can say talk about, basically in naive Bayes we deals with some text classifiers. Okay, we will deal with some text kind of data. Okay, here in the linear regression, logistic regression, if you talk about decision tree and random forest, we work with some kind of data frames. Okay, but in naive classifier, we always work with some kind of text categorization. Okay, we are having some text kind of data. You can take all those texts in Excel format, and you can work with that data set, and you can able to predict your the whatever task you are having in your text data. Okay, so these are all kinds of common algorithms that we use in supervised learning. Okay, so guys, in this session we will be performing some hands-on in linear regression algorithm. Okay, we will see how our linear regression model is trying to predict our values. Okay, so let's jump on to the modeling part. uh, okay, so now guys, I am in my Jupyter notebook. I will work with the Python programming only. Okay, so let me first introduce with the data set, which type of data set we will use today. Okay, so as you can see here in my data set, I'm having two columns. Okay, that is years of experience and salary. If you work with some real world scenario data, okay, you will be having some multiple sets of column. Okay, so here for this demo, I will be only working with a small amount of data so that you can see that how your model is trying to predict the values. Okay, so we will be working with, here's the simple linear regression model. So here I'm having years of experience and salary. Okay, so I'm having basically 30 data. Okay, I'm having 30 number of rows in my data set, and all those rows I'm having as years of experience and salary. So if you take this data, if you take your first data, so in my first data, I'm having a customer that is having years of experience as 1.1 years. Okay, and that particular customer is having salary as 39,343. Okay, if you talk about the next customer is having years of experience as 1.3 years and salary as 46,205. Okay, so this is all about the data of a customer. Okay, all those customers are like there are 30 number of customers. The data is for the 30 number of customers, and I am having their respective salary. So I want to build a model because see here I want to predict a salary. Okay, with respect to years of experience, I want to predict the salary. So here my salary is a kind of continuous set of numeric value. Okay, so that is why we will use here simple linear regression algorithm. Okay, so okay, so first of all, guys, there are some rules that you have to follow while predicting your model or while building your model. Okay, so the first rule, the first you can say step for building your model is the analyzing the data set. Okay, you can analyze your data set with the help of various plots that are there. Okay, you can build a bar plot, or you can see you can build a scatter plot to analyze your data. You can see how the data is like how the data is working. Okay, after that thing, you have to see if you are having any NA values or missing values in your data set. If you are having those NA values or missing values, then you have to remove all those columns, not columns, you have to remove all those rows that are having some missing values. Okay, because see, if I'm having any missing value here in my data set, then my model will get confused. Okay, if I'm having 3 years of experience and the data is not given here, then my model will get confused. Okay, if what will be the salary if my data is not present there in my training data set. Okay, so that is why you have to keep this thing in mind, like before working with any data. Okay, if you're working in data science field, and if you are working with any kind of data, you have to make sure that you don't have any NA values, any missing values in your data set. Okay, so that process to remove all those things, that process comes under the data pre-processing part. Okay, then you have to select your dependent and independent variable. Okay, so what is dependent and independent? See, basically, dependent variable means the target variable. What variable you want to predict? Okay, what variable you want to predict? So here, I want my model should predict the salary value. Okay, with the help of years of experience, my model should predict the salary. So that is why whatever value you want to predict is your target variable, or you can say the dependent variable. Okay, so here my salary column will be the dependent value, and years of experience will become my independent variable. Okay, so let's go to the Jupyter notebook. Okay, so now I will discuss some basic libraries that we have to import before working with our before building our model. So first of all, I have imported my NumPy and pandas. Okay, so I have written import NumPy as NP, and then I have written import pandas as PD. So these are the two necessary libraries that you have to import for each and every data. Okay, for each and every model building part, because this pandas and NumPy will help you to first of all, it will help you to import your data set in this Jupyter notebook. Okay, and it will able to find out if you want to plot any graph, okay, or anything you want to do with the data set, like data manipulation or anything like that. You can work with the data set with the help of these two packages. Now we have to we have our data set. Okay, we are having our years of experience and salary. Now in order to build our model, okay, because see, I'm working with a supervised learning. So what is supervised? I have to train our model. So what we will do here is, it is the second step that you have, after defining your independent and dependent variable, then you have to separate your whole data set into training and testing part. Okay, so basically what you have to do is, from the whole data set, you have to separate your testing data and your training data set. So on the training data set, we will train our model. Okay, we will try to build our model, and on top of the test data set, we will just test our model. Okay, like suppose if you talk about let's take an example of examination. Okay, so there are unit tests are there. Okay, so what are unit tests? After each and every course completion, there will be some unit tests. Okay, then after completing all the units that are there in the course, then you will be having a final examination. Okay, so that unit testing, that we have to do, because we have to see if I have learned something or not from the course. Okay, so that is why here we will first train our model with the help of the training data set, and we will test our model with the help of testing data set. Okay, so it is you can say it has been suggested that to always split your data into 70 is to 30 ratio. So what does 70 is to 30 ratio means? 70% of the data will go inside my training data set. Okay, if you talk about this whole data, so from this 30 data, from this 30 records, my 70% of the whole data will go inside my training data set. Okay, and the remaining 30% of the data will go inside my testing data set, so that on top of the training data set, I can build our model. Okay, I can fit our model, and on top of the training, on top of the testing data set, I can test our model. Okay, so for splitting our data into train and test, we have to use a library, that is train underscore test underscore split package. Okay, this is a package name. So from where we will get this package? From the sklearn dot model underscore selection. Okay, so this is the parent package, and this is our main package that I want to extract. Okay, now after importing this package, now we have to basically build a linear regression model. So we have to import a linear regression model. This is the package name, linear regression. From where we will import? From sklearn dot linear underscore model. This is our parent package. From this package, I am importing my linear regression. Okay. Now, after predicting your model, after training our model, okay, now we have to also see the accuracy. What is the accuracy of our model? So you can use here, see, I have used here R2 underscore score package. Okay, you can also use your accuracy score package also. Okay, accuracy score package will also provide you with the accuracy of the whole model. Here I have used R2 score package so that I can able to find out what will be the accuracy of my linear regression model. So from sklearn dot matrices, I have imported my R2 underscore score package. Okay, so let me run this cell. Okay, now after importing unnecessary packages, now I will first import my data set. Okay, so I will import this data set only. That is, the name of the data set is data1. So I have written here pd.read underscore csv. So guys, pd here is the pandas package that will help us to import our data set. Okay, so pd.read underscore csv is the function. Inside this function, you have to write here the name of the data set. Okay, so I have written here my name of the data set, and I have stored my data. I have stored my data in the data set variable. Okay, so guys, if see, basically from where my pandas will able to fetch this package, this particular file. So in my home page of the Jupyter notebook, I have uploaded my data. Okay, I have uploaded my this data set. Okay, then my pandas will by default, my pandas package will by default take this directory. Okay, this is the working directory for my pandas package by default. Okay, so if you have not uploaded your data set on the home page of the Jupyter notebook, then what you can do here is inside this thing, you can just write the path of the file, and you also have to write the extension of the file also. Okay, so here you can just write here C drive, and wherever you are having this data set, you can just write the path here, and just also keep this thing in mind that you also have to write the extension of the file also. Okay, now after importing our data set, I have stored that in data set variable. Okay, so guys, see here my pandas, okay, my pandas package will by default save my data in this data set variable, and this data set variable is a kind of data frame. Okay, so guys, we never work with the actual data. Whenever we work in data science, we never work with the actual data. We always work with the copy of the data, and that copy is known as the data frame. Okay, so I have written a dataset.head. So guys, this head function will help you to fetch my top 5 records from the dataset variable. Okay, so if I run this cell, then you can see here I can view my top 5 records from the dataset. Okay, as you can see, I'm having years of experience and salary. Again, these are all the top 5 records from the dataset. Now, if we want to see what is my shape of the data, okay, what is shape basically means what is the size of our data, okay, how much columns and how much rows I'm having in my data. So for that, there is a syntax that is dataset.shape. So this is a syntax that will help you to get whatever number of rows and columns you are having in your data set. Okay, if I run this cell, so as you can see here, I'm having 30,2, which means I'm having 30 number of rows and 2 number of columns. Okay, now after this thing, now we will first, I have told you that you have to see if you are having any NA values or missing values in your data set. So as you can see here, I am working with small amount of data and I'm not having any NA or missing values in my data set. So I will skip this step. Okay, so if you are dealing with a huge amount of data, then you have to check if you are having any NA values or not in your data set. Okay, now after this thing, our first step was to not initialize, basically we have to see, we have to just see which is my dependent variable and which is my independent variable. Okay, so we have to declare our dependent and independent variable. So for that, see in my see, I have written here x and y as my variable names. So in my x, I will have my independent variable, and in my y variable, I'm having dependent variable, or you can say the target variable. Okay, so first of all, see in my independent variable, I want to have this years of experience. Okay, so for that, I have used here dataset.ilog. Okay, so what will ilog will do? Ilog will try to fetch my index value of the column. So basically, guys, see, if you talk about index value, index always starts from 0. So if you talk about this years of experience, then for this particular thing, I will have index as 0. Okay, because it is starting from years of experience and index always starts from 0. So the index value for years of experience will be 0 here. The index value for the salary column will be 1. Okay, so in my dependent variable, you can say in my target variable, I want to fetch my salary column. Okay, so what I have written here in my y variable, I have written a dataset.ilog. Now inside the ilog, you have to first keep this comma in mind. So what is this comma? Whatever you write before the comma is being represented as the rows. Okay, you want to fetch the rows, and whatever value you write after the comma is being represented as the columns. Okay, so basically guys, I want all the rows that I'm having in my data set. So I have written here colon. Okay, so colon basically means I want all the rows. Okay, and after comma, I have mentioned here 1. So 1 means it will only fetch my one value index of the column. Okay, so the first, see the index is starting from 0 here. So it is 0 and 1. So for the salary column, the value of the index is 1 here. So that is why I have written here 1. Now I want to initialize my independent variable also. Okay, So I want my years of experience. So in my X variable, I have written here dataset.ilog. Now after ilog, I have again written here colon. Colon means I want all the rows. Okay. And after comma, I have written here colon -1. So what this colon -1 means? Colon means I want all the columns, okay? Because colon means I want all the, if I write colon before the comma, which means I want all the rows. If I write colon after the comma, which means I want all the columns. So basically I want all the columns except for the last one. I have written here -1, which means it will extract all the columns that I'm having in my data set, and it will just extract only all the columns except for the last one, except for the salary one, because my salary is the dependent variable, is the target variable. That is why I don't want this column. I just want my years of experience. Okay. So that is why I have written a colon -1. Okay. Now, after defining our independent and dependent variable, let me run this cell. Now, after defining our dependent and independent, now we have to divide our data set into train and test set. Okay. So for that, we have to use this X train, X train, X test, Y train, and Y test. Okay, so guys, keep this thing in mind that you don't have to change this order. If you change this order, then you won't be able to build your model. Okay, this order will remain constant if you are trying to split your model into train and test set. First of all, you have to write your independent variables of the train and test set, and then the dependent variables of train and test set.
Okay guys, a quick info, if you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
Okay, now after defining all our train and test, now I have to fill all the values with X train, X test, Y train, and Y test. Okay, so for that, the function we will use here is train underscore test underscore split function. So from where this particular function will come? From the import train test split package. So from this package, our train test split function will come, and so inside this function, our first value that I have to pass here as an argument is the independent variable. Okay. So first of all, you have to pass here the independent variable, then the dependent variable, then you have to specify your train and test size. Okay. So train and test size. So basically, if I write here train size.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Which of the following are machine learning methods? A. Based on human supervision. B. Supervised learning. C. Semi-reinforcement learning. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I will be mentioning my train size, the training dataset size. Okay. So I want to split my data into 70:30 ratio. So my 70% of the data will go inside my train, and 30% of the data will go inside my test set. So I have mentioned my test size as 0.3, so that I have mentioned here my testing size. Okay. That is 30%, and the remaining 70% of the data will go to the train size. Now I have written here random state equals to 0. So what this argument means? This argument means that, see, let me first eliminate this particular code, then you will get to know what this random state means. Okay. So see, if I only write this thing, X and Y, and then test size equals to 0.3, then let me run this command. Now let me see what all values I'm having in my X train, X test, Y train, and Y test. Okay, so I will be just printing my X train, Y train, X test, and Y test. So if you see here, okay, my 70% of years of experience value has come under the X train. Okay, my 70% of the data, and my 70% of the salary column. Okay, my 70% of the salary column will go under the Y train. Okay, and if you talk about the X test, then my remaining 30% of the data will go inside my training size. Okay, the training data set. Sorry, not training, testing set data set. Okay, and the remaining 30% of the salary column will go to the Y test. Okay, that is the salary column of the testing data set. Okay, so guys, again, let's suppose I have again run this command. Okay, if I again run this command, and just keep this thing in mind that our first value is 2.2 for the X train. Our first value is 2.2. So if I run this column again, then as you can see, I am getting random set of values. Okay, I'm getting random set of values in my X train, Y train, X test, and Y test. I'm not getting any constant set of values in my training and testing data set. So that is why, in order to get a fixed amount of data, not amount of data, fixed value of data in the X train, Y train, and X test and Y test, we have to write here, we have to mention here random state as 0. Okay, because see, by default, the value of random state will be null. So what this means is that you will be getting your random set of data set, but I don't want to have my random state of data set, because see, if you are having random state, okay, if you are having randomly data set, then your accuracy will get affected. Okay, so if you don't want to have you can say varying accuracy, then in that case you have to use random state as 0. Okay, so if I again run this command, and if I again run this command, so our first data for the X train is 7.9. Okay, if I again run this cell and again run this cell, so again I will be getting a fixed amount of data only. I will not get any randomly selected data. Okay, I will get a fixed amount of data. Now, after splitting our data into train and test set, now we will be fitting our model. Now we will be training our model. Okay, so first of all, what we have to do here is we have to call a linear regression function. So from where I will get this function? From the linear regression package. Okay, from this package I will be getting my linear regression function. So linear regression function, I have called this function and I have stored all these attributes in my model variable. Okay, so basically guys, here my model variable is having all the algorithms that are related to the linear regression model. Okay, now after creating our model of the linear regression, let me run this cell. Now we will be fitting our model, we will be training our model. So which model we have to train? We have to train this particular model of the linear regression. So we will be training our model on top of the train data set, because we always train our model on top of the training data set. So I will use here first of all the model name, that is my model dot fit function. Okay, so guys, this fit function will help you to train your model on top of the training data set. Okay, so model dot fit function, and you have to pass here your X train and Y train, whatever training values you are having in your data set. Okay, so you have to pass your X train and Y train inside the fit function. Now if I run this cell, so as you can see, the output is coming as linear regression and all these attributes are there. Okay, so guys, see this, these all attributes are by default attributes that my model is having. Okay, so you don't have to worry about these things. You have to just see what values my model can predict. Okay, you have to see the predicted values. Okay, because we have trained our model on top of these attributes. Okay, so these are the by default attributes that I'm having in my linear regression function. Okay, now after training our model, now we will just see first of all what is the actual value of the columns. Okay, so in my X test, I'm having my like the 30% of the years of experience. Okay, so if you talk about this 1.5 year, so this is the years of experience value, the remaining 30% of the data set for the years of experience. Now after training our model, okay, this is for the training our model. Now we will be predicting our model. Okay, So we always predict our model on top of the test set. Okay, so what is my test set? On what value my model will predict? On top of these values only. Okay, because this is my testing data set. So on top of these values only, my model will try to predict, okay, if the customer is having 1.5 years of experience, then what will be the salary for this particular customer? If my customer is having 10.3 years of experience, then what will be the salary of this particular customer? Okay, so the model name dot predict function. Okay, so inside this predict function, now I have passed here my excess, that is my the 30% of the data set, okay, for the years of experience, because on top of these values only my model can able to predict the value. Okay, and after predicting my values, I'm storing that in y pred. Okay, so if I run this cell, then you can see here it has predicted these values. So what are these values? These values are the salary. So if the customer is having 1.5 years of experience, then my model has predicted that for the first customer, the salary should be 40,817.7. Okay, this is what my model has predicted. If you want to check the actual value, what is my actual value? So let me just add a cell here and I will just write here the actual value. So where my actual value is having, my actual value is present in my y test. Okay, so as you can see here, let me show you. Okay, in my y test, okay, I'm having the 30% of data. So this is my actual value. If my customer is having 1.5 years experience, then in my data set, in my original data set, if my customer is having 1.5 years experience, then the salary is 37,731. If my customer is having 10.3 years of experience, then that particular customer is having 1,22,391 salary. Okay, so these are all the actual values. Okay, these are the actual values, and my model has predicted these values. So if you talk about the first data for the 1.5 years of experience, my model has predicted that that particular customer should have salary of 40,870, but the actual value was 37,731. Okay, so as you can also compare your second value also, okay, your third value also. So it has predicted these values and the actual value was these. So by comparing your actual and predicted value, you can able to see, okay, it has predicted somewhat correctly. If you talk about the second data, your second data, the model has predicted that if my customer is having 10.3 years of experience, then my model has predicted that the salary should be 1,23,180, but the actual value was 1,22,391. So it is somewhat matching. It is not exactly matching, but it is somewhat matching. Okay, so this is what you can analyze from the data. Okay, that okay, my model has predicted, but it has not predicted correctly only, but it is somewhat near to the correct value. Okay, near to the actual value. Now after predicting our data, now we will just find out the accuracy. So for finding out the accuracy, we will use here R2 underscore score function. Okay, and inside this function, I have first passed here the actual value. The actual value was in the y test. Okay, and then the predicted value, that is whatever values your model has predicted. Okay, so the actual value will be there and then predicted value will be there. And after this thing, the accuracy is 97%. Okay, so for this kind of data, the model has accuracy of 97%. So you can use this particular model for finding out your future outcome, because you are having accuracy more than 95%. Okay, so you can use this particular model for for building your future outcome. Okay, so guys, this is all about the simple linear regression part. Okay, so let's suppose from the data, okay, I'm having these kind of data, and let's suppose I want to predict that if my customer is having 6 years of experience, then what will be the salary of that particular customer? Okay, so for that we can use this predict function. Okay, because see, I have trained our model, and with the help of predict function, I can test our model. Okay, so here I have passed here my x test, but now I'm having my own value. Okay, I'm having my own value that I want to predict what salary will be there if I'm having 6 years of experience. Okay, so for that, first of all, I have to write here the model name, that is model dot predict function. Okay, now inside the predict function, now guys, see, I'm only having one value, that is the years of experience. So I have to pass the value as a array. Okay, so guys, if you see here, if you check out the x train, x test, y train, and y test, all these values are in the form of array. They are not in the form of data frame. What is data frame? Data frame is a kind of this kind of structure. But I'm having all these values in the kind of array because I can only pass the array values inside my predict function. Okay, inside my predict function, I can only pass the array values. So that is why, in order to predict a new set of data, I have to pass the array value. Okay. So what I have written here, np.array. I have created an array here, np.array, and inside this I have passed here 6 years of experience value, because on top of this data set only, I want to predict what will be the salary of this particular customer. Okay, so I have written here the data. Now, after this thing, I have written here dot reshape minus 1 comma 1. So guys, what this reshape minus 1 comma 1 means? See, basically I'm only having one kind of data. Okay, I'm not having here 2D kind of data. As you can see here I'm having two-dimensional data. I'm having multiple set of rows and only one column. Okay, so this is a kind of 2D data. But here I'm only having 1D data. Okay, that is 6. So I'm only having 1D data, one-dimensional data. So that is why, in order to convert this one-dimensional into a two-dimensional array, I have used here reshape function, and inside this reshape function, I have passed here minus 1 comma 1. So this whole syntax will help you to convert your one-dimensional array into a 2D array. Okay, so it will convert my 6 value into a two-dimensional array so that I can pass that particular two-dimensional array in my predict function, and it can predict whatever salary I can have if I'm having 6 years of experience. If I run this cell, so as you can see here, my model has predicted that if the customer is having 6 years of experience, then that particular customer should have a salary of 82,938. Okay, 0.95. So this is what you can able to predict. Okay, if you are having your own kind of data and you want to predict, you can just call the predict function, and inside this predict function you can just pass your values. Okay, if you are having only 1D array, then you have to reshape your array as this thing, as a two-dimensional array. Okay.
So this is a problem statement, guys. Okay, so this is a customer churn data set. Okay, the details regarding this customer data set are present in this data dictionary. Okay, so this is nothing but a data set here. Okay, so guys, you see the first question is nothing but data manipulation. Okay, so first we have to extract the fifth column and store it in the customer file. Okay, so first we'll import the respective packages, guys. Okay, as pd. Okay, so with the help of this pandas package only, we can able to import our data set here. Okay, so data pd.read csv. Inside this, you just pass on the name of the customer churn dataset, customer churn one.csv. Okay, so first one is the thing but data manipulation. Okay, so guys, what we have to extract the fifth column. Okay, so first we'll have a glance at our data set. Okay, so data.head. So this is our data set, guys. Okay, so we have to extract the fifth column. Okay, so what is the, can you tell me what will be the index value of the fifth column? it's 4. Okay, so index value of the fifth column is 4 here, and we have to save it the customer 5. Customer 5 equals to data dot ilog. Since we are using the ilog function, since we are using the index value of the row, we need to, like, since we are using index value of the row, we are extracting those rows, we are using this ilog here. I'll give comma, before comma represents the rows and after comma represents the columns. Okay, so we have to extract the fifth column here, so I'll just give 4 here. Okay, and when I try to execute customer 5, so this is nothing but the fifth column, guys. Fifth column is nothing but 0 1 2 3 4. So dependence is the fifth column, guys. Okay, so you can see everything low. Cool. So what is the next question? So we have to extract the 15th column. What is the column for 15? What is the index value of 15th column? So it is nothing but the 14 here. Okay, so data dot ilog comma, before comma represents a colon, and after comma you have to give the respective index value of the column. Okay, so then it's customer 15. So this is nothing but the 15th column, guys. Okay, so next is nothing but, so extract all the male senior citizens whose payment method is electronic check and store the result in the senior male electronic. Okay, so guys, if you carefully look at this question, so we have around 3 columns. Okay, so we have around 3 columns present inside this in this question here. Okay, first column, so like column 1 is nothing but the male column, then senior citizen column, then the payment method column. Okay, so we have around 3 columns present in this question here. Okay, so yes, again we'll have a look at our data set, guys. Okay, cool. Okay, so what we have to do is, we have to, the question says we have to extract only male senior citizens. Okay, that too whose payment method is electronic check. Okay, so male senior citizen. Okay, so and we have to save it in the senior male electronic. Okay, so senior male electronic. Okay, so then what I have to do is, I'll use data. So first column I will take is nothing but the gender column. Okay, so what is I'll just copy it, I'll paste it. Okay, so gender equals to male. So guys, make sure you give the correct spelling there. Okay, so male. Okay, so we have to extract the customers who are male and then senior citizen. Okay, so I'll use under operator, then data of senior citizen. Okay, so if senior citizen is equals to 0 means they are not a senior citizen. If it is 1 means they are senior citizens. Okay, so I'll just give equals 1, and I'll give again and here. Okay, then what you have checked, we have to check whether the customer's payment method is electronic check. Cool. So I will just give data of payment method. Okay, so payment method equals to, we have to give the exact spelling of electronic check. Okay, so this one, I'll just copy it, I will paste it here. Okay, so we have included around 3 columns, guys. Okay, so we need to extract the customers whose gender is male, and then they are, whether they are senior citizen, then their payment method is electronic check. Okay, so I am using this AND operator because it should satisfy each and every condition here. Okay, so now when I run the senior male electronic, okay, so yes, guys, so we have around 298 customers, guys. So this is nothing but the output, guys. Okay, so we have around 298 rows here. Okay, so when you check, like when the gender is male and then the senior citizen is 1, okay, then you can check like their payment method is electronic check. See, each and every customer's payment method is electronic check. Okay, so I'll copy this code and I'll paste in the chat window, guys. Okay, cool, you guys can check it out. Cool, Brajesh, are you getting any error here? So okay, so for For senior citizen, you have to mention only one. Okay, so don't take it inside the double quotes. Okay, Vitesh, just remove those double quotes here. Just give one there. Okay, this one. So guys, is everyone done? Okay, so we'll move on to the next question. Okay, so next question is nothing but you have to extract all those customers whose tenure is greater than 70 months or their monthly charges is more than $100. Okay, so guys, can you tell me how many columns are included in this question? So whose tenure is greater than 70 months or their monthly charges is more than 100. So in the before question we had around 3 columns. Can you tell me how many columns we have this? Yes, Ashwini, yes, Chirag. Yes, guys, cool. So we have around two columns in this question here. Cool, guys. So I've just again gave data.head because we don't need to scroll back again so to check the column name. Okay, so that's why I'm just giving data.head again and again. Okay, so which way we have to save it? We have to save it in the customer total tenure. So customer total tenure. Okay, so data, sorry guys, so data of, so what is the first column we have to check? Whose tenure is greater than 70 months. Okay, so this is tenure. I'll copy paste it. Tenure is greater than 70. Okay, and we'll give this inside a function bracket because we have 2 columns to check. Okay, so the question is either you can see either tenure is greater than 70 or, okay, so we have to use the or operator here, or their monthly charges. Okay, we'll copy paste the monthly charges name, or their monthly charges is greater than 100. Okay, so what we have done here, we have just said like either tenure is 70 or else monthly charges is greater than 100. Okay, so let's have a look at our data, our total tenure. So we have around 1259 customers whose tenure is greater than 70. Okay, either here since like it's not greater than 70, but when you look at the monthly charges, it will be more than 100. Okay, if this condition fails, automatically it will check for this condition. Okay, whether this condition gets true or false. Okay, so even if both the conditions satisfies, we'll add that record into customer total tenure. Okay, so if you look at this customer, for this customer they have tenure greater than 70 and their monthly, but when you look at the monthly charges, it is only 21 year. Okay, since this condition got satisfied, we're adding that customer's details to customer total tenure here. Okay, so guys, can you able to get it? Okay guys, so guys, I'll move on to the next question. Okay, so next question is extract all the customers whose contract is of 2 years, payment method is mail check, and the value of churn is yes. Okay, so how many columns are there in this question, guys? How many columns you have to check here in this question? Yes, Mugdho. Yes, Leela. Yes, Ashwini. Cool. Yes, Chirag. So we have to check 3 columns here. Okay, and we have to save it in the to mail s. Okay, so to mail s. Okay, so I will just give data of. I'll check data of. What is the first column you have to check? You have to check the contract column. Okay, so what is the, we'll do one thing, guys. Data dot text. Okay, cool. So for the contract column, where is the contract column here? This one. So either contract column should be 2 years. Okay, 2 years. Okay, so 1 year, if you look at the 1 year, only caps. So in this way, I think 2 years will be 280 will be the caps here. Okay, so either contract should be 2 year, like, and then payment method is mail check. Okay, so data of payment method. Okay, so data of payment method is mail check. Mail check. Okay, so then what have to do? And we have to check whether churn is yes or not. Okay, so churn, I think, is the last column. Okay, so data of churn equals to yes. Okay, so we'll try to execute this line to mail yes. So when I execute this line, payment method, I think I have done. Okay, cool. So we have around 3 customers, guys. Here's Samandeep, who I've done before. It's cool. So we have around 3 customers, guys. Okay, whose contract is 2 years, and then their payment method is mail check, and their churn is yes. Okay, so we have around 3 customers here. Okay, so we'll move on. Wait a second, let me share the code, guys. Cool. Okay, so next question is we have to extract 333 random records from the customer churn data frame, store the result in customer 333. Okay, 333. So guys, what I have to do is we have to just simply extract 333 random records, guys. Then we have to store the customer 333. So customer 333 equals to, we will be using a sample function, guys.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Machine learning is a field of AI consisting of learning algorithms that A. improves their performance, B. at executing some task, C. over time with experience, D. all of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so this will gives you extract random sample records, guys. So inside this, you just give the attribute, like how many sample, like how many random records we need. Okay, so customer 333. So guys, now you can see we have around 333 records here. So for this, we have been using the sample function here. Okay, so with the help of this sample function, we can enable to extract the 333 random records here. So inside this, you just need to give this 333. Okay, let's move on to the next question. So next question is nothing but we have to get the count of different levels from the churn column, which means you have to check like what are the different levels are there in the churn column and how many respective count values are there. Okay, so for that, what we can use here is we can use a value counts function here. So I'll just give data of churn dot value counts. So these are the different levels. Okay, so we have no, then yes. Okay, so we have around 5,174 customers whose churn is no, and we have around 1,869 customers whose churn is yes here. Okay, so the question is we have to get the count of different levels from the churn column. So for that, we'll be using value counts function here. What you have to do is, for first question is, yes, you can be able to get the count here. With the count, we are also getting the like mean value, standard deviation value. Okay, so guys, we'll move on to the first question. Okay, so in this data visualization, we have to do around 4 questions, guys. Okay, so first question is we have to build a bar plot, then second one you have to build a histogram, then scatter plot, then box plot. Okay, can anyone tell me what is the package that we have to import for data visualization? What is the respective package that we have to import here? So what have to do? We have to import the matplotlib package here. Cool. Okay, so with the help of this package, we can do all these questions, guys. Okay, so again, we'll have a look at our data set. So the first question is, we have to build a bar plot for the internet service column. Okay, so first for bar plot, first we have to split the column into X and Y. Okay, so for that, what we have to do is, for first we will have a look at our internet service column, like what are the different levels are there. Okay, so internet service dot value counts. Okay, so guys, this is our internet service. So we have around 3 levels here: fiber optic, DSL, and no. Okay, so now what I will do is, in our bar plot, this fiber optic, DSL, no should be plotted in our x-axis, and then the respective count on the y-axis. Okay, so to extract this fiber optic DSL no, what I will do is, I will just create a new column, data of internet service dot value counts. From this, what I will just do is, I will just take the keys here. Okay, so dot keys nothing but it will just take only the respective keys here. Okay, so from this entire data, it will just take the respective keys here. Okay, so when I run the X value, see, I can able to get this fiber optic, DSL, and no here. Okay, now in my y-axis, y variable, what I will just do is, I will just I need the respective count values there. Dot value count. So here, what function I will use is, I will use toList function here. Okay, so what this toList function do is, it just take the numbers here. Okay, so it will accept only the numbers, so it will take only the respective count values: 3096, 2421, 1526. So when I execute the y value, see, I can able to get the expected count values alone. Okay, so right now my x variable has these fiber optic DSL no, then my y variable will have this 3096. Okay, so without any delay, now we will start plotting our bar plot here. Okay, so for that PLT, what is the function name that we use to plot the bar plot? PLT dot. So we'll be using the bar here. So PLT dot bar. Yes, Muthu. Cool. So PLT dot bar, and inside this, I'll just pass on the x and y variables here. Okay, and I'll just give the show, because it will just show me the respective bar plot. Okay, guys, so this is nothing but our bar plot. Okay, so bar plot of internet service column. Okay, so when we have to set x-axis, label should be categories of internet service. So plt.x label should be categories of internet service. Then what is the next question? Y-axis label should be count of categories. Y-axis label should be count of categories. Then title should be distribution of internet service. Okay, so plt.title should be distribution of internet service. Okay, so then we have to set the color of bars to be orange. Okay, so to set the color, we have to give inside this bar function only. So color equals to, what's the color they have mentioned? There's to orange color. Cool. So I'll just give orange here. So when I execute it, so guys, I think you can able to see the title, and then I have also assigned the y-axis label. I also assigned the x-axis label. Okay. Moreover, I have colored my bar plot as orange color. So this is nothing but a final bar plot. So we'll move on to the next question. Okay. So here our next question is nothing but a histogram. Okay. That too we have to build a histogram for tenure column. Okay. So function name to build the histogram is dot hist. So guys, as you told, to plot the histogram, the function name will be using nothing but a plt.hist here. Okay, so for which column I have to plot the histogram? For the tenure column. Cool. tenure column. So guys, this is nothing but the histogram here. Okay, so we'll look at the next set of questions. Okay, so we have to set the number of bins to be 30. So to set the bins, we have to give here only bins equals to 30. So now we have set the bins equals to 30. Then cool Karthik. Okay, then we have to set the color to be green. Okay, so then I'll just give color equals to green. Then what I will do, I'll just assign the title should be distribution of tenure here. Okay, so for the title, I'll give plt.title distribution of tenure. So guys, this is nothing but my final output, guys. Okay, see, I have assigned the title to my histogram. I have set the bins to be 30. Moreover, I just changed the color to green here. Okay, guys. So this is nothing but the histogram here. So from this histogram, like what we can conclude is like we have around like, so when you look at the customers, like we have around like 0 to 1 2 3 4 5. Okay, so we have around 2 customers whose tenure is more than 800. Okay, so we have around 2 customers who has a tenure of more than 800. So likewise, we have to analyze this tenure here. Okay, so how we can analyze this, from this what we can say is, so we have around like 800, more than 800 customers whose tenure is 2 years. Okay, I'm sorry. Okay, so like we have around more than 800 customers whose tenure is 2 years. Okay, so like whose tenure is between like 0 to 2 years here. Okay, so like that we have to analyze it. So guys, like shall we move on to the next question? Okay, what we have to do is we have to build a scatter plot here. Okay, between monthly charges column and the tenure column. Okay, then here we have to map monthly charges to the y-axis, then tenure to the x-axis. Okay, so guys, now what is the function name we will be using for plotting the scatter plot, guys? Yes, actually, yes, Chirag. So we'll be using dot scatter here. Okay, so plt dot scatter, detail x. Okay, tenure should be on the x-axis, and then monthly charges on the y-axis. Okay, so tenure should be on the x-axis, data of tenure, then monthly charges on your y-axis. Is that right? Yes, monthly charges on your y-axis. Okay, and one more thing, guys, like I will plot scatter plot only for my first 20 records here. Okay, so why I'm taking first 20 records means, so if I try to execute scatter plot for my entire data set, it will take huge time to compile each and every data here. Okay, since like it will take too much time for me to execute this line type. So that's why I'm just trying to plot this scatter plot for my first 20 records. So that way I've used this dot head of 20, then dot head of 20 here. Okay, so guys, if you like in case of my system, it'll take huge time. Okay, since like spec is not up to the mark, so that's why it will take so much time. If you guys have higher spec in the system, means you can execute without dot head of 20 itself, no problem. Okay, so then I will just give cool Amari. Then you think like you have pretty much good spec, I think so. plt dot scat, plt dot show. Okay, so this is nothing but my scatter plot, guys. Okay, then we have to assign brown color to the points. So I just give color equals to brown. Then x-axis label should be tenure of customer. I think as since it's a huge record, like it will be in the dense. I guess so. Scatter will be so dense. So axis monthly charges of customer. My label monthly charges of customer. Then title should be tenure versus monthly charges. So title should be tenure versus monthly charges. So guys, this is nothing but my final output, guys. Okay, for my first 20 records, not for my entire data set, for my first 20 records. Okay, so this is a monthly charge scatter plot of tenure versus monthly charges. Okay, see here I have assigned the title here, then I also assigned the y-axis label, I also assigned the x-axis label here. Okay guys, so this is nothing but a scatter plot here. So next question is, we have to build a box plot between tenure and contract column, guys. Okay, so we have to map tenure on the y-axis and then contract on the x-axis here. Okay, so we'll try Seaborn for this, guys. Okay, we'll try to plot box plot in in Seaborn package, so that will be more colorful. For Seaborn as SNS. So SNS dot box plot x equals to data. Okay, so for x-axis, what have to do? Have to cool session tab, no problem. Contract on x-axis. Then for y-axis, there's nothing but the tenure here. Okay, so is equals to data of tenure. So I'll just give plt dot show here. So guys, this is nothing but my box plot, guys. So we can also go with the normal one also. So this is a box plot, okay, without using Seaborn package, guys. Okay, I'll just reduce it to 7,7. And thank you, Shishanta, for the code. So this is using Seaborn. This is using like without using Seaborn, guys. So guys, tell me once you guys are done with this box plot here. So now we'll jump on to the linear regression. Okay. So guys, now we are into the third part of our project session, guys. Okay. So just something but we have to build a simple linear model. Okay, so where a dependent variable is monthly charges and then independent variable is tenure here. Okay, so first we'll import the respective packages, guys. Okay, so guys, now tell me what is the package that we have to import to split the data, guys. It's like to split the data into training set and testing set. So yes, guys, the function name we have to use is train test split function here. Okay, which helps us to split our data into training set and testing set. Okay, so from Scikit-learn dot model selection, I'll be importing train test split function. Okay, so now what I do is, so guys, for to build linear regression model, so what package we have to import, guys? Like what class, what package and what class we have to import? Yes, Munda. So we have to import the fit function. Okay. So for that fit function, like to build the linear regression model, what class we have to import here? Okay. So we have to import linear regression class here. From linear model, we have to import the linear regression class. Okay, so from linear model package, what I am importing? We are importing this linear regression class. Okay, so we need fit function to build the model, right? But that fit function is present inside this. If we are using the fit function from linear regression class, we will be building the linear regression model. Okay, so I hope you guys can understand. So now
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
we have to okay, so we'll now have a look at our data set again. Data dot get. Okay, so what you have to do now is our dependent variable is monthly charges and our independent variable is tenure, right? So I told you like independent, while building a model, independent variable should be in a 2D format. Okay, so I will create x variable I will tell you one more way to take the independent variables, guys. So we can take either with the help of dot values, else we can also take the variables in this way also, guys. So pd dot data frame data of tenure. Okay, so we can also take a independent variable in this way also, guys. Okay, so our model accepts, like our algorithm accepts a variable in this way also. Okay, then a dependent variable, as I told you yesterday, dependent variable, it can mean anything, no problem here. Okay, I'll just take it as data of monthly charges. Okay, so right now X has this independent variable, then Y has this dependent variable. Okay, so now what have to do, we have to divide the data set into training and testing sets. Okay, in 70:30 ratio. So what we will do here is we have to create 4 new variable, x train and x test, then y train and y test. Okay, yes, we can take a data of data dot monthly charges also. Okay, so y train, y test, x train, x test, and y train, y test. Now train test split. Okay, so here what we'll do here is I'll just give x and y values, guys, here. Okay, x comma y. Then we have to give the, either we can give train size or else we can give the test size, guys. Okay, so I will give the train size as so actually I have to divide a data set into 70:30 ratio. Okay, so either, guys, you can give train size equals to 0.7. So either you can give the train size equals to 0.7 or else you can give test size equals to 0.3. Okay, it's your wish. You can give either train size equals to 0.7 or else you can give test size equals to 0.3. Okay, so then I'll give random state equals to 0. So now, guys, we have successfully splitted our data set into 4 variables. Okay, so 70% train size. Okay, 70% of my x data should be saved in the x train, and the remaining 30% test size, remaining 30% of my x variables should be saved in the x test. Okay, same thing for y also. 70% of my y data should be saved in the y train, and the remaining 30% of my y data should be saved in the y test here. Okay, so we'll have a look. Data dot shape. Okay, so guys, now you can see, so this is data is nothing but a original data. Okay, for that we are around 7043 rows here. Okay, but in the case of x train, we took only 70% of original data, so that is nothing but we have around 4930. And for the x test, we took the remaining 30%. Okay, so that is nothing but 2113. Okay, so same thing, sir. So same thing, guys. So for y train we have around 4930, and then for y test we have around 2113 here. Okay, guys, so we are done with this part. So now what I'll do is we have to build the model on train set, and we have to predict the values on test set. Okay, so that is simple. So with the help of train set, we'll be building the model, and with the help of test set, which is nothing but x test here. Okay, with the help of test set, we'll be predicting the values here. Okay, so now what I have to do is we have to build the model on train set. So to build the model, so guys, can anyone tell me what is the function that we using which helps us to build the model? Yes, guys, cool. Okay, so but we can't take that fit function directly, right? So who help us to take that fit function from that linear regression class? Like who we have to create? Yes, Ashwini. Yes, guys. So we have to create a object here. With the help of that object only, we can able to retrieve that specific function from the class. Okay, let my object name be LR. Okay, so let my object name be LR. Oh, LR equals to linear regression. So I have successfully created the object here. So LR dot fit. Okay, is your x variable name is capital X here or small x. So guys, into this fit function, we have to pass on the training set or testing set, guys. Yes, guys. So it's nothing but x train, comma, y train. So now we have successfully built the model. So our next step is we have to predict the values here. So for that, whom we have to pass on inside. So which variable you have to pass on, guys, into this predict function? X test. Yes, Akshay, cool. So we have to pass on the x test value here. Okay. So now we have the predicted values also. Okay. So we'll have a look at our predicted values. Y test. Cool. Okay. So guys, can you able to see? So guys, now you see this is the original value 58.2, but our predicted value is 60.95. So there's little bit fluctuations there. For second value, original value is 116, but the predicted value is 72. So it's not near also. So for third value, it's 71.595, but our model predicted is as 59.6.90. Okay, so no problem with that. Okay, guys, so we have built the model on train set, then we have predicted the values on the test set also. Okay, so our next question is, after predicting the values, find the root mean square error. So find out the error in prediction, store the result in the error. Okay, so find the root mean square error. Okay, so guys, for all these three questions, the agenda aim is same, guys. So what I have to do is we just need to find the error in root mean square error, guys. Okay, so fit missing to required position. So x train, x test, y train, y test, train test with x y. Okay, no problem. So and this line, whether you check you have passed these two variables here inside this fit function, just share this line of code. I think for x train, I think you have gave the capital X in the x train. I guess so. So guys, here what I'll do is for these three questions, we have only one thing to do. We just need to find the root mean squared error. Okay, so but the thing is like we doesn't have direct function to find the root mean square error, so but we can find the mean square error value. Okay, so we have direct function to find the mean square error value. Okay, so after finding a mean square error value, we'll just find the square root of that value, so that we can get the root mean square error there. Okay, so for that we'll just import the respective packages, guys. Okay, so from Sckit-learn dot metrics, I will be importing the mean squared error function. Okay, so after finding the mean square error value, I'll just find the square root of that mean square error value, so that I will get the root mean square error value. Okay, to find the square root of the value, we need to import the numpy package, guys. You have to import this package here. So only with the help of this numpy package, you can have to find the square root there. Okay, so I'll create MSC here. So MSC equals to, I'll just find the mean square error first. Error inside this, I'll just pass on the y test and y pred values. Okay, so now what I will do is I will create new variable called error. Okay, error. Okay, I will create new variable called error. Now with the help of numpy package, I will use this xqrt function. Okay, that is nothing but take the square root there. Inside this, I will just pass on the MSC value here. Okay, so my root mean square error value is 29.3945, guys. Okay, so this is my root mean square error, guys. Okay, so what I've done is I'm trying to find the mean square error value. Then I'm just trying to find the square root of the mean square error value, guys, so that I'll get the root mean squared error value there. Okay, so guys, what is the values you guys are getting? I think you will also get the same value. I'm not sure. So this is the root mean squared error value, guys. So guys, lower the error value, better the model. Okay, so the error rate is 29.3. If it is too low, I means we can say it is a good model. Okay, if it is below 15 or 10, then we can say it is a good model. Okay, So our next question is logistic regression, guys. Okay. Okay, guys. So now we'll move on to the logistic regression here. Okay. So guys, for logistic regression, what package we have to import? So we have to import some Sckit-learn dot. So inside this linear model package, we can able to import the logistic regression class. Okay. So what have to do is we have to take the dependent variables churn and the independent variable is monthly charges. Okay. So the dependent variable is churn here. What is the independent variable? Monthly charges. So x equals to pd dot data frame. So what is the independent variable here? Independent variable is monthly charges, and our dependent variable is nothing but the churn here. So either you can give data dot churn, or else you can take it as data of churn. Okay. So then what I have to divide the data set in 65:35 ratio. Okay. So I will just copy this same line. I will paste it here. I'll just change the, instead of train size, instead of test set, I'll take it as train size, guys. Size equals to 0.65. So guys, now we have successfully splitted our data set into 4 new variables: x train, x test, and y train, y test. Okay. So then same thing, build the model on train set, predict the values on test set. Okay. So now what you can do is we need to build the model. Okay. So let my object name be log model here. Okay. So log model equal to logistic regression. Then what I'll do is I'll just get, with help of this object, I will call the fit function. Okay. So into this fit function, I'll just pass on the x train and y train values. So now we have successfully built the model. Now it's time to predict the x test value. So ypred is equals to log model dot predict. Okay. So I'll just give x test values here. So now we have predicted values. We'll check the predicted values now. These are predicted values by underscore test. So these are original values, dot values. Okay, so now we can see original values no, but predicted values also no. Here some misclassification has happened. So misclassification has nothing but where model failed to predict correctly here. Okay, so what I've done is, so you see the original value is yes, but a model predicted it does no. So there's nothing but misclassification here. Okay, so guys, now I said some method. With help of that method, we can able to find how many data has been misclassified here. Okay, so what is the method name? So it's nothing but confusion matrix here. So kindly create an object for logistic regression class. Okay, so guys, now what we'll do here is we'll just try to find the, okay, now next question is you have to build a confusion matrix, then you have to get the accuracy score. Okay, so for confusion matrix we have to import the Sckit-learn dot metrics class, metrics package. I'll be importing confusion matrix as well as accuracy score here. Okay, so now what I'll do is I'll just find the confusion matrix, guys, ypred and ytest. So guys, you can see I'm getting confusion matrix like this. So from this confusion matrix, see I'm getting 7043, 1 here. So guys, from this confusion matrix, what we are trying to get is
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Which of the following are machine learning methods? A. Based on human supervision. B. Supervised learning. C. Semi-reinforcement learning. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So these are the actual values. These are the predicted values. Do you have to write my predicted? No, Akshay, it won't make any changes. Even we can give white test white pred, or else you can give white pred and white test. No problem there. Okay. So guys, here we have around accuracy score SGR. Okay. So we have around 1815 records where the original value is yes, original value is no, but a model predicted as no here. Okay. Then we have around 651 records where the original value is yes, but a model predicted as no here. Okay. So this is a confusion matrix here. So we have around 651 records where the data has been misclassified. So with the help of this confusion matrix, we can have to say how many records has been misclassified. Moreover, with the help of this confusion matrix, we can also get the accuracy score. So 1815 true positive plus true negative divided by yes, Samandeep. So a model didn't predict, like a model predicted only no for the entire data. Okay. So 1815 plus 615 plus 2 positive 2 negative plus 0. So guys, yeah, my accuracy score is 0.74691, which is nothing but 74%.6. So with the help of, if we call the accuracy score function by pred comma y test also, so I'm getting 73 points, 73%, guys. Okay. So accuracy score of my simple logistic regression is nothing but 73%, guys. Okay. So guys, what is the accuracy score you guys are getting? Cool, Amandeep. So guys, can we take a short break? Like, can we take a short break of 10 minutes? 10 minutes? Yes, Leela. I think we are getting the same accuracy score there. So what I have to do is we have to build a multiple logistic regression where dependent variables churn and independent variables tenure and monthly charges. Okay. So in the case of simple logistic regression, we have only one column for monthly independent variable. Okay. Now in the case of multiple logistic regression, we will be having multiple columns for the independent variable here. Okay. So other than that, the rest of the things are same only, guys. Okay. So x variable, what I should have, pd dot data frame. Okay, so what I have to do is, see, you have to take two columns here. Okay, tenure and monthly charges. So what I will do is I will use data.log function here. Okay, so with the help of log function, like I can use the name. Okay, not the index value. If you want to retrieve the respective rows or columns with the help of their name, you can use log function here. Okay, so I'll just give comma. Before comma, it represents the rows. I'll give entire rows, and after comma represents the column here. Okay, so what are the columns we have to take? You have to take tenure and monthly charges. Since you have two columns, we should take another bracket. So tenure, this comma, then monthly charges. Okay. So now you have two independent variables. So nothing but tenure and monthly charges. Okay. And my dependent variable I'd be having, I think, same churn, I guess. Yes, we have the same churn here. So I'll just give churn there. Okay, guys. So in the case of X, we have tenure monthly charges. Now in the churn, in the dependent variable, we have churn column here. Okay, so we have to divide the data set in 80:20 ratio, guys. So I'll just copy this, I'll paste it, I'll just change it into 0.8 instead of 0.65 here. Okay, so now I have created four different variables, xtrain, xtest, and ytrain and ytest here. Okay, so now we'll create a object here. Okay, so please share line number 72. Okay, guys, so you guys got this line why I'm using log function here, because I am taking the tenure and monthly charges column with the help of the column name. So I took dot log function here. Okay, So then I'll create an object for the logistic regression class. Okay, so now with the help of this object, I'll create a model which will have X train and Y train here. Okay, so now guys, we have successfully built the model here. So what we can do here is now we'll predict the values here. So y predict is equals to mlr dot predict X train, and I mean we have to predict the X test values here. Sorry. So we have the predicted values. Okay, then we have the original values also. Okay, so even here we can see the misclassified data here. Okay, we'll check whether a more predicted entire thing as no, I think so. We'll check. Okay, so we'll build the. So guys, since we have already imported this package here, so we don't need to again do this. Okay, even if we do it again also no problem. Even if we want to import once again also no problem here. Okay, it won't create any error or it won't make any changes here. Okay, so what we'll do here is confusion matrix y pred and y test. So guys, here we have, so here like model, like here like we don't, it not only predicted no, it also predicted yes also. Okay, so don't worry. So no, yes. So these are the actual value, these are predicted values. Okay, so guys, we have around 934 records where the original value is also no and a model predicted as well true. So this is true positive here, true negative. This is true positive. Then this is true negative, guys. Okay, so then we have around 156 records where our model, where the original value is yes and a model predicted is also yes. Okay, so but we have around 2112 plus 107. What is that? 319. Okay, so we have around 319 records where our model failed to predict correctly. Okay, where we have some misclassified data here. Okay, so you see we have around 212 records. You see the original data is yes here. Okay, but our model predicted it as no. Okay, even here we have around 107 records where the original value is no, but our model predicted it as yes here. Okay, so this is nothing but the confusion matrix, guys. Okay, now we'll try to find the accuracy score here. So 934 plus 156 divided by 934 plus 156 plus 212 plus 107 here. Okay, so guys, I'm getting the accuracy score as 77%. We'll check accuracy score of y test and y pay. Yes, guys. So I'm getting the accuracy score as 77%, guys. Okay. So when compared to simple logistic regression, so we have higher accuracy here. So which means like since we have added a column, even here like a process, everything is same, guys. Only the matter that differs is nothing but the package that you are importing. Okay, package and the class that you are importing here. Okay, so only thing that changes is that only. Okay, so guys, now we'll move on to the decision tree. Okay, so what I have to do is we have to build a decision tree. Okay, where the dependent variable is churn and independent variable is tenure here. Okay, so moreover, we have to divide the data set into 80/20 ratio. Other things are same place. Okay, like what package we have to import, what from that package, what class we have to import. So from Sckit-learn.tree, we have to import the decision tree classifier class. Cool. Okay. So what have to take the independent variable? Independent variable is something with the tenure here. So x equals to pd dot data frame. I will take data of tenure. Okay. And the dependent variable is nothing but the churn. So y equals to data of churn. Okay, so what I have to do is we have to divide the data set in 80:30 ratio. So which is same thing. I'll just copy, I'll just paste it here. Okay. So now we have successfully splitted our data set into 4 variables. Okay, so 80% of my x variables are saved in x train, and remaining 20% of my variables are saved in the x test, and same thing. 80% of my y variables are saved in y train, and remaining 20% of my x data are saved in the y data are saved in the y test here. Okay, so here either you can give train size equals to 0.8, else you can give test size equals to 0.2 guys. It's your wish. Okay, so now you have to build the model on train set and predict the values on test set. So let me object name be dt guys. Okay, dt of decision tree classifier. So guys, make sure you give the correct spelling for the class here. Okay, so dt dot fit. I'll just pass on the x train and y train values. So now I have successfully built the model, and into this model I will pass on the x test values and I will predict the values there. Okay, so y pred is equals to dt dot predict. What I'm going to predict? The x test values. Okay, so we are going to predict the x test values here, and I'm saved in the y pred here. Okay, so y pred, these are y pred values, and these are the original values. Okay, so even yes, the original values yes, but the mol operators no, and the original values no, mol operators yes. Okay, even here we have some misclassified data here. Okay, so with that we have to build the confusion matrix. We have to calculate the accuracy. Okay, so to find the confusion matrix, what is the function name we have to pass? Confusion matrix. I'll pass on the y pred and y test here. Okay, so guys, this is nothing but my confusion matrix. Okay, so I hope so I'll explain, no problem. So these are the actual values, these are the predicted values. Okay, so we have around 965 records where the original value is no and a model predictor is also no. Okay, and we have around 87 records at the original value is yes and a model predicted it is also yes. Okay, and these two 81 and 76 are nothing but the misclassified data guys. Okay, so where original value is yes but a model parameters no. Okay, likewise here around 281 records, and even they have around 76 records where the original value is no but a model parameter is yes here. Now what I will just do here is we'll try to find the accuracy score here. Okay, so true positive plus true negative divided by the whole thing, 965 plus 281 plus 76 plus 87. So 87, 965, 965, 281, 76, 87. So guys, we are getting the same one. Okay, so I'm getting the accuracy score of my decision tree model is 74% guys. So accuracy score of y test and y pred is nothing but same thing guys. So we are getting the I'm getting accuracy score of my decision tree model is 74% guys, 74.66 to 80. So guys, here what I have to do is, so guys, and for random forest, what's the package that we have to import guys? Sckit-learn dot ensemble. I would be importing random forest classifier class. Okay, so this class is responsible for us to build a random forest model here, random classifier model, random forest classifier model here. Okay, even in this class we have this fit function with the help of the fit function only, we are going to build this model. Okay, so we'll move to the question. Okay, so what we have to do is we have to build a random forest model where dependent variable is churn. Okay, so independent variables tenure and monthly charges. So I'll just copy paste this line, guys. Okay, so because even here you can see this is independent variable, moreover it has the same column, tenure and monthly charges. Okay, so tenure and monthly charges. Too faster. So my variable have data of churn column here. Okay, so right now my axis will have my tenure and monthly charges. I mean y and my y variable have the churn column here. Okay, so what have to do? We have to divide the data set in 70:30 ratio. Okay, so I'll copy paste this line. I'll just change the train size as 0.7. Okay, so instead of 0.8, I've just changed the into 0.7 here. Okay, so what this line will do, this will ultimately create 4 new variables, xtrain, xtest, and ytrain, ytest. So 70% of my x variables will save in the xtrain, remaining 30% of my x variables will save in the xtest. Then 70% of my y variables saved in the ytrain, and remaining 30% of my y variables are saved in the ytest here, right? So what I will do, I will create a object called FC. Okay, it's your wish, you can give any name. Okay, so just make sure you give the correct spelling. Random forest classifier. Okay guys, so I have created an object for this class. So with then only I can able to retrieve the fit function from this class with the help of this object. So rfc.fit, I will call the x, I will use xtrain and ytrain values. Okay, so now I have created a model here. Now I'll just predict the fit missing. So ypred equals to rfc dot predict x test here. So now what I will do, I'll just build the confusion matrix test and ypred. Then this is my confusion matrix. The accuracy score I will get 1350 plus 232 divided by 1350 plus 232 plus 210 plus 321. Okay, so 1350 232 121350. So 232 3210 321. Okay guys, so I'm getting 74.8 guys. Okay, so I think many are getting 74 and 75. Cool, no problem. So guys, with this question we have come to the end of this project session, guys.
So now we finally come to Scikit-learn. So what is Scikit-learn? Scikit-learn is a free open source machine learning library that contains generic implementation of common machine learning algorithms. So as we've already discussed, there are a lot of algorithms that you can use in order to build a machine learning model, but writing those algorithms from scratch on yourself by yourself is going to be really difficult. So using instead of that, what we do is we use Scikit-learn. Scikit-learn allows us to import the algorithms ourselves after understanding the data, and we can just use those algorithms that have already been pre-written for us to implement our model instead of us having to implement the algorithms ourselves. Since they are common algorithms, they have been implemented by people already. Okay, so now the thing that we have to understand is that it contains a lot of functions to perform commonly used operations. So it doesn't just contain the machine learning algorithms that we want to use. It also contains a few functions that we use a lot. So for instance, if we have some data set and we want to split it into a 70-30 ratio, it has a function for that. If you want to figure out if you want to validate our data set against different distributions of data, it has a function for that. If you want to generate a confusion matrix, it has a function for that as well. So there are a lot of things that it covers. It doesn't cover everything, but it has a lot of functionality out of the box that we can use. All right. So with that, I have another question for you guys. Hopefully, if I show it to you on the polls, you'll be able to see it. Okay. So now I think you can see the question. For those of you who are unaware, the question is, can you build a machine learning model by only using Sckit-learn and no other library? So if you are not using any other library other than Sckit-learn, can you build a machine learning model? When I say no other library, I mean you are not able to use Python as well you are not able to write, you are not using any other thing other than Scikit-learn. So for all the tasks involving machine learning and everything, can you use Scikit-learn only? So the answer that options that we have is yes and no. So I'll wait for the answers, and once I've gotten all the answers, I will tell you the correct answer. So I encourage everyone who's participating in the all right, majority of you have answered, and the options that were available were yes and no. I'd like to tell you the correct answer, which is for the question that can you build a machine learning model with only using Scikit-learn and no other library. The correct answer is yes, you can. The people who have answered no, I'm assuming that you guys were thinking that because we have to use NumPy or Pandas or other libraries like that, we could probably not be able to use build a model without using those libraries. The thing is, you can build a model without using those libraries, but you would have to do a lot of coding yourself. You would have to import the data, parse it, split it, and then use it inside the library of Scikit-learn. But only using Scikit-learn, you can build a machine learning model. It's just going to be really difficult, and without using Scikit-learn on any library, it's going to be even more difficult. So the correct answer is yes. For those of you who have answered yes, you were correct. For those of you who answered no, you were incorrect. But depending on how your thought process went, you were really close. All right. So now let's move ahead. I've closed the poll, and now let's take a look at why should you use Scikit-learn. First of all, it's very easy to use. Scikit-learn is extremely easy to learn and use, and it makes the task of implementing mathematical algorithms really easy because it contains all the implementation with it. We just have to understand how to use the classes and the functions available in the library. It's very well documented. It's got an extensive documentation that contains information about how to use every available feature in the Scikit-learn library. And using that, we can take a look at that. Then it's been created by experts. So Scikit-learn is a library that has been created by expert data scientists who have been inside the data science business for a long time. They have written these algorithms themselves, and these people have been writing algorithms that are relating to data science from their hand for a long time. So they know how to make a generic implementation that many people can use. And finally, it's very well tested. It's been used by several developers across the world who contribute patches and bug fixes. Scikit-learn is an open source library, so if you want to take a look at the code underneath the hood, you can just go to GitHub, search for Scikit-learn or sklearn, and you can get the library code yourself. If you find some problem or want to help Scikit-learn grow and add some features to it, you can use GitHub to add some features in the code that the Scikit-learn has, and then suggest a revision to the developers and maintainers. Because it's open source, many people have already found a lot of bugs and submitted a lot of bugs. So that means it's battle tested as well, and it has seen a lot of issues already. Now let's take a look at steps in building a classifier. This is an important concept, right? So now let's take a look at steps in building a classifier. So there are 5 steps in building a classifier, but there are several steps in building a classifier. 5 to be exact, but depending on how you're training a model, it could be more and could be less. Usually these are the 5 generic steps that are used. The first thing is we import the library. So if you're using sklearn, NumPy, Pandas, you import it. Many people import it throughout their code. So as soon as they need something, only then they'll import it. I like to import everything at the top of my file so that everyone who's using my application knows, or looking at the code that I've written knows what are the libraries that my code depends on. So you can firstly import all the libraries needed to train and build the model that you need. And these libraries can perform tasks ranging from numerical manipulations such as NumPy and testing the accuracy that we'll be using Sckit-learn for. All right, and then what we do is we import the data set. So data set is the data that we will be training our model on. It's important to understand what data set we'll be using and how we'll be using it. So that's how we firstly need to import the data set, or we can, after importing the data set, we view the data set, we load it, we manipulate it so that it's clean and it's in a state that we can use it to train our model and do the following steps. And after that, we can use it in machine learning models. After that, what we do is split the data. So when we get the data set, its x and y variables are right with each other. So the thing that we are using to make the prediction and the prediction itself are right inside the data. First, we split that, and then we split our data into a training and testing set. Training set is used to train the model, testing set is used to test the model, and using that we understand what is the how the model has learned and what is the accuracy that it's giving us. Then comes training the model, in which is the task of the Scikit-learn library. It creates an algorithm and allows us to feed it data so that it can learn from the data. And after learning from the data, it can do the classification or regression tasks that are needed. Finally, we test the model. We give it the data that we had set aside for testing. After giving it the data, we ask it to make the classifications, and depending on how many were correctly classified, we give it a percentage from 0 to 100. Higher percentage means our model is more accurate, lower percentages mean it's less accurate. What is the max percentage of a model accuracy? The max percentage is 100%, but no model can be expected to have 100% accuracy. If your model, when training or testing, it gives 100% accuracy, it could be that your training set is too small. That is, it either contains only 10, 20, 40, or 100 values, or it could be that your training set is overfitted, which is the variance issue that we have talked about recently.
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
So you need to train your model again, and if it sees some data that it hasn't already seen, it will give poor results. Someone has asked some more detail on splitting the data sets and why and how.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Machine learning is a field of AI consisting of learning algorithms that A. improves their performance, B. at executing some task, C. over time with experience, D. all of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So splitting the data set is basically the task when we get the data and we want to set aside some data that our model can be trained on, and the remaining data is used to test whether or not our model is giving us correct accuracy. So as in supervised learning, we already have the data and the output that it should map to. Once we feed in the data and we take a look at the predicted output and the correct output, the percentage of outputs that match are the ones that are correctly classified, and the ones that are correctly classified are the outputs that lead to higher percentage of accuracy. So someone has asked to explain some example on training the model. Training the model basically means just taking the algorithm from the Scikit-learn library, feeding in the data, which is the x and y variables that we have splitted for training. Then that data, that algorithm learns from the data, and after that we can make predictions using it. We'll take a look at that in the demo. All right, hopefully you can see the question. The question, yeah. So the question is, which set is used to validate the performance of the trained model? So once the model has been trained, which set is used to check whether or not our model's accuracy is good? So I'll wait for a few moments and you guys can answer in the poll and submit your answers. Whether it's training set or testing set. Training set is the first option, testing set is the second option. All right, in the meantime, people have asked a few questions. I'd like to answer those. Someone has asked, what is the ratio to split the training and testing set? So for training and testing, you can split the data into, depending on how large your data set is. If it's really large, like you have millions or billions of rows, then you can just take 1% or 10% of your data. If it's a small data set, then 70-30 is a good ratio to split your data on. It's testing set, which is the correct answer. The training set is used to train the model. The testing set is used to figure out whether or not the answer is whether or not the model is performing well, which is why we use it. And let's have our hands-on. We'll have a demo here. So I already have prepared a Jupyter notebook for you guys in which we perform all the 5 steps. So let me just first explain what we're doing. We're using the iris dataset that contains information about flowers. It contains information about the sepal length of a flower, sepal width of the flower, petal length of the flower, and petal width of the flower. Using these 4 features, we're trying to predict the kind of flower that it contains, or kind of the iris flower that it's containing. There are 4 kinds of flowers that our dataset has. 3 kinds of flowers that it has: Virginica, Setosa, and these are the different kinds. So what you do is, firstly, we import all the libraries. As you can see, the libraries were easily imported, so it works fine. And from Sckit-learn, I'm importing the load iris function that will get us the dataset. It's a very common dataset, and so that you can follow along with me and you don't have to wait to load the data from some remote data source, you can just use this code that I'm showing you on my screen right now. And then we are using the train test split function, which we'll use to split our data set into the specified ratio. Someone has asked, can we try it on Google Colab? Yes, you can try it on Google Colab. That's a very good use case for Google Colab actually. So if you want to use Google Colabs, or if you want to use your local notebooks, you can use those as well. Okay. With that, we have train test split, which is the function that is used to split the data. We'll be using the logistic regression model, which we can import from sklearn.linear model. And finally, we will be taking a look at the accuracy score as well. And Scikit-learn already gives us a function that does it for us. I'll be more than happy to answer you on the questions that you ask about the code that you're watching. If you want to follow along, you can type in the code in your Jupyter notebooks if you have it. If you don't have Jupyter notebook, then it's going to be difficult for you. You can use Google Colabs. That's a really good option for you to try if you want to follow along. So now let's take a look at it. So someone has asked that they need to import the data set. Should they need to import it with its name? So we are using the load iris function, and using that you can just import it. You don't need to specify any name. If you have a CSV file on your local system, importing that, you would need pandas library and need to know the file and the example. Okay. So now we load the data set. But now let's take a look at what the shape of the data set is. As you can see, it's a dictionary. Dictionary is a key value pair. It's a common Python data structure. It contains a key of data that contains all the data. And it's 5.1, 3.5, 1.4, 0.2. These are individual rows in our data set. Now, we don't know what these values mean. So taking a look at the data, we have targets as well. Targets ranging from 0, 1, and 2. Now let's take a look at the target name. These are the different types of flowers that we'll be predicting. These are the categories that we'll be predicting: Setosa, versicolor, and virginica. So 0 means Setosa, 1 means versicolor, 2 means virginica. The reason why we have encoded them into numbers is because machine learning algorithms only understand numbers. They don't understand words or strings or letters or sentences. So we need to first convert those numbers into letters and classes into numbers, and then we can make the prediction. And now for our columns, we want to be able to understand what are the different columns that we have. And what we get here is we get the sepal length, sepal width, petal length, and petal width. So it's given us the example of what we have. So feature names are: the first column has sepal length, second column has sepal width, third column has petal length, fourth column has petal width, and all of them are in centimeters. So that helps us understand the data. Now it's time to split the data. We'll split it in X and Y. We'll be using these features, and using those, we'll be predicting these targets: 0, 1, or 2, which map to Setosa, versicolor, or virginica. So with that, after splitting the data, I try to split it into 70-30 ratio. So let me just explain what that means. Using the data set that we have, the data.data The data key inside it contains all the data that we need. So let me just show you what the size of the data is. If I insert a row below and look at the length of X, we have 150 rows there. Now, if I split it into a 70-30 ratio, right? And now if I insert a row and I print the length of X train, we have 105. So 70% of 150 is 105, and remaining 45 are for testing. So we will use 70% of our data for training, 30% for testing. And with that, we create a logistic regression model. This is a class in Sckit-learn. It just takes in the logistic regression model and creates an object of it. We use the fit method to fit our data. Fit basically means train our data. We pass in the training X variable and training Y variable. So the 105 rows that we have created for testing, we pass it inside our training and testing set. If you're following along, if you want me to scroll up to help you look at the code, this is what the first line, first things we import is. Then we load the data set. You only need to write this code. This is just for explanation. This is markdown format, so you don't need to copy that. After we have trained our data, since our data set is small, it trains in a few milliseconds. Now we make the predictions. And after the predictions are made, we take a look at the accuracy, and accuracy is 88%, which is quite good. Because machine learning models use statistics, these accuracies could change. So if I train it again and then I check it again, it's giving me 100% accuracy because our data set is too small. And now it's giving me 91% accuracy. So it's giving us high accuracy, but the accuracy is variable. The reason why is because depending on how data is split. When we split the data using train test split, it splits it randomly. So it takes a look at 45 values randomly and splits it into another 45 and 105 random values from the entire data set, and then we can train the model. So someone has asked, is face recognition classification or face recognition is a supervised learning problem. It's a classification problem, but it takes a look at very different technologies that are not just part of classification. It takes a look at computer vision, handling the data. There are many other different kinds of things. Face detection is a classification algorithm. Face recognition is a system that uses classification algorithms along with other algorithms as well. Is computer vision in area of ML? Yes, it is. Hyperparameter tuning, as the name sounds, is used to tune the hyperparameters of a model to make it increase its accuracy. So what are hyperparameters? So for instance, let's take the support vector machine model as an example. Now, when you're training a support vector machine, you need to set a lot of parameters. These parameters determine how your machine learning model will get trained, for how long it will get trained, and how it will begin with the training session, and how the training session will go on, and how long it will go on. So these are the kind of things that the hyperparameters are responsible for. To give you a quick look, let's take a look at the Sckit-learn libraries documentation for support vector machine. This is the support vector classifier, also called SVC, and as you can see, there are these many parameters that you need to change. Now, as you can see that these are the default parameters, and you can take a look at all the options that you can take. So for instance, the parameter named C, parameter named kernel, you could say the default is RBF, but you could change it to poly or sigmoid or pre-computed or any other value. As you can see, there's also degree, there's also gamma, and there are a lot of other parameters that you can set. Now these parameters are responsible for you to understand how your model works, and these parameters also take care of how your model will take care of the data interaction and how it will train itself and figure out the classification problem. For instance, if you have a data set and you want to use it to classify your algorithm, to train it on a classification problem, this algorithm, if you don't set any of these parameters, these are the default parameters that will get set automatically, and all you would have to do is train your model and you will get some sort of an accuracy. It might not be the best accuracy you get, but it will be the accuracy you get by the default parameter. So if you're not satisfied with the accuracy that you have with any of the models that you have trained, one thing that you can do is called hyperparameter tuning. That is, you could change the parameters to different values and see how it affects the accuracy of your algorithm or the trained model. So for instance, if you have trained model with the default parameters and you change it and you get a better result in the accuracy score, that means that that model is better than the previous model and you need to pick that model. Now, all of that is good, but since you can see that there are so many parameters that you need to think about, and what's even more difficult to understand is that since there are so many parameters and all these parameters have so many options, which ones do you choose and how do you go about choosing one of those? Now, since machine learning is based on statistics, probability, and calculus, there's no fixed answer. There's no way to determine which one to choose right off the bat. So if you want to learn how to choose one, you need to try a lot of combinations. Now this is where the hyperparameter tuning part comes in. So in hyperparameter tuning, what we do is we take a list of all the possible or all the options for the hyperparameters that we are choosing, and we choose a lot of combinations in those hyperparameters, and then we pick the ones that lead us with the best result. So to give you an example, since in SVC, let's say these are the parameters that we're concerned with: C, kernel, and gamma. As you saw in the documentation, C, kernel, degree, gamma, all of these are parameters that you could set to the different values, and you might get better or worse results depending on how your data set. Now the thing is that there's no fixed answer that you choose these parameters together and you will get the best answer. A lot of it is based on experimentation, so you would have to pick a lot of parameters and do this. So the two options that we have to do this are called random search and grid search. So we have a grid search algorithm and we have a random search algorithm. So what do these mean? Well, let's say that these are the options that we want to test or tune our hyperparameter on. We want a combination out of these options and we want the one which gives us the best result. So let's say we have a data set and we train our model on default parameters. Now, if you take a look at the documentation, the default parameter for C is 1.0. Here it is, 1.0, which is this. The default parameter for kernel is RBF, which is this one, and the default parameter for gamma is scale. However, the options you could choose a numeric option as well, and this will give you different results. As you can see, it says here if gamma is scale, the default value is supposed to be this. If auto uses 1 by n features, when 1 by n underscore features. N underscore feature means that we have n underscore feature means the number of features or the number of columns. So if we set it to auto, then it will automatically determine the scale. However, we can pass in the scale as what we want as well. So if we want our model to be trained to its max accuracy, considering all these parameters, one thing that we can do is we try all the combinations or all the different permutations and combinations of these options. So let's say we start with 1 linear and 0.1. We get the accuracy of, let's say, 68%. Then we go with 1 linear and 0.2 and we get the accuracy of 69%. Then we go with the accuracy of 1, we go with the parameters 1 linear and 0.3. So C will be set to 1, kernel will be set to linear, gamma will be set to 0.3, and we will again train the model and test the model and figure out its accuracy the normal way we do. Let's say we get the accuracy of 58%, and we try it for all the possible combinations. So we, after getting through all of the gammas, we go from 1 RBF and we train on all of these. Then we go through with this process again with 10, with 100, 1000, and we try out all the combinations. Now, when we do that, we keep track of the combination that gave us the highest accuracy. So if the highest accuracy we got was 88% with the parameters as 1 linear and 0.6, then we'll choose that. So this is what grid search algorithm does. Now, as you can see that this could be an exhaustive search. We're trying all the possible combinations and permutations. And the real problem here is that since we're trying all of the permutations and combinations, and if the data set is large, then training it will take a lot of time. And to be fair, hyperparameter tuning does take a lot of time. So if you don't want to spend a lot of time, or you don't have the resources to train such all of the combinations, or to try out all the combinations on the size of the data set that you have, you could try random search. Now, random search, as the name sounds, is that it chooses values at random. So it might choose one linear 0.4, 1000 RBF 0.2, so on and so forth. And it randomly chooses these values and picks the best one that it gets after a number of iterations. Now, this number of iterations is unknown to us because it's implemented in the algorithm. We don't have any control over that, and that's how that works. Now, intuitively, you might think that since it's randomly selecting these things and there could be number of possibilities, we might not get the best answer. And you're right, we might not get the best absolute result when we're choosing random search CV or the random search hyperparameter tuning. But the thing is, even if we don't get the best, we'll get somewhere around the best. So let's say the best attainable score using these hyperparameters was 95%. We would get somewhere around 88 to 93%. Now, this is, by the way, mathematically proven. There's a research paper on this as well. I don't know the link of this, but you can search it online and it will show you that random search CV performs much better on large data sets, mainly because it's not exhaustively trying to find out all possible permutations and combinations and trying to figure out how to get things done. So if you don't have the luxury of having large computational resources, or you don't want to spend a lot of time on training your model, you could choose random search CV, but with the understanding that random search CV might not give you the best, most optimum result that you want, but it'll give you somewhere around that. So that's good enough. Now that's done, we can understand that these two techniques are quite different. One focuses on a lot of time. So grid search will take a lot of time, but will give you a great result, or the most optimum result attainable using the hyperparameter grid that you give it. And one is a little pragmatic. It might not search all the possible permutations and combinations, but it will do good enough and give you a good result. So you can try that as well. Now, this mainly depends on the size of your team, the resources that you have, the size of the data set that you have, and a combination of all of that will determine which algorithm you choose. Now, for instance, if you're training your model on a cloud computing platform, let's say the Azure ML Studio, that these studios have other algorithms as well. So I don't remember the name of those algorithms, but they are there as well, and you just have to change some settings and click a few buttons and you'll get good results. Also, they allow you to write code to do that as well, so you could read through the documentation of their SDK and then provide you with that as well. But for normal tasks, if you're doing it on your PC, or even if you're offloading these computations to a cloud computing cluster, these tasks are better performed, and grid search and random search will give you good results. So if you are using a service like the Amazon SageMaker, or the Azure, I think ML Studio is called, Machine Learning Studio. So you could use those technologies, and they depending on the data set and the technology you're using, it will give you some graphical tools as well to train or hyperparameter tune your model. So, and again, they give you options to save that model, deploy it, create a web service out of it, all of that using a graphical. So if you want to take advantage of that, you could use cloud computing for that as well. But if you just want to train a model on your local computer, grid search CV and random search CV are great examples for that. So you could use that as well. So as we have seen, grid search CV will try out all popular or all the possible permutations and combinations of all the options that you've given it. Do make sure that it will only try out the permutation and combination of all the options that you have given it. So for instance, for C, it won't try out 1, then 2, then 3, then 4, then 5 to 1000, because we are only allowing it to use a value out of these four for C. And similarly for kernel, it will only try out either linear or RBF. Similarly for gamma, it will only try out 0.1 to 0.9. So that's how it's supposed to work, and that's how it does work. Now that that's done, let's take a look at the code and understand how to get it done. So we'll be using a support vector classifier, and we'll be using a data set that we have. The data set is quite small, as I'll show you, but first let's import pandas. So pandas is used to load data and data sets from our local computers or any other format using CSV, XLS, and so on and so forth. And it's loaded. Now let me load it. and read CSV. The name of the file that we'll be using is called dataset.csv or no data.csv. So I type data.csv and the file is loaded. Let's take a look at the file. Shall I think that's too much information. Let me just take a look at the head of the file. Head will determine the first five. Okay, so this is the data set. Here's the user ID, here's the gender, here's the age, here's the estimated salary, and here's the purchased. So these are the, you can think of it as the records from a store, and this is a record for a particular product. So let's say it's the record for an iPhone. So these are the user IDs and the information stored about the person's name, person's gender, age, and estimated salary, and we check whether the person has bought this or not bought this. So zero tells you that okay, the person did not buy the iPhone, and one would determine that the person did buy iPhone. So this is what the dataset looks like, and we'll be training a support vector classifier using a SVC, and we'll be using the support vector classifier that is provided inside the Sckit-learn library, and we'll take a look at how to tune it using the grid search and the random search algorithm. So let's start doing that. Let's first import. Okay, I will be using now, by the way, Sckit-learn comes with all of these pre-installed, and if you don't know how to use them, we do provide courses on that as well, so you could take a look at that. But I won't be teaching you how SVC works internally, but I'll show you how to get it done in the Python Jupyter notebooks, and you can understand how to do hyperparameter tuning, since this is the goal of this this session. So let's take a look at that. So we'll go from sklearn.svm import SVC. SVC stands for Support Vector Classifier, and since this is a classification problem mainly means that we're trying to figure out the output in categorical format. So we don't have a continuous format where we are trying to figure out whether we have only two labels. Let's say the customer will either buy the product or would buy the product. So if we have a limited number of outcomes, that's what's known as classification problem. Regression problem basically means that we're trying to predict something, and predictions could have an innumerable number of outcomes. So let's say that I'm trying to figure out the price of a house. That would depend on the house, and you can't keep it in a category that it will be this much. Let's say it's a continuous number. It could be 1,000, 10,000, millions, or possibly billions as well, or 1,000,000, 11,000, something like that. So it works like that as well. So since we are using machine learning, we'll use the train test split function in the Sckit-learn model or the Sckit-learn module. So from Sckit-learn dot model selection, I think it's called. Oh, my Sckit-learn app. So model selection, we import train test split, and we also import the grid search algorithm while we're at, and it gets imported. I usually like to import everything that I wish to use in a particular notebook at the top cell, so the cell which is at the top. Now that that's done, let's take a look at how we're going to do it. So for this classification problem, we'll be taking a look at the age and the estimated salary. We are discounting the gender and the user ID because these, in our opinion, does not have any effect on how the person whether the person buys something or not. So let's split the data into X and Y columns. X is the data that we will have, and Y will be the data that we will try to predict. So we will extract the age and the estimated salary from the data set that we just loaded from the data.csv file. And since we're using pandas, we could use the ilog. Now ilog, for those of you who don't know, ilog stands for integer location. Basically, we pass in an integer list which slices up the data and gives us only the subparts or subrecords of the entire data set that we want. So we want all the rows, however, we only want age and estimated salary. So 0, 1, 2, 3 in pandas, the columns start from the 0th index. So user ID is the 0th index, gender is the first index, age is the second index, estimated salary is the third index. and we want age and estimated salary, so we want 2. And y is the column that we're trying to predict, so we are trying to predict the purchased column. For that we will be using, again, iLock will be used, but here we only have to pass the, I'll just copy it and I'll show you. I don't have to pass in a list since I'm not choosing multiple columns. All I have to do is press enter, and now the data set is split. Now I have age and estimated salary in one data field, and y would contain whether the customer has purchased or not purchased. As you can see, we have it here as well. So now that that's done, quick sanity check. Let's take a look at the size of the data set that we have. So data dot, so you can take a look at all the columns that we have. What are the data types of each of the columns? And finally we have 400 entries. So the index ranges from 0 to 399. As I've already told you that in pandas the indexes start from 0. So this is what it looks like. Let's change it back to head so we have an idea of what our data set looks like. I misspelled it. So this is what it looks like, and let's remove that. So now that that's done, the first part we'll do is we'll train a support vector classification model. To do that, we will just train test split our algorithm, and since we've already split the data set into x and y columns, we'll be taking a look at that. So let's name our functions x train test, y train, and we will use the train test split method to do that, and we will use the train test split method. So for train test split, all we have to do is use the x and y methods. So we pass in the x and y columns, and then finally all we have to do is specify the we have to specify what the name of the train test size. So if the testing size is 0.25, let's say test. So now the dataset is split. Let's take a look at the size of the dataset that we have. Strain shape. So we have 300 records in the X train, and for X test we have 100. So as you can see, we have split the dataset into 25 and 25 and 100% of the dataset. So now let's take a look. Let's take a look at that. Now that that's done, we have split the dataset, and now all we have to do is train our model. We'll be using the SVC algorithm as I've already discussed. So for that, all I have to do is use the SVC, and I will use the default methods. So it's done, and all I have to do now is fit the dataset. So to fit it, all I have to do is pass in the training parameters. So we are training it, the x value, the y value, and these are, as I've already told you, the default parameters. Check it with the documentation. All of this is completely as it was supposed to be inside the documentation. Now that that's done, let's take a look at how our model is performing. We will make a prediction with dot predict, and we will use the x test. So the predictions are made. Now we have to take a look at whether those predictions are right or not. Now these predictions can be taken using the or the accuracy could be checked using the Sckit-learn package. We'll use Sckit-learn dot metrics, and we will import accuracy score. If you've not worked with accuracy score before, so now we're taking a look at the accuracy score. We have the the training. Okay. Okay. White train, it's white test, and it's done. So right now, as you can see, the accuracy is only 0.58%, and it's very, very bad. So now let's take a look at how we can use the grid search algorithm and get better score. So we have already imported the grid search algorithm, so it won't take a lot of time for us to get started with it. All we have to do is first create a grid of all the possible values and all the possible parameters that we want to tune it to. So we will create a grid using a dictionary in Python. So I will call it a grid. I will create a dictionary, as you can see.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Which of the following are machine learning methods? A. Based on human supervision. B. Supervised learning. C. Semi-reinforcement learning. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And inside that dictionary I will create some so key would be the name of the parameter, and the values would be an array of list of all the possible values that we want it to work on. So for C, I want it to work on, I think, from 1, 10, 100 and 1000. So let's do that. So 1, 10, 100, 1000. Similarly, there are other parameters that I want it to be trained on as well. One of those parameters is the kernel. And you can take a, if you want to figure out how these parameters are being chosen, you can take a look at the documentation and it will tell you what are all the parameters that you could use. So we use kernel. Inside the kernel, I would use RBF. RBF is used by default used in the SVC, and I will use something called linear, LINEAR. So we are using RBF as well as the linear kernels. And now finally I will use gamma, GAMMA. And for that the list would go from 0.1 to 0.9. So I will, so let's take, if I'm not made any mistakes, it works, and yeah, it works. So now all I have to do is create a new instance of the grid search CV class that I imported above, passing a new support vector classifier that has not been trained on anything, and the grid search will take a look at the rest of it. So to do that, all I have to do is firstly create grid search CV. Grid search CV. Inside this, I will take a look. I will pass in the parameters. Now, the first parameter would be the classifier that I want to use, or an instance of the classifier. I can't use CLF mainly because it's already been trained and it won't be trained again. So to do, I have to pass in a fresh classifier. Now I have done that. Now what I have to pass in is the grid that I created, and it's called, I believe, param grid, and I've called it grid, so I am passing it in. Next, I want to pass in the scoring method. So what is it that I want to score it on? So scoring would be, I want to score it using the accuracy. So there are different parameters for, let's say that you are using it to train a, not a classifier, but a regressor. So regressors usually use something called R2 score or the R squared score, in which we are trying to reduce the error. So it's not concerned with the accuracy, but the error produced by the regressor. So we can choose that. And now that that's done, let's take a look at it. And it's created. Now it's created, but we have to fit it. Fit it basically means that the algorithm will be run on the data that we pass in. So grid search CV dot, and we pass in the same data that we passed to train our model, and we pass in the training data, and it will take some time, guys, because as I've already told you that there is a lot and lot of options that, or a lot of combinations that it could take. So it will build up all of this and it will take some time. So let's wait for it to finish. So as you can see, it's taking a lot of time. Just wait for a few minutes. We'll see if it works. Most probably it will. If it doesn't, then we'll have to tweak some parameters as well. This is the problem with grid search, that it takes a lot of time. So you do have to wait for quite some while. Okay guys, so it is taking a lot of time. So what I'll do is I'll interrupt the kernel and I'll restart it. And since it's taking a lot of time, what I'll do is I will rescale the data and make some changes, and this will show you how this works. So let's take a look at that. Rescaling the data will make our data a little smaller, or the magnitude of our data a little smaller, and it will allow us to work perfectly with the configuration that we have. So it won't take a lot of time. So let's see how that works. So I will rescale the data. Hang on a bit. And if you ever come across a problem like this, you can rescore. You could use other functionalities as well. I'll be using the Sckit-learn pre-processing standard scaler. You could use other methods as well. So Sckit-learn dot pre-processing. Yeah. Import. Rerun it. Works. Rerun it again. This is done. I will remove it since it's taking a lot of time, and I will rerun it again because I've closed the kernel. So run again. Now, as you've already seen, I will firstly insert a new cell below, and I will try to rescale the data. And for that, we will use the same standard scaler that we have used right now. All I have to do is create a new method. Scalar is equals to standard scalar. This is the instance of the scalar that we'll be using, and we will be scaling the xtrain and the xtest variables. So xtrain is equals to, we will be using the scalar to fit and transform. Now it's going to take some time. So hang on a second. I think it's doing this because we have not run it here. So I'll just type it entirely, and we will fit it. Let me create a new variable, scaled, and here I won't be using the fit and transform. I will just use the fit. Now the difference between fit, transform, and fit is there are a lot of internal variables that need to be set for the scalar to fit the data, because it depends on the mean and the standard deviation of the data. So it takes the xtrain method, xtrain variables, or the variables inside the xtrain data frame. It will fit itself, and it will then transform the data based on the variables that it's set on the xtrain data. So I would be using xtest here, and now that it's done, let me just use the xtrain scaled and the ytrain. Oh, I don't have to use the scaled versions because it doesn't matter. And it's done. And here xtest scale and ytest and ypred, and we get a score of 93%. So as you can see, scaling increases the algorithm's performance massively. But now let's take a look at how to get it done with the grid search algorithm. 93% is actually a pretty good score. So if you might not have to do this on the SVC algorithm, but let's say that you do. Let's say that you have an algorithm that's performing very low. It's giving you a score of, let's say, 60%. You could use the same performance tricks that I've used right now, and you could get a better result. But just make sure that when after you have trained the data on a scaled data set, the next time when you make predictions, you have to scale that data as well. So just make sure that you're doing that. And now that that's done, we have the parameter, and let's just change some few parameters so that it uses our maximum CPU capabilities. Now Sckit-learn provides us with some of the functionalities that allows us to use the maximum CPU capabilities. If you want to take a look at that, just type shift space in any method. Inside any method, we will be using the CV and the njobs method. So what do they do? If you want to take a look at what any of these do, they have the doc string with them. Just take a look at CV. It means cross validation generator. So it will create 10 buckets of the data to create the validation data. So we could use that. We don't have to use it if you don't want to. The main one that I'm interested in the end is the njobs one. The njobs method, njobs would allow us to use all the processing power that our computer has to offer. So if it's a multi-core processor, we will use all the cores. So for that, let's try n_jobs, set it to -1, so it will use all the processing power that's available on our PC. If you know how many cores that you have, or if you don't want to use all the cores, just the cores that you have, like you have 4 cores and you only want to use 3 or 2 of them, then you can use n jobs equals to and set it to the number of cores that you have. So now that that's done, let's just try it out. Grid search CV dot, and as we've already used before, we will be using the fit method. Let me just use the fit method. I will pass in the scaled data, TRAIN. Training data is passed, and believe I have to pass in bytrain. And now it's run off again, and let's see if it works. And as you can see, it works in a couple of milliseconds actually. So you can see scaling of data actually increases the or decreases the computational complexity. So now that the data set is scaled and we have used all the possible combinations, let's take a look at the score that we are getting. Oh, I'm sorry, it's not a grid search. And we're getting 90.33. So it's actually a pretty good score. The reason why we're getting different scores is because the number of times there's a lot of randomness involved in our data set. So if you train it multiple times, you get different accuracies. But as you can see, we're getting a score around 90%. Now, if you want to take a look at what the parameters that they use, you could use the best params method. So not the method, but the property. So C was 10, gamma was 0.5, and kernel was RBF. So we're getting quite close to what we already had. And the C was 1, kernel was RBF. And yeah, so these are the methods that we use, and we're getting a score of 90.3%, which is quite good. Now let's take a look at what happens when we use the random search CV. So if you want to use the random search algorithm, firstly you will have to import it, and importing it is not that difficult. It's in the same package that we already have. Import grid search from, you just have to type in random search CV, run it again. Now using random search CV and grid search CV are quite similar because we'll be using the same almost the same things. So we have the same parameters that we'll be using. We'll be using the support vector classifier as well, and we'll be using the scaled data. So it would be quite similar. So in order to not make mistakes, I'll just copy it, paste it. I'll type in RDM or
Okay guys, a quick info, if you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
search CV. Now that that algorithm is done, let me take a look at randomized search. That's what I was wondering. So let's name it randomized search. Again, I'll be passing in a fresh instance of SVC. The parameter grid is the param grid. This is the grid that we created earlier with all the possible parameters that we'll be setting. And inside this one, we need to change it from param grid to param distribution. So because these are different methods and we won't be using a grid, we have to change it to param distribution, and we'll be passing in the grid that we created earlier. It will take a look at this and choose randomized random parameters and figure out the best one that you have to use. Now that that's done, we probably could get away with not passing in accuracy, so it will use accuracy by default. And this is done. Now let's random search CV and we fit it. We use the scaled data and we pass in, and as you can see, it ran actually quite faster than the grid search example that we had. And now that grid search is done, we will be using the same attributes, and we'll be checking how much it improved our performance. So we'll be taking a look at random search best score and best params. So let's take a look at that. So random search CV best score, and as I said that it will take somewhere around the best score even without trying all the possible combinations. The best score we got was around 90%, and we got around 89.66%. So as you can see, that works. Random search CV, and we take a look at the best and RBF and gamma and C. So just the gamma parameter was set a little differently, otherwise it shows RBF and C exactly the same as the grid search parameter. And there's not a lot of difference between the gamma that's chosen by the random search and the gamma that was chosen by the grid search. So as you can see, both of them are giving us the right answers, and we are getting the right answers, and we are getting an accuracy of around 90%. So in conclusion, you should use the scale the data to get better answers. Just make sure that when you scale the data, you understand that you are scaling it, and the data that you get from any other source for prediction in the future, you would have to scale the data again. So if you use unscaled data in your production environment, then that would give you incorrect results. So even with 90% accuracy, you will be giving it the wrong data and you'll be getting the wrong answers. So with that in mind, we had how much? 93% of accuracy. Now, I'm sure you're wondering why did we get 90% here and 93 there. So let's again just run it again. I'm running all the parameters again. Earlier we got 93% of accuracy. Now let's take a look at this. We got 92. Let's run it again. So I create a new support vector classifier, fit it again, split the data, train it, make predictions, and 92%. So we get around 90% of the accuracy. You can see again we get 93%. So there's a lot of randomness that's involved here, and when you get some accuracy score from the data set, it's not going to be set in stone. It's going to take some time, and when it does, it'll give you different results. So when you run the random search algorithm again, or the grid search algorithm again, you'll get different results. Let's take a look at that. So as you can see, now you're getting 91% of score, and the estimators are these. So if you wish to use the random search or grid search algorithm, do know that there's a lot of randomness involved, and as you can see, kernel, RBF, and gamma at 0.2, and we are getting a good result. So the accuracy that you'll be getting is going to be around 90%. Scale your data, pre-process it, make sure it's easy to digest by the computer, and make sure that you are using the correct tool for the correct job. If you have a lot of data, don't use grid search because it's going to take a lot of time, even with the scale data. And if you have you use the randomized search, you could probably get away with it using smaller data sets. For larger data sets, random search is quite good. You could get around the same accuracy score, and you would get it much faster.
So let's start this Kubeflow video by taking a quick look at some facts that you might or might not know. See, for example, did you know that Kubernetes has a huge community presence online just because it's open source, it's extremely powerful to use, and it's pretty easy to go about working with it as well, right? So one, it's open source. Two, it has a very supportive and a huge community to go with that as well. And then, when you think about the Kubernetes logo, right, it has always the ship, it's the anchor, and it consists of 7 spokes. Well, there is a meaning for that, and the 7 spokes in the logo actually refer to the project's original name. Before it was called Kubernetes, it was called as the Project 7 of 9, and that's how it's got the 7 spokes in the logo. And then when we think about anything open source, right, there's a lot of companies that come into collaboration to see if they can pitch out and come with a common solution. And here in this case, that was the same too, because Red Hat actually worked with Google to go on to develop Kubernetes even before it was actually officially announced or launched as well. So in that particular case, Kubeflow or Kubernetes in general being open source adds a lot of value to the community and of course to the people who are willing to use the technology as well. Now, coming to the introduction to Kubeflow. Well, what is Kubeflow, right? See, when you think about it, you have tools such as Adobe Photoshop for photographers out there, people who want to edit photos and all that. And then when we're talking about architecture and civil engineers, these guys have the AutoCAD tool, right? Now, what do machine learning engineers have when we're talking about using a machine learning pipeline which is hosted in a clustered architecture? Well, that tool itself, the entire platform is Kubeflow. So when we talk about what Kubeflow exactly is, you have to understand that it is one of these very popular open source platforms right now that will help us make use of setting up machine learning pipelines where we can run very complicated, very complex programs and have it run on Kubernetes clusters very easily as well. So by doing this, we can make use of the computation power, the resources, and a lot of other things, a lot of dependencies from multiple machines in a cluster at a time, and this can exponentially speed up a lot of complex things. And of course, whenever you talk about artificial intelligence, machine learning or deep learning, you already know that it takes a lot of memory, it takes a lot of processing power, power, and it's going to take more than this. It's going to take a lot of time to go on to provide a solution, right? Now think about, you're on a website, you have a chatbot that you're talking with, right? Or it's your favorite food delivery service, and there's a chatbot on the other side, and you're very hungry, you're asking where the order is and all of that, right? So in that case, if you send a message across to the chatbot, and if the chatbot takes 3 or 4 minutes to just put out one single reply with a basic reply, it doesn't make sense. So you need that kind of a speed, and it's not just you asking where your food order is. There's probably thousands of people who are doing that at that very second as well, right? So it has to cater to all of these people at once. Now when you consider of a situation like that, when you're thinking about the practical usability and the possibility of how overloaded a machine learning model's implementation can get, in that particular case, I believe Kubeflow is definitely something that helps a lot, especially, we're talking about Kubernetes, right? So Kubernetes is one of those tools that is extremely easy to work with. It's very, very powerful, right? So do not be carried away by the fact that it's easy to use, just that it is extremely powerful and it can achieve a lot of things with you doing a lot less. Now, why do I say this, right? See, what is Kubernetes first of all? Kubernetes is one of these tools where we can, create applications, deploy them, and operate them in a microservice architecture, right? So, but then how do we go on to do this? Like, we know what it is, but how do we go on to do this? So, what we try to do is we have a couple of hosts where we make use of the computation power of the hosts, but here we create an abstraction layer on the top, so we are in continuous touch and control with all of these hosts that we have, and you can work with it. You can deploy your applications very, very easily without you having to do many things, as I just mentioned, right? So when you think about Kubernetes, it's going to give you an ocean worth of control when it comes to deploying your applications and when it comes to continuous delivery as well. So in that particular case, it can get a little complex for beginners to get started with Kubernetes, but then worry not. With a good certification program, with good training, you guys can become experts in DevOps and of course in Kubernetes as well. So after understanding what Kubernetes is, how it works, and of course why we have to prefer Kubernetes, you really have to check out how Kubeflow came into the picture, right? See, so we're talking about machine learning and its orchestration on the Kubernetes platform, but then who are the people who brought this into existence? Well, to answer that question, you have really 4 big names you have to talk about. One is Google. Of course, Google is the key player in Kubernetes and everything that has to do with it. We have Cisco, we have people of IBM, and of course we have the experts at Red Hat as well. So these 4 guys, it's not just 4 people from this company, it's probably hundreds of people from each of these companies. They came together, they realized that they want to make use of the power of operations to make sure the machine learning pipeline is simplified, right? A developer should really not break his or her head about deploying the application. Their job is to make sure they solve the problem using code, and they write it and they're done. Now, to go on and take it into a production environment, you need the operating side, right? This is why we require DevOps. DevOps actually bridges the gap in between development and operations. So the people at development can worry about development. The people at operations can worry about, actually going on and taking all of these code and scaling it to production pipeline. And of course, you have DevOps engineers and developers and architects who have the capability to bridge these gap in between as well. So with this, you might have a question that states, how will Kubeflow help in today's world, right? See, whenever we talk about Kubeflow, the main thing you have to talk about is its performance, is its ability to work with machine learning pipeline, to host it, and of course to give you that kind of a power of making use of machine learning and orchestrating it very easily at the end of the day. So what Kubeflow actually does is it'll help you build machine learning models. You're going to get all the tools, the frameworks, and everything as we're going to check out in the components in the next couple of slides. So you're going to have everything foundational enough where you can get started working with the top machine learning frameworks out there, and you can in fact start working with machine learning and get it across ready to production as well. So you can do all of that just with the help of Kubeflow. And then it's not always about just building your model, right? See, building your model is one thing, but the second thing is to see how well the model actually performs. Now, to do all of that, you're going to require certain tools, you're going to require certain skills, and of course, you're going to have a platform that will support model testing too, right? So with Kubeflow, yes, you get features where you can help yourself, and of course help the product development team in a way where you can actually analyze the model performance in depth to see where the model, where the machine learning model is going wrong, what it's doing right, why it is doing the things it's in the way it's doing, and a lot of these things. So the primary aspects of using Kubeflow is to build machine learning models, and of course to analyze to see whatever you have built is either working fine or not. And then talking in terms of in the depth of machine learning, there's so many things that are involved, right? See, with Kubeflow you can actually tune out hyperparameters, you can fine tune the model, you can make sure your model is extremely accurate and that it achieves the solution in the best way possible. In terms of time, in terms of efficiency, in terms of computing power, all of these come at a price whenever you're in a production environment, right? So you have to count for all of these. And if there is one problem, right, you can probably have 3 or 4 ways a machine learning model can solve that problem. Now it is your job to make use of the analysis and to make sure you find the top way to go on to actually solve the problem using that. That's where tuning comes into the picture, and with Kubeflow you can do just that. And then when we talk about version controlling, right, see, in a production environment especially, right, in an official environment where you're working with a team, where you're working on building a product, it's not like you wrote a piece of code and that was the end of it until you close out sales or close down your company, right? So you will have version 1, version 1.1, 1.2, version 2, version 3, version 4. So you're going to have a lot of versions that will be coming out, and it's not just literally these versions being pushed out to production. It's just that you will probably have 100 people behind you who's working on the same piece of code. They're trying to achieve something, a part of the code that you might be working on, a part of the entire project that you might be working on, and everyone is trying to achieve their own subtasks to achieve the goal. Now, to keep a track of all of the changes that gets made in the code, to keep a track of who did what and what changes it had on the production pipeline, be the development pipeline or the production pipeline, and to track all of this actively, to roll back if there's any mistake, to update it to the latest versions, whatever it is, right? Version controlling is important, and Kubeflow is going to help you guys in a way where the use of version control is actually very foundational to the use of the tool itself. And then, as I told you, right, the next set of points we really have to talk about is your ability to control the computing power that you require for your model. Now, sometimes there is a very good chance that you might be running a very simple classifier, right? It can be a binary classifier, or it can be a very simple linear regression model, or whatever it is that might not require a lot of compute power. In that case, if you have and in that case, if you have a cluster which really does not have the latest or the fastest machines, well, yes, definitely you can get away with that. But what if you have extremely powerful machines and you're still using very simple programs out there, right? Of course, it doesn't hurt, but at the end of the day, if you have the ability to dial down the computing power or dial it up and throttle it out as and when you require, depending on the complexity of the machine learning model, well, that's going to save you a lot of time, money, and effort because there will be no bottlenecks that get created in case if the demand is more than the supply, right? For that particular case, Kubeflow is definitely helpful in controlling computing power. And then the next important thing we have to talk about is how we can take model prototypes into production. See, whenever you go on to develop and design a machine learning model, and if you guys are from a machine learning background, I'm sure you guys will relate to what I'm saying now. You will write a piece of code that will achieve almost, let's say, 80% of the task that needs to be done, and you call it a prototype. And now this prototype can go through multiple stages of being redone, being polished, and everything else to take it and make it production ready, right? So you have a piece of code that works, but then at the end goal, we want a product that works. So to take this piece of code into production and to make sure, it's being implemented actively, be it on a website, be it a chatbot, or wherever it's required, right? So to do that, to bridge the gap between taking it from prototyping to production, Kubeflow definitely helps here too. So the next thing that you guys might be curious about at this point of time in this Kubeflow tutorial is the name itself, right? See, Kubeflow comes from Kubernetes itself, but then what are we talking about? What is the connection to Kubernetes out here? And of course, whenever we're talking about Kubeflow, right, Kubernetes is the basic foundation on which it works. So you really have to know Kubernetes to work with Kubeflow. You really do not have to know Kubernetes in complete depth to be a machine learning programming person who's using Kubernetes. But at the end of the day, it'll always pay well if you are a Kubeflow developer that you know Kubernetes and machine learning well. Now coming to the actual talk about how the name came about, what does the name mean, right? Let's consider two things here. On the left side we have cube, on the right side we have flow. Now what we're trying to signify with the name cube here is that it runs these machine learning models run on Kubernetes clusters, right? It's this orchestration platform that we make use of. We have multiple clusters, we have multiple devices in each cluster that we can use to run our machine learning programs on. In that particular case, we're using Kubernetes, hence the name cube. So what we're trying to do here is we're trying to train multiple machine learning models across a lot of computers, as I told you, to leverage their speed, leverage their compute power, leverage their resources, and a lot more. Now, why would you want to do this? It's pretty simple, and I'm sure you already know the answer to it right now, because we want to exponentially speed up the execution. Now, if you have one computer that can run a machine learning model and it's going to take maybe 5 hours to train, but now you have a very powerful Kubernetes cluster that can do very similar tasks probably in 1 hour, which would you pick? 1 hour or 5 hours? Well, 1 hour, right? Similarly, now this 4 hours that you saved probably for your pet project it's simple, it's okay. But then if you save 4 hours in a production environment, you're saving a ton loads of time in a way where it'll either make or break your business in many of these cases. So it's very, very important to speed up execution and keep it as fast as possible. So now coming to talk about the flow part of it. See, with the flow part, what we're trying to understand here is whenever we say flow, it's basically a short for workflow, because we're trying to signal how the model should work, its training lifecycle, testing lifecycle, and all of that from its start, right? So from the ingestion of data all the way till we have results and we verify that the results work correct. This workflow scheduling is very important, and the flow part of Kubeflow talks about that. As I just mentioned, it helps in the complete machine learning lifecycle completion and working. And of course, what this does is, at the end of the day, the developer only has to sit and work on the machine learning code and not break his or her head about how they have to scale it into production and all of that. So this means it's effective and efficient development that's going to save a lot of time and of course a lot of money for the organization as well. So to do all of this, right, so what are some of the components of Kubeflow that will help us do all this? There are many components in Kubeflow depending on your level of expertise, depending on your level of requirement. But then the four most common things that you will use in Kubeflow is pretty simple. You have the central dashboard, you have metadata, you have Jupyter notebooks, and you have the machine learning frameworks that you will actually use to train the model. So let's check out each of these for a second. Now, whenever you talk about a central dashboard, well, this is how a Kubeflow dashboard will look like. However, this is a very old screenshot from the build version 0.7. We're going to talk about the latest version in a couple of slides as well. But then as you can see, right, so you have a lot of notebooks here. You have a couple of documentation things that will help you get started with it. You have a lot of shortcuts where you can create a new notebook server. You can view the pipeline. You can see what's running. You can check out the activities. You can do a lot of things at the click of a mouse button. So having this kind of a user interface and a very easy and a nice to use user experience, right? This is what drives the success of Kubeflow in my opinion, because at the end of the day, if you have to look at code all the time to think about operations, leave development. Of course, for development you're going to need code. Now for operations, if you have to keep doing this, it's a major headache, right? So that headache is completely solved by making use of a very elegant, very concise, very pithy dashboard.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Machine learning is a field of AI consisting of learning algorithms that A. improves their performance, B. at executing some task, C. over time with experience, D. all of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
In the case of Kubeflow with this. And the second thing is, whenever you're working with machine learning, there's going to be a lot of data that gets generated even before you run the model, and of course a lot of data that gets generated into information after you've run the model. So there is data that actually is used to help understand what the all the components mean and all the data mean, and that data is metadata. Metadata basically describes data. Now, in a machine learning scenario, you will have a lot of lot of data, such as how many executions were conducted, what was the epoch times in each of these runs, how many training sessions you had, and there's a lot of things whenever we just talk about execution as well. So considering the data just that gets generated out of execution is large, and then of course you'll have the model data, you'll have input output components, where of course if you have a model, it means it has a data set. You have to describe the data set. The data set has to be understood by the machine learning model. So all of these individual files that we talk about will have sub dependencies among them, right? There are many files that's required to run a machine learning model. There's many objects that you'll have to consider in terms of input output components. You have data sets, you have the actual model training files, post training files, and there's so many files that you have to talk about. In the case of Kubeflow, right, so this is one important component that Kubeflow provides, where you can simply analyze all of this, manage all of this, and of course at the end of the day use it to see what your model is doing as well. So you have something to describe what your model is doing, and that is metadata. And the third thing that we'll have to talk about is the Jupyter notebooks. See, whenever you're writing a program in Python or in a notebook online, it's a good chance it's a Jupyter notebook, right? Now, in the case of Kubernetes, where you're running a Jupyter notebook across a server, where the server is orchestrated across a Kubernetes cluster, you're gonna need one common place. You're gonna need one notebook where you can work with all your data, right? And of course, with Kubeflow, you can make use of your regular Jupyter notebook, and I'm sure all the developers that we have out here have been comfortable with using Jupyter notebook. It's very simple to use, and it's one of the preferred ways of how a lot of us developers write code as well. So in that case, this actually helps in a way where you can completely concentrate on using Jupyter notebooks for writing code. And the next important component we'll have to talk about is the machine learning frameworks that we can use. See, there are four main machine learning frameworks that that act as a serving that we can kind of use to deploy all of our models through and work with it as well. You have the MXNet, you have PyTorch, you have Chainer, you have TensorFlow serving, and you have a lot of other machine learning frameworks that are supported by Kubeflow too. So this mostly is what you would require to go on to solve a problem with machine learning. And down the line, of course, whenever you're talking about machine learning, it's an ever growing field, so you can definitely expect to have more of frameworks come into the picture with Kubeflow, and with thousands of people actively contributing to the world of open source, it should come as no surprise to you that there'll be complete support of making use of all of these in the Kubernetes architecture as well. So that is something really important, and that you really should know about. So now, on the next section, we can actually talk about how machine learning works with Kubeflow. See, machine learning is done by whom, right? Who is the person who's responsible for achieving machine learning? Either data scientists, or they are either machine learning engineers, right? So these guys have the complete power to make use of powerful computers around them, and to use these computers to the best of their efficiency, to make sure that that the computer is working in an optimum way, where it's providing the maximum performance possible. Now, if you're thinking about the same scenario in a cloud computing environment or on a Kubernetes environment, that's going to take some time and skill, right? So this is actually what happens when people go on to implement Kubeflow in their existing machine learning chain. You have data scientists that will create the machine learning models for you, or of course machine learning engineers as well. And once the models are actually created, right, there is an ops team that sits in the picture, where they're going to take all the machine learning models that get created by data scientists and machine learning engineers, and then they take it into production, as we discussed before. Prototype to production. On the left you have prototype, and of course you're going to get the final final production code on the left side itself. But then to take it to production, to bridge the gap that exists between development and operations, we have people to do that, and these guys are experts, and they're called as ML ops experts, because machine learning operations is what ML ops stands for. And this is very much required in a production environment too. And to check out the next set on this tutorial, you might be wondering about what is so complex about machine learning that even with Kubeflow sometimes people find it difficult to use. See, there's three main things, right? See, when we talk about machine learning, first of all, you guys learning machine learning and providing a solution for a problem that's out there is going to take a bit of time. So it's not just time that it's going to take; it's going to take equal amounts of effort because, hey, let's face it honestly here. You're using a machine and you're trying to ask the machine to replicate human intelligence. Human intelligence, in a way, is probably the most intelligent thing right now. But so if you're asking a machine to do it, so even though the machine has extremely powerful computation power, probably quicker than humans, it has a lot of things that, but it doesn't have a lot of things that we do, right? That's what makes machine learning complex to achieve in the first place itself. So it's going to take a good amount of time, it's going to take a good amount of effort, and of course, at the end of the day, the result that you will see is worth the time and the effort that you put into machine learning, is what I wanted to convey. Now, when you're talking about the complexity of what goes on in a machine learning pipeline, right? See, the first step involves data collection. This is probably the place where it's going to take the most amount of time because you need a data set, you need to pre-process the data set, you need to clean the data set, and you need to find out the problem, you need to find out the data set that solves the problem. So collecting data is one of the most important steps when we talk about machine learning. And then of course we have feature extraction. Feature extraction is when you'll keep whatever is required and throw away what's not. This feature extraction is a place where you filter out things and you understand what's required for your model and what's not required. This is a very important step as well, and of course I just put it on in a very simple way, but actually implementing it will take some effort. And then we have model configuration. Model configuration is where you have to understand what type of machine learning should you use to solve the problem. Once you understand that, you must have a model which will make use of the types of algorithms that you think is right for the solution. Be it supervised algorithm, unsupervised, it can be reinforced. It can be reinforcement learning and a lot more as well, right? So you need to find what model to pick and you need to configure it to at least have the bare bones of it working. And once you understand what you need, all the tools that you have, all the data that you have, and you're ready to actually put it all into code, well, yes, here is where you will require a machine learning engineer or a data scientist to put all of these into effect by converting and typing out the code in multiple programming languages, be it R, be it Python, be it Java, or any other language that supports machine learning as well. And after that, you have something called as workflow monitoring. With workflow monitoring and process management is a way where we're talking about the operations side of machine learning. Once the code is written, once the model is working, once it's verified that yes, this is a solution to the problem, you will have to keep on monitoring it to see how it moves around through the life cycle of the problem. Can it be made better? Version control, how many people are working on the project? Is the project actually complete? Have you met all the all the requirements from the client, and a lot of other things, right? So to monitor all of this easily, the operations part of it handle all of these too. And then process management, right? See, it's not just that you're done as soon as you write the machine learning code. It's all about getting this code ready as a product or an application to the people who are willing to use it or the people who have paid you to build it. Now, this is another very important thing that follows workflow monitoring, because there's a lot of things in each of these steps, right? See, for data collection, I can probably tell you 10 steps, and for feature extraction, another 10 more steps. So we can talk about 100 steps before we come to the process of workflow monitoring. Now, to break, manage, and make effective use and keep a track of all of these 100 steps, you're going to require a person who's going to sit and manage the life cycle of a machine learning model, right? That is where process management always takes center stage. And then coming to the talk about how Kubeflow came to the picture, even though Kubeflow has been in testing for a while now, there's a lot of beta tests available. The official version 1.0 of Kubeflow actually launched in March of 2020, right? So it wasn't very long ago, but then now there is complete support for Kubeflow. And a lot of people, a lot of companies, in fact, thousands of companies have realized the power of Kubeflow, and everyone wants to use and jump on it to see how best they can use it. One, because it really doesn't cost any money because of its open source nature, and two, if it's open source, it means that there is just thousands and thousands of enthusiasts, people, developers, and a lot of other people with interest who will be developing the product as well. Now, if I was a person who was contributing to the open source community for Kubeflow, let's say I use Kubeflow, I find that something is wrong or something can be made better. What do? I basically, fix something or suggest changes, or actually go on to roll out the changes and tell people saying, hey, this is how I've done better. Now, do that 1,000 times over with 1,000 different people. You have a product which will be polished very nicely with, I'm just giving you a random number here saying 1,000, but there'll be, of course, a lot of other number of contributors out there as well, right? So each of these guys bring about their best to develop the software, and in an open source nature, that will help a lot. And one thing is that the entire Kubeflow project that's happening right now, right, be it from its launch to every single day, the progress these guys make in the community, it can all be tracked on the official Kubeflow GitHub as well. So if you head on to that GitHub, you can check out, right from the inception to where they are now. And I think that in your journey of learning Kubeflow, you really have to understand where these guys came from, what the product was when it officially came out, where it is now, and of course where it is headed as well. So when you're talking about making use of Kubeflow, right? See, Kubeflow is one of these platforms that you can use across a wide variety of cloud computing platforms that are out there. Be it Amazon Web Services, be it GCP or the Google Cloud Platform, be it Azure, be it the Red Hat OpenShift, be it IBM Cloud, and many other clouds as well. So if you are a person who's using any one of these cloud platforms, or if your company is using it, or if you plan to doing it, understand that you can actually go on to implement Kubeflow without you having to put much effort as well. So in that particular case, if we were to show you saying, hey, this is how it works on Azure, or this is how it works on the IBM Cloud, and if you're a person who's using Amazon Web Services, it really won't make sense to you, right? I mean, of course, at the end of the day, you will find out the basics of it, but to understand it in depth, you really have to first find out what cloud platform you want to use. And after that, once you know what cloud platform you want to use, understand that Kubeflow supports everything. So with that in mind, you just start to see the official documentations to see how you can get started with Kubeflow for that particular cloud platform, and then begin working on it as well. And then the second biggest advantage we have to talk about is the TensorBoard support, right? See, we already spoke about how you guys can use TensorFlow and how well you can implement it using the Jupyter Notebook in the cloud computing platforms too. With TensorFlow comes one of these beautiful visualization tools called as TensorBoard, and TensorBoard is completely integrated into use whenever you guys are going to use Kubeflow with all the single features that it brings. So with this kind of a support for TensorBoard, what you can do is you can tune out all the model parameters, and you can work with the performance checking and analysis of your models, and tune it based on your requirement, right? At the end of the day, it's going to save a lot of time, it's going to save a lot of effort, and if you have saved time and effort, it means you're making more money in a production environment, and it is as simple as that. It's not just saving time and money. When we talk about TensorFlow, you have to understand that this kind of a data visualization that we get, it's extremely aesthetically pleasing to use. It's completely functional in a way where if you probably see a lot of data in charts, you might not pick up a fault in the data, but then as soon as you put it out and lay it on a graph, that'll stand out to you like a sore thumb. So in that particular case, using TensorBoard is something which is very effective too. And then when we talk about model deployment, right? See, with model deployment, it is extremely important that you understand that, TensorFlow it's ready to use with TensorFlow. Of course, you can use PyTorch, you can use frameworks such as Sckit-learn as well. And with this case, you have to understand that depending on your model complexity, you're going to require resources, right? So in this particular case with Kubernetes, you have something called as autoscaling that happens, right? So it will go on to assign these resources automatically based on the level of computing power your machines need, and it's going to start scaling from maybe 1 machine in a cluster to 10 machines in a cluster, 100 machines in a cluster, to go on to actually have the best performance possible too. And then when we have to talk about the Kubeflow serving as well, right? So this is one of these tools that will run locally and on the cloud premise as well. So it is not that you have to have a compulsory cloud setup to make use of Kubeflow. If you have a local network architecture where you'd want to use this, of course, you can use that as well. So that kind of a flexibility is really one of the big advantages that comes whenever we talk about model deployment. And then with model deployment, with this kind of ease of use, it means, of course, efficiency goes up again. When efficiency goes up again, you save time and money. You're making more money to the organization itself, right? So guys, now let's take a quick look at the GitHub and of course take a look at the Kubeflow website as well. And now, coming to the GitHub, as I told you, you can track their entire project here, right from what's happening right now, all the pipelines that they have, the manifest, the websites, their entire community and everything. So they have a huge GitHub profile where they have a huge GitHub profile where you can check out a lot of things here. So make sure at the end of the day, before you start working or as and when you start working towards learning Kubeflow, right, understand what they're doing in a way how best you can use it, right? So you can there'll be all the top languages that they've put using. You can see JSON.NET, people are using Go, TypeScript, Python, and a lot of others as well. So if you just click on these repositories, you will see a lot of things. And of course, whenever you talk about all the dashboards that go on to use it and all the tests that go on to see if these dashboards are functional, the updates are working or not, you can find a plethora of information on this particular website. So I would really suggest and urge that you guys check it out. And after that, coming to the actual Kubeflow website, to get started with, to get a quick start, you can of course take a look at the documentation to get work with, right? It's one of the biggest machine learning toolkits out there right now. We have to work on Kubernetes. And one important thing, as I mentioned in our session, before you start working with Kubeflow, right, you need a basic understanding of Kubernetes. And of course, you're going to need something called as Customize as well. Customize is one of these configuration management tools that will give you a template free way on how you can work with the tools as well. So in that particular case, you really wouldn't require a lot of customize, but of course the knowledge on Kubernetes is definitely something that's needed. So you can see how you can go on to choose a Kubeflow deployment option as well. Do you want a single node deployment where you're going to run everything in one particular node on a cluster? You can do that. Do you want to have a cloud deployment based on all the types of clouds that we discussed? It is possible. So do you want on-premise installation? Do you not want on-premise installation? So based on all of that, right, it's going to give you a lot of flexibility to go on to get started as well. But then, as I just mentioned, to go on to use all of these on a cloud platform, guys, you really have to follow certain basic rules. And of course, it's not just rules, certain installation steps that are out there. See, for GCP, these guys have a deployment guide. For AWS, they have another one. If it's Microsoft Azure, what we call as AKS, then of course they have another one. IBM Cloud, there's another one. If we have more documentation for OpenShift as well. So to deploy all of these, what's the first step? You really have to go on to install it, right? So these guys will give you the complete steps that you need to basically get started with it. Of course, you're going to need a lot of training to use it. You're going to need a lot of head start, a structured way of learning to understand first of all what this is, why it is used, all the things that we already checked out, and then actually using it, right? So in this particular scenario, depending on where you want to deploy Kubeflow, they're going to give you install instructions. They're going to tell you how you can uninstall it, how do you create a cluster, how do you use the ICRs or what we call as the IBM Cloud registries. There's so many different things, and of course they provide all the basic documentation to do this, and that's what makes me very happy about it. And then once you are ready to, let's say, go on to use it, now you want to make use of Kubeflow on the IBM Cloud, they're going to give you in depth about how you can first of all deploy it, and how you can install it, how you can secure it, and all of that, right? So with each of these tools, it's basically a very simple command line interface. You're going to need a command line interface where you log into the cloud, and once you log into your cloud, be it AWS, be it IBM, you just have to run a couple of commands there to make sure you can get all of your storage up, everything, and you can work with the deployment process. Well, you're going to have to build the code, you're going to have to allocate the resources, deallocate the resources whenever it's not required. You have to configure auto scaling, multi-user mode, version controlling, and all of that, right? So you have all the code, all the documentation basically that's needed to get you guys started. So if you just click on the documentation part on their website, you should have the basic understanding of how you can go on to use this on any cloud platform of your choice that these guys support as well. Coming to the comparison between artificial intelligence and machine learning, let's break it down into a couple of simple points. The first thing has to be definition. We've already looked at this, so let's quickly glance over it again. Well, basically, in the world of artificial intelligence, the intelligence part of it is actually defined when we talk about, the machines gaining knowledge and, the ability to actually learn something and pretty much apply what it has learned. This particular stored knowledge, that is where the word intelligence comes in. Coming to machine learning, again, machine learning learning basically involves the process very similar to artificial intelligence, where it's acquiring information, but then it's doing it in a very different way. There's something called repeated learning, where it actually learns on one particular concept again and again to master it and then understand what the concept actually is. Then coming to the second point, which is the technological aim of artificial intelligence and machine learning. Again, when it comes to AI, pretty much AI is concerned about increasing chances of success in actually mimicking human intelligence. So it at couple of stages, artificial intelligence is not concerned with how accurate it is, but it's a very different story when you come to machine learning, because when it comes to machine learning strives to increase the accuracy, and it would actually sideline the amount of success that it sees, because achieving accuracy in a mathematical model in terms of machine learning is actually a very good priority, and it is actually built for what it's supposed to do, and it does it very well. Coming to the third point, it is basically the goal of artificial intelligence and machine learning. When we talk about the goal of AI, it is to, again, as I've already told you, to simulate natural intelligence, to prove to humans that machines can be as good as humans, and this is done by solving complex problems and whatnot. Coming to machine learning, again, machine learning, the primary goal of machine learning is to actually learn from the data that it actually sees, understand what the data is, then perform certain tasks using the data. Since it does it repetitively, it understands it better and better every time it does it, and this increases the performance of that particular machine. And then the fourth point is how simpleton it actually is. Well, artificial intelligence, put in very simple terms, is basically that it is decision making on steroids, because to a computer what feels like a very complex convoluted entity, it is actually a very simple dumb machine which has been coded by the humankind, right? So artificial super intelligence claims to, if it has ever been founded, or if a machine chooses to start coding another machine, the decision making skills of an artificial intelligence entity will be equal to that of human intelligence, or better than that as well. Coming to machine learning, again, machine learning basically allows a system or a computer to learn things from the data it sees, does it repetitively, as you already know it. And coming to decision making, again, as we already talked about it, artificial intelligence is actually concerned with finding the optimal solution to an existing problem, but machine learning is used to see if the problem is actually pretty much optimal to work on or not. So it'll actually try to see if the solution, whatever it's obtained, is actually optimal, it's not optimal, it'll work, it'll not work, and much more. So here's a very subtle difference that you can see on your screen right now when it comes to artificial intelligence and machine learning. And then number 6 on this list is the outcome. So artificial intelligence, again, leads to developing system which basically will mimic human activities in certain circumstances. But then at this point of time, it can mimic everything apart from emotions and much more. In fact, it can detect emotions. That is how good it is. But for it to mimic human level emotion is impossible at this point of time. But then let's not say it's impossible in the future as well, because we do not know what the future holds. And then coming to machine learning involves this entire procedure where you will be creating algorithms which learn on their own. And here's the best part about the comparison: machine learning will help achieve artificial intelligence at the end of the day. So the outcome of artificial intelligence is to equal human intelligence, guys. So this brings us to the 7th point, again, which is a very important point for all of you guys as learners, because here's the average developer salary of an artificial intelligence developer and a machine learning engineer. An AI developer gets somewhere over 120,000 USD per year, and then an average salary of a machine learning engineer is over $100,000 per year as well. Well, this number is an average number for an associate to a junior or a middle intermediate level programmer, but do know that there are companies out there in the world which will actually pay 3 times 4 times the number you see on your screen right now throughout the world. So they don't mind where you are, they don't mind what amount they're paying out if you're actually good with the skills and you have the right certification when it comes to especially artificial intelligence, machine learning, and concepts of data science, guys. And then coming to my final thoughts about this particular comparison, well, if it has to be put into one sentence, then know this: artificial intelligence will lead to intelligence at the end of the day, or some sort of wisdom. But if you're talking about machine learning, again, it's all about acquiring knowledge, and this knowledge again is put into use when we talk about artificial intelligence in general. So to summarize the entire thing, guys, artificial intelligence will actually use all of the experience to acquire knowledge, to acquire skills, to learn it and understand how it has to apply all that knowledge. And machine learning will basically use all the experience it has from learning again and again to basically look for some pattern, understand what's going on there, to amplify the amount of knowledge it has gained, to see where it's like picking a needle in a haystack. So machine learning is where it's the process of picking the needle in a haystack, where we're talking about artificial intelligence. It finds the fastest way, it finds the most important way where a human is not required to pick out that needle from the haystack, guys. So coming to when you have to use artificial intelligence, when to use machine learning, here is when you'll be using artificial intelligence. Artificial intelligence is required in situations where there is a requirement of precision, where there is a higher degree of precision is a very important requirement. And then you will use AI when you have faster decision making, logical decision handling, which does not require any human interference, guys. Because at the end of the day, emotions do come into place at a place of work, which might affect at the end of the day the work that the person is doing. But then if a machine does this, again, it cannot understand emotions. So your work will again remain very efficient because of the fact that it cannot have any emotional interference. And then coming to handling repetitive tasks, humans might get bored of doing the same thing again and again, but the machine does not. And then the next point is the reason why AI replaced a lot of jobs in the last year. It is that it can work 24/7, 365 days of the year without taking any single break, unless there's, of course, a breakdown in whatever it's doing. But then without a break, because humans again are very, very limited when it comes to working when you directly compare it to a machine, because machines can go years and years without a single break, but a human cannot, obviously, right? And then coming to risk analysis and risk taking, the machines can actually take a very good calculated decision.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Which of the following are machine learning methods? A. Based on human supervision. B. Supervised learning. C. Semi-reinforcement learning. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Based on so many things, so much mathematics, so much programming, and much more. Coming to machine learning is actually used where it can see the data and see a trend or a pattern that it can find. And another important reason is that there should be no human intervention here as well.
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
The basic idea is to make the model self-sufficient enough so that it can understand the patterns and trends. And then, if there is a requirement for machine learning, then there'll definitely be some sort of requirement for continuous improvements, continuous learning, and hunting for more knowledge. So this brings us to the point which says that, improvement needed is actually linear. It does not have to be, learn, wait, forget, and no. It has to be learn, and keep going like that. That's what the point basically means. And then coming to the next point, it does not require any human intervention when it comes to adaptation as well. So humans take a lot of time to adapt to, let's say, to a new climate, to a new technology they're learning on, everything in general, right? So humans need some time to go about doing that. Machines, well, if there is a requirement where you have to change certain programming language to something else, and nowadays there are tools which can do it automatically for you as well. And then industrial requirement are there, guys. So basically what we're trying to do is we're trying to perform predictive analytics in the world of manufacturing as well, like what product is doing good in what part of the world, why is this car selling so much more. So you have machines which can tell you all of this. You don't need any more humans to look at the numbers, plot graphs, and go about taking a judgment call, which might be a little inaccurate at the same time as well. Let us get this out of the way right now. So machine learning engineers are extremely sophisticated programmers who develop systems, machines, and these machines can pretty much go about learning on their own and applying knowledge, and they would not require any specific direction to pretty much go about doing the same as well. So if you think whatever job you're doing or any other computer science job is cool, well, think about it again, right? A machine learning engineer job seems amazing. So what is the goal of a machine learning engineer's job? Guys, To put it into one simple sentence and to just hold it under one banner, one umbrella, say, this is what I would put it as. Well, achieving artificial intelligence is pretty much the primary goal of any machine learning engineer, guys. So by achieving artificial intelligence, I mean, those are some big terms there, right? It might be anything, something very small, right? So let's say they're just, customizing a chatbot, or they just want to probably dim the lights in their office for Diwali or something. Think about it, so many things, right? So a machine learning engineer can cover everything from these simple things all the way till guidance to Mars or guidance to Moon, and help our space agencies as well, ISRO, NASA, SpaceX, and so much more. We have machine learning engineers everywhere in the world. So, and the main important thing that you guys need to know about a machine learning engineer is that this role, right? So this role requires the person to talk to a lot of people, a lot of different teams in the office, and hence it'll include a lot of customization as well, because every client's requirement for artificial intelligence purposes, or let's say they have a particular requirement for machine learning, and this changes from every person to the other person, right? So this one particular job where you'll be extremely creative and where you'll be on your creative front foot at all the time is pretty much a machine learning engineer's job. So what are the requirements of a machine learning engineer, guys? So think about it. Well, to simplify it, just for the sake of this video, I've put the requirements into two tabs, guys. One would be the educational requirements, and the other one would be the skill requirements. Well, let us begin by checking out the educational requirements. Well, think about it, right? So pretty much for being a machine learning engineer, you need to have a very solid background in something, right? So this is one of the very hyped, designations out there. Well, the most important thing that you would need to know is that these machine learning engineers pretty much they're either out of their masters, or they have a doctoral degree in computer science discipline, and so much more. Well, fear not if you do not have a master's or a doctor's degree as well. We're going to pretty much guide you through about how you can pretty much go about becoming a machine learning engineer. And the major important field of study here, again, guys, pretty much you would have guessed it by now, it is computer science. Well, instead of or mathematics, let's say and mathematics, because machine learning is a world which revolves around mathematics, and then you would be applying these mathematical concepts with respect to code. So it's computer science and mathematics, guys. So again, you might be wondering if experience is required, before applying or anything. Well, yeah, majority of the companies pretty much ask for about 4 or 5 years of experience in the same field of artificial intelligence or machine learning. Well, so aren't there any fields for any juniors? Well, fear not, my friends. Pretty much everyone these days is hiring for an associate machine learning engineer and an associate software engineer in the field of artificial intelligence and so much more. And I'll be walking you through all of the jobs as well. I have a very good couple of statistical numbers that I think you guys might be interested in. So on that note, what are the programming languages you might require, right? So top of the head, I think you would require C++, guys, or you might require Java as well. You might require Python and so much more. But then the educational requirements, the foundation has to be computer science and mathematics. So it's a combination of both, guys. Let's say the best of both worlds. So coming to the skill requirements again. This is the expanded version of the educational requirements, by the way. So with respect to the skill requirements, again, it requires exceptional mathematical skills in order to perform computations, right? And work with all of the algorithms, because again, machine learning is full of algorithms, and then working with each of these algorithms, especially calculus, you would require probability, you will require so much more, right? So you will require the concepts of differentiation, integration, and so much more. So knowing offhand that you're very good at these skills is again a very good asset to have for a machine learning engineer, guys. And then communication skills are extremely important because you might be wondering how I am very good at coding. Why would I require communication skills, right? Well, you need to explain what you're doing to the people who are non-programmers. Let's say these people that you have to explain to are your respective managers or your directors and so much more. Well, they might not have the skills required to probably type out the entire algorithm or pretty much do a binary classification in Python and so much more. Well, they would not know that. And you have to communicate your work to them in such a way that you are understood, right, at the end of the day. And then again, you need to put it out in such a way where you'll be publishing articles on the work, or let's say you want to do more research work as well. Well, you need people to understand what you're saying. So communication skill again is extremely important, guys. And the third important skill that's required is very strong analytical skills. Well, analytical skills again is extremely vital because again, think about it. There's a lot of analysis with a lot of data that's going on in the backend. So emphasis on a lot of data, because again, you'll be working with your big data architects as well. They'll be pretty much giving you all the data. They'll be cleaning up the data for you. You'll have to be working on the data. Run a couple of algorithms on the data, further clean up the data, do so much more with the data. So having these analytical skills to pretty much take raw data and make it, convert it into information, this is a very good asset and a very good requirement for a machine learning engineer, guys. So again, as we have already been kept on mentioning for a while now, the type of programming that machine learning engineers do is very sophisticated, guys. Well, fear not if you do not know the type of programming these machine learning engineers do. Stick to the end of the video and I'll be guiding you on how you can get certified in the same, guys. So on that note, we need to check out the roles and responsibilities of a machine learning engineer. So what are the different roles that are expected out of a machine learning engineer, guys? Well, it says that, you're supposed to assert all the production tasks to check if they're working properly in terms of execution and scheduling. Well, good enough. You'll be checking execution and scheduling as well. You need to abuse machine learning libraries to their extremes. And this again will lead to adding new functionalities, exploring new ways that you can, sell your product better, make your product better, engage with different audience and so much more. And third one, ensuring that, your data science code is always maintainable, always scalable and debuggable. Let's say you're just a company of 10 people right now and you want to move it to, let's say, 1,000 or 10,000 people, right? So having that scalability feature and implementing machine learning to do it for you is again amazing. Having it debuggable as well. Well, think about it. Let's say you'll not be the only one in the entire company working on some machine learning concept, right? You will have teammates, you will have peers, superiors, juniors, and so many people, right? So all these people have to combine, come together, understand the code, what's going on. If there's a mistake, then each one has to debug each one's work and so much more. So again, having maintainability, good scalability and debuggability in the code is very good, guys. So again, the fourth thing is to automate and abstract away very different repeatable routines that are present in most machine learning tasks. Well, you need to figure out how to make it unique for your organization, right? Because with respect to machine learning, it's a lot of iterations, it's a lot of doing the same thing that everyone else does. Well, you need to stray away from this to make sure that you can do something on your own, keep it unique and keep it very efficient at the same time. And then the fifth one again is probably the most important thing, guys. Well, it is to bring up the best software development practices to the data science team and help them speed up their work. Well, think about it. Your data science team in any company, let's say as a machine learning engineer, even you would be a part of the data science team. And to bring out the best software development practices, having them combine with each other, making sure that they gel with each other, all your work is going good, your data is being handled perfectly, your data is being machined perfectly, it's being analyzed perfectly, and so much more. And then choosing the best operational architecture together with your DevOps team, right? Again, the DevOps team forms one of the very pillars of any organization, in my opinion, guys. So working with them to find out the best architecture that holds everything, the development side, the operation side, everything together, and to bring it under one umbrella. Again, this is a very important thing, guys. And then the next important thing would pretty much be to go on, check for performance improvements wherever you want, wherever you can, and then deciding, here's the important part, you need to go about deciding which machine learning technologies that you need to put in a production environment there is, guys, because you will have a couple of testing environments, working environments, production environments, and so much more, right? So you need to know what machine learning technology needs to be put where. This again is a very important role of a machine learning engineer, guys. So coming to the responsibilities, let me walk you through quickly. Well, A machine learning engineer's responsibilities pretty much start out like this. Well, running your machine learning algorithms using a programmed language with machine learning libraries, again, you need to perform a lot of experiments to know what works for you, what doesn't work for you, what works for your company, and so much more. And then the next thing is to pretty much go on to deploying your machine learning solutions directly from testing into production, guys. And this obviously calls for optimizing all of the solutions with respect to performance, with respect to scalability, and so much more. And the next thing is pretty much data engineering, right? So you need to have amazing data flow in between your databases, in between your backend systems, to make sure that everything in between your front end, back end, all your data, the data movements in the entire system, the process of data engineering, what we call it, is working as it should. And this would be an advanced responsibility, I would say, but then it involves implementing custom machine learning code, which again is pretty much depending on your company, depending on your firm, your team size, so much more, right? So that would be unique to each and every one. And then analyzing all of the data that comes with it, coming up with different use cases for all of your data, doing so much more, guys. So if you've been following me through the roles and responsibilities slide, then it pretty much sounds it sounds a lot overwhelming, right? Well, the overwhelming job pretty much pays amazingly well, guys. So make sure you stay for a little while. I'll be discussing the salary as well, and the salary of a machine learning engineer is amazing. So, on that note, we need to check out a machine learning engineer's job trends. Well, here's what I could pick up from Forbes.com. So, an esteemed writer there pretty much says machine learning engineer's job is the best job in the United States, according to the website, very famous job hunting website called Indeed.com. Pretty much again, artificial intelligence and machine learning job postings on the website of Indeed rose almost 30% over the last year, in between May 2018 and May 2019, guys. Well, think about it. 30% seems like a small number, but every day Indeed's website pretty much gives way to about 1,000 new jobs, and at the end of it they have lakhs and lakhs of jobs. Now what do you think is the number which forms when we calculate 30% of a lakh jobs? That many new jobs just got added in between the duration of 1 year, guys. Just 1 year. So how amazing is that? And here are more statistics for you. There has been around, let's say, 5,000 machine learning engineering job posts on Indeed.com's website in just India, guys. Whatever you're looking is all the cities that are present in India. Well, here's the location-wise division of machine learning engineer job posts. In Bangalore alone, we call it Bengaluru. Well, in Bengaluru alone, we have 1,500 new jobs that are posted on Indeed's website. In Hyderabad, we have 500 jobs. In Pune, we have 300 jobs. Chennai, 200 jobs. All these jobs have the designation machine learning engineer with them, guys. So think about it. How amazing is this? When people go about saying artificial intelligence or machine learning, does not have any scope or has very less scope compared to, let's say a Java developer or something, guys, the numbers are right in front of you. This again pretty much comes up to over 2,500 jobs in just the majority of the cities in India. Well, if you think India was just the common playground, well, think about the world right now. Let me bring you a couple of statistics from the United States of America, guys. So there are about 30,000 machine learning engineer jobs posted again. Seattle has about 2,500 job postings. New York wants 1,500 machine learning engineer. San Francisco wants 1,400 of us. Chicago wants 500. California wants 500. Again, these numbers just keep going up. Well, every time pretty much I have this schedule where, every 3 months I just keep coming to these job hunting sites to check out what the trends are. And to my astonishment, every time I come step out there, just search for something, it's amazing. All these numbers always keep going up, and I am flabbergasted every time I just take a look at these numbers, guys. So on that note, how are the divisions? Who are the companies that are hiring so many people around the world, right? We have Amazon, who top the top the numbers when it comes to hiring machine learning engineers, because they want 2,500 machine learning engineers across the globe. Next, we have JP Morgan Chase, and Morgan Chase people who want about 1,000 of us. Microsoft wants 500, Accenture wants 300, Google wants 300, Google wants 300. Whoa, that's cool, because I was expecting, because Google pretty much has their own DeepMind, their entire TensorFlow project set up and running, and they still want 300 people more. Is amazing. So Google always is on their front foot when it comes to hiring machine learning engineers, guys. Cisco, the world's biggest network company, probably, they want 250 of us. Facebook wants 200 people. Well, Facebook again has this amazing machine learning and deep learning team and aspect when it comes to that, and they run their own people who work at Facebook founded PyTorch, and they have so much more, guys. So it is amazing to know that they require 200 machine learning engineers as well. And Deloitte is an amazing company, and these guys require 150 of our machine learning engineers as well. So the world is your playground, guys. As you're looking at it, so many jobs are there. You just need to find the right path to get from where you are and into these companies, right? So let us take a moment and take a look at a couple of job descriptions from a machine learning engineer. Again, I had to pick up Google, because Google is a fantastic example and a fantastic benchmark when it comes to machine learning, right? So Google has again posted around 300 jobs looking for machine learning engineer on Indeed.com, just as we saw. Here's a sample designation that they're looking for. They're looking for software engineers with respect to machine learning. And here are the responsibilities, guys. Well, software engineers on the operation research team will have two roles. One role is to develop combinatorial optimization solvers, and then the second thing is to help customers, and these customers might be inside Google, outside Google, to solve their optimization problem. So Google is hunting the optimization train because of their operations research team, and then participate in cutting edge research with respect to artificial intelligence and machine learning applications, develop solutions for real world large scale problems. Guys, we're talking about Google, probably the world's biggest company, right? These guys are encouraging in their job responsibilities that they pretty much want you to, sorry about that. So these guys, again, they're indulging you and they're wanting you to pretty much go get into research, do more research with respect to artificial intelligence and machine learning as well. Think about it. And if you're not convinced enough, here is another job description from the big company called American Express, guys. So these guys again have about 50 jobs looking for machine learning engineers on Indeed.com, and they have the designation looking which is perfectly matching to ours. It's called as the machine learning engineer. So what are the responsibilities of the people at American Express? What? Well, they say that 70% or more of your time will be spent on coding or technical hands-on analysis and implementation of reusable frameworks to drive adoption of machine learning in Amex. Amex is short for American Express. And then combine your data science and your engineering skills to solve very interesting problems that pretty much go about directly and greatly impacting millions of individuals worldwide. Whoa, read that again. Directly and greatly impacting millions of individuals worldwide. How cool is that? And then not only creating machine learning prototypes, but also taking these prototypes from their prototype stage and putting them into production and scaling them up. Whoa, this is amazing. And then being a part of be part of a dynamic team. They say that their team is already dynamic. Okay, beautiful. And then they say that play a visible role in implementing cutting edge technology and machine learning solutions with other industry leading partners. Amazing. So think about it, right? So a machine learning engineer works in team, with in the same team, other teams in the company, and then they're participating in worldwide competitions as well with respect to their industry leading partners, competitors, and so much more. This is why I love the world of machine learning, guys. And then lastly, they want you to work with a large complex data set which is used to build products and tools that enhance colleague and customer experience. Well, at the end of it, any product company would want to enhance colleague and customer experiences, right? So coming to the most important slide that you guys probably are waiting for is the machine learning engineer salary, guys. Well, I have very big numbers for you. Again, think about it.
We already talked about how cool a machine learning engineer's job is, right? And you need to go get that number one ranking job in the whole world of computer science, and then you'll be presented with an average salary of $95,000 per year. So this is in American dollars, guys. Well, I had to bring the number down. It starts all the way from $80,000 and goes all the way to $160,000 per year. So I pretty much averaged out the entire salary and came up with a figure of almost $100,000. But then, if you had to look at the salary pretty much around the world, it is $95,000. And if you have to directly look at the American states, look at United States of America, it is about $120,000 per annum, guys. So it's above the average that I've mentioned. But at the end of it, let's say a machine learning engineer, you are a machine learning engineer, guys, I can guarantee you that you will be a very rich person if you hold the designation of a machine learning engineer. I mean, look at those numbers, right? So we've pretty much seen their job description as well. I mean, sure, it's a lot of work, but then knowing that you will have that number one ranking job in the entire world and a damn good salary is a win-win for you guys. As, let's say, as an enthusiast or as a programmer or as anything, right? A job that you enjoy while you code, pretty much a good salary in hand, an amazing designation, and so much more. So the machine learning engineer salary is again out of this world, guys. Again, a data scientist pretty much shares some of the perks a machine learning engineer does as well, and that pretty much also includes a salary. Even a data scientist earns somewhere around the same as a machine learning engineer, but the skill sets of a machine learning engineer would probably be a little bit higher when it comes to a data scientist, guys. So on that note, I thought let me just quickly help you organize your resume a little bit better in case you guys already choose to apply for a machine learning engineer's job. So on that note, again, building a fine resume, think about it, in my opinion, is the most crucial part in landing your dream job, right? So your resume is your entire life story in probably 1 or 2 pages max. So making sure that it stays beautiful, it's very informative, and it pretty much, surprises the employer again, or the person who's hiring you is very important, right? So here at Intellipaat, we think that these 4 are the most important steps that are needed to pretty much go on building your resume. The first thing is introduction, guys. You need to know how you should go about introducing yourself, because putting yourself, they say first impression is the best impression in the world. Well, you're pretty much the introduction, the first couple of paragraphs. So the first paragraph itself is going to be your best introduction to the person who's hiring you, right? So the introduction part of it should be very tight, guys. And the second thing is domain relevance. Again, we already know that the world of artificial intelligence is huge, right? We have artificial intelligence, we have machine learning, we have deep learning, so much more even under those concepts, right? So I just mentioned the 3 main umbrellas under which our entire world pretty much functions. So knowing that, let's say there is a job which requires you to be an expert in machine learning, but you're an expert in artificial intelligence, then you would also need to know that, again, a machine learning engineering is a part of artificial intelligence, right? So knowing that you are applying for the right domain, getting into the right job, knowing what's going on in the industry, and then mapping your resume to it is very important in the point of domain relevance, guys. And thirdly, this would be, in my opinion, the most important thing that you should be putting in your resume, guys. It's about showcasing your skills. Come on, be amazing in your resume where you're selling yourself, guys. So pretty much a resume is a 2-sheet version of you. You might be an amazing guy or girl in your entire life. Well, the person who's hiring will not know that. You need to sell yourself, and you need to show that you've done something where you deserve the huge salary that these guys are paying, or let's say even to be a part of good companies like Amazon, Facebook, Google, and so much more, right? So your skill set again is your personal skill set, professional skill sets, and so much more. And one more very important thing is the couple of certifications that you get, couple of certifications that these hirers think are extremely important are what is to be shown in the skill sets, guys. When telling them that, hey, look, I am certified in this, here's a certificate, and then if the certification is from a big institute such as us, then you're pretty much upping your game with respect to having your resume being shortlisted everywhere, guys. And then the first important thing is educational qualifications. Well, at the same time, as you've already talked about it, well, having an amazing grasp on mathematics, again, converting all these mathematical concepts into code, and then directly having an impact with respect to mathematics and code when they're clubbed together, again matters a lot, right? So you need to be very strong in your basics, and at the end of it, that's all they're checking how good your basic is and so much more, and educational qualifications pretty much tells them that.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Machine learning is a field of AI consisting of learning algorithms that A. improves their performance, B. at executing some task, C. over time with experience, D. all of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Machine learning is the heart of artificial intelligence, and it consists of techniques that lay out the basic structure for constructing algorithms. These algorithms are used to build machine learning models that predict some outcome based on the input. So let's look at the first question. So the first question is, what are the types of machine learning? So there are three types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. So let's see them in detail. So the first is supervised machine learning. In this type of machine learning technique, machine learns under the supervision of labeled data. There is a training data set on which the machine is trained, and it gives the output according to its training. So for example, if a patient is diagnosed for a disease of cancer, so the machine will predict the outcome based on the input or the symptoms as positive or negative. Now the next is unsupervised learning. Unlike supervised learning, it has unlabeled data. So there is no supervision under which it works on the data. Basically, unsupervised learning tries to identify the patterns in the data and make clusters of similar entities. After that, when a new input data is fed into the model, it does not identify the entity, rather it puts the entity in a cluster of similar objects. So you can see over here, the robot tries to identify the object and makes the clusters of similar objects, and whenever a new data is fed into the machine, it tries to identify it according to the cluster identified by it. Now the next is reinforcement learning. So reinforcement learning includes model that learn and traverse to find the best possible move. The algorithm for reinforcement learning are constructed in a way that they try to find the best possible suit of action on the basis of the reward and punishment theory. So you can see in the example, the agent tries to learn from the environment, observes the environment, select action using policy, and it gets a reward or penalty according to its suitable action. So whenever it gets the reward or penalty, it tries to learn the right suitable action according to the environment. Now let's see the next question. So differentiate between classification and regression in machine learning. So in machine learning, there are various types of prediction problems based on supervised and unsupervised learning. There are classification, regression, clustering, and association problems. So here we'll discuss about classification and regression. So in classification, we try to create a machine learning model that assists us in differentiating data into separate categories. So the data is labeled and categorized based on the input parameters. For example, imagine that if we want to make predictions on the churning out of customers for a particular product based on some data recorded. So either the customer will churn out or they'll not. So the labels for this would be yes and no. So this lies under classification problem. Now the next is regression. So it is the process of creating a model for distinguishing data into continuous real values instead of using classes or discrete values. It can also identify the distribution movement depending on the historical data. So it is used for predicting the occurrence of an event depending on the degree of association of variables. For example, the prediction of weather condition depends on factors such as temperature, air pressure, solar radiation, elevation of the area, and distance from the sea. So the relation between these factors assist us in predicting the weather condition. So this was about classification and regression. So the next question is, what is linear regression? So linear regression is a supervised machine learning algorithm. It is used to find the linear relationship between the dependent and the independent variables for a predictive analysis. So you can see the equation over here, that is y equal to a plus bx, where x is the input or the independent variable, y is the output or the dependent variable, and a is the intercept and b is the coefficient of x. So let us see the graph for it. So this is the graph where it is having a best fit line that shows the data of weight, that is y or the dependent variable, and height, that is the independent variable, of 21 years old candidates scattered over the plot. So this straight line shows the best linear relationship that would help in predicting the weight of the candidates according to their height. So to this best fit line, we'll try to find the best values of A and B. And by adjusting the values of A and B, we try to reduce errors in the prediction of Y. So this is how linear regression helps in finding the linear relationship and predicting the output. Now let's head on to the next question. The question is, how will you determine the machine learning algorithm that is suitable for your problem? So for identifying the machine learning algorithm for our problem, we should follow these steps. So first is problem classification, second is checking the algorithm, and third is implementing the algorithm. So classification of the problem depends on the classification of input and output. So for classification of input, it depends on whether we have data labeled, that is supervised learning, or unlabeled, that is unsupervised learning, or whether we have to create a model that interacts with the environment and improves itself. For classifying the output, if we want the output of our model as a class, then we need to use some classification techniques. If it gives the output as a number, then we must use regression techniques. And if the output is a different cluster of inputs, then we should use clustering techniques. Now checking the algorithms in hand, after classifying the problem, we have to look for the available algorithms that can be deployed for solving the classified problems. Finally, we'll be implementing the algorithms. If there are multiple algorithms available, then we will implement each one of them one by one, and we'll check for the accuracy. And finally, we would select the algorithms that gives the best performance. Now the next question is, what are bias and variance? So bias is the difference between the average prediction of our model and the correct value. So if the bias value is high, then the prediction of the model is not accurate. Hence the bias value should be as low as possible to make the desired prediction. And the variance is the number that gives the difference of prediction over a training set and the anticipated value of other training sets. So high variance may lead to large fluctuation in the output. Therefore, the model's output should have low variance. Let's see the diagram for it. You can see in the diagram, the desired result is the blue circle at the center. And if we get off from the blue section, then the prediction goes wrong. So the model should have low bias and low variance. And if the model is having low bias, high variance, then very few of the points are lying close to the desired result. And if the model is having high bias and high variance, then the points are not lying close to the desired result. So the model should have low bias and low variance. Now the next question is, what is variance inflation factor? So the VIF is the estimate of the volume of multicollinearity in a collection of many regression variables. So it is calculated as variance of the model divided by variance of the model with a single independent variable. So the VIF quantifies the extent of correlation between one predictor and the other predictor in a model. It is used for diagnosing collinearity and multicollinearity. So higher value signifies that it is difficult and impossible to access accurately the contribution of predictors to a model. Now let's head on to the next question. So we have to explain false negative, false positive, true negative, and true positive. So let's start with true positive. When the machine learning model correctly predicts the condition, it is said to have a true positive value. Then true negative, when the machine learning model correctly predicts the negative condition or class, it is said to have a true negative value. Next is false positive. So when the machine learning model incorrectly predicts a negative class or condition, it is said to have a false positive value. Finally, when the machine learning model incorrectly predicts a positive class or condition, it is said to have a false negative value. Let's understand this with the help of an example. So if an alarm goes on in case of a fire, it is true positive in the sense that there is a fire. That is, the fire is positive and the prediction made by the system is true. Next is, if the alarm goes on and there is no fire, then system predicted fire to be positive, but it made a wrong prediction, hence the prediction is false and the condition is false positive. Next is, if the alarm does not go on but there was a fire, system predicts fire to be negative, which was false since there was a fire. So it is a false negative condition. Finally, if the alarm does not go on and there was no fire, the fire is negative and this prediction was true. So the condition is true negative. Now let's head on to the next question. So what is a confusion matrix? So confusion matrix is used to explain a model's performance and gives the summary of the prediction on the classification problems. So it assists us in identifying the uncertainty between classes. So this is the formula for calculating the accuracy from a confusion matrix. So it consists of true positive, true negative, false positive, and false negative values. So the accuracy is calculated as the sum of the true positive and true negative values divided by all the outcomes. So the accuracy is calculated as the sum of true positive and true negative values divided by true positive, true negative, false positive, and false negative. For example, consider this confusion matrix and it consists of values as true positive, true negative, false positive, and false negative for a classification model. Now the accuracy of the model can be calculated as below. So it is the sum of true positive and true negative value divided by the sum of true positive, false negative, true negative, and false positive values. So the accuracy comes to be 0.78. So the accuracy of the model is 78%. Now let's head on to the next question. So what do we understand by type 1 and type 2 error? So type 1 error is also called as false positive, and it is an error where the outcome of a test shows the non-acceptance of a true condition. For example, a cricket match is going on, and when a batsman is not out and the umpire declares that he is out, this is a false positive condition. So here the test does not accept the true condition that the batsman is not out. Now type 2 error. So type 2 error is also called as false negative, and it is an error where the outcome of a test shows the acceptance of a false condition. For example, the CT scan of a person shows that he's not having a disease, but in reality, he's having it. Here, the test accepts the false condition that the person is not having the disease. So when should you use classification over regression? So both classification and regression are associated with prediction. So classification involves the identification of values that lie in a specific group, whereas the regression method entails a predicting a response from a consecutive set of outcomes. So the classification method is chosen over regression when the output of the model needs to yield the belongingness of the data points in a dataset to a particular category.
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
For example, we have some names of bikes and cars. We would not be interested in finding how these names are correlated to bikes and cars. We would check whether each name belongs to the bike category or the car category. So that is why we use classification over regression. Now let's head on to the next question. So we have to explain logistic regression. So logistic regression is the proper regression analysis used when the dependent variable is categorical. Like all the regression analysis, logistic regression is a technique for predictive analysis. It gives the output as binary. So logistic regression is used to explain the data and the relationship between one dependent binary variable and the one or more independent variables. Also, it is employed to predict the probability of a categorical dependent variable. For example, if we have to predict whether a citizen is a senior or not, so the output will be in 0 or 1. So there are three types of logistic regression, that is binary logistic regression. So in this, there are only two outcomes possible. For example, to predict whether it will rain or not, it will give the values as 1 or 0. The next is multinomial logistic regression. So in this type of regression, the output consists of three or more unordered categories. For example, prediction on the regional languages like Marathi, Telugu. The next is ordinal logistic regression. So in ordinal logistic regression, the output consists of three or more ordered categories. So rating an Android application from 1 to 5 star, it comes in ordinal logistic regression. Now the next question is, imagine you are given a data set consisting of variables having more than 30% missing values. Let's say out of 50 variables, 8 variables have missing values which is higher than 30%. So how will you deal with them? So to deal with the missing values, we need to first identify the values, and for that we'll specify a different class for the missing values. After that, we'll check the distribution of values over the data set, and we would hold those missing values that are defining a pattern. Finally, we'll change these into yet another class while eliminating the others with the help of eliminating functions available in Python or R. Now, the next question is, how do we handle the missing or corrupted data in a data set? So in Python, there are two methods that are very useful. So we can use these two methods to locate the lost or corrupted data and discard those values. So the first is isNull method. So we can detect the missing values using isNull method. And after that, we can use drop_NA for removing the columns and rows with null values. Also, we can use fill_NA to fill the void values with a placeholder value. Now, let's head on to the next question. So we have to explain principal component analysis. Firstly, this is one of the most important machine learning interview question. So in the real world, we deal with multi-dimensional data. Thus the data visualization and computation becomes more challenging with the increase in dimensions. So in such a scenario, we might have to reduce the dimension to analyze and visualize the data easily. So we do this by removing the irrelevant dimensions, keeping only the most relevant dimensions. So this is where we use principal component analysis. So finding a fresh collection of uncorrelated dimensions and ranking them on the basis of variance are the goals of PCA. So here is the mechanism of PCA. So we have to compute the covariance matrix for data objects. Then we have to compute the eigenvectors and eigenvalues in a descending order. Next is to get the new dimensions and select the initial n eigenvectors. Finally, we'll change the initial n-dimensional data objects onto n dimensions. So here is an example for it. Here, the two graphs shows the data points and the two directions. One is green and the other is yellow. So we got the graph 2 by rotating the graph 1 so that the x-axis and y-axis represent the green and the yellow directions. So after the rotation of the data points, we can infer that the green direction gives us the line that best fits the data points. So here we are representing two-dimensional data, but in real life, the data would be multidimensional and complex. So after recognizing the importance of each direction, we can reduce the area of dimensional analysis by cutting off the less significant directions. Now we'll look into another important machine learning interview question. So why rotation is required in PCA? So what will happen if you don't rotate the components? So rotation is a significant step in PCA as it maximizes the separation between the variance obtained by the components. Due to this, the interpretation of the components become easier. So the motive behind doing PCA is to choose fewer components that can explain the greatest variance in a dataset. So when rotation is performed, the original coordinates of the points gets changed. So there is no change in the relative position of the components. So if the components are not rotated, then we need more extended components to describe the variance. Then the visualization and prediction becomes more difficult. So you can see over this graph, the data points, these blue dots represents the data points. And if we rotate the axis to these dimensions, then all the points will lie in this x-axis. So the previous one is x-axis and the new dimension is x-axis where all the data points lies. Now let's head on to the next question. So we know that one hot encoding increases the dimensionality of a dataset, but label encoding doesn't. So how? So when we use one hot encoding, there is an increase in the dimensionality of a dataset. So the reason for the increase in dimensionality is that for every class in the categorical variable, it forms a different variable. Suppose there is a variable called color. It has three sub-levels as yellow, purple, and orange. You can see over here. So one hot encoding color will create three different variable as color.yellow, color.purple, and color.orange. Now in label hot encoding, the subclasses of the certain variables get the values as 0 and 1. So we use label encoding only for binary variables. So this is the reason that one hot encoding increases the dimensionality of data and label encoding doesn't. So you can see over here that in this label encoding, the categorical variables or categorical values are given to the name of the food, and in one hot encoding, the 0 and 1 values are given and the separate variables will be created for it. So it increases the complexity of the data. Now let's head on to the next question. How can you avoid overfitting? So overfitting happens when a machine has an inadequate data set and it tries to learn from it. So overfitting is inversely proportional to the amount of data. So for small database, we can bypass overfitting by the cross-validation method. So in this approach, we'll divide the dataset into two sections. So these two sections will comprise testing and training sets. So to train the model, we'll use the training dataset, and for testing the model, for new inputs, we'll use the testing dataset. This is how we can avoid overfitting. Now let's head on to the next question. Why do we need a validation set and a test set? So this question is similar to the previous one. So we split the data into three different categories while creating a model. The first is training set, the second is validation data set, and the third is testing data set. So let's see training data set. So we use the training set for building the model and adjusting the model's variables. But we cannot rely on the correctness of the model built on top of the training set. The model might give incorrect output on feeding new data. So we use validation set. So we use a validation set to look into the model's response on top of the sample that doesn't exist in the training data set. Then we will tune hyperparameters on the basis of the estimated benchmark of the validation data. When we are evaluating the model's response using the validation set, we are indirectly training the model with the validation set. So this may lead to the overfitting of the model to the specific data. So this model won't be strong enough to give the desired response to the real world data. So for this, we use the test dataset. The test dataset is the subset of the actual dataset, which is not yet used to train the model. So the model is unaware of this dataset. By using the test dataset, we can compute the response of the created model on hidden data. So we evaluate the model's performance on the basis of test dataset. So we do not always expose the model to test dataset after tuning the hyperparameters on top of the validation set. As we know, the evaluation of the model on the basis of the validation set would not be enough. Thus, we use a test set for computing the efficiency of the model. Now, let's head on to the next question. So what is a decision tree? So a decision tree is used to explain the sequence of action that must be performed to get the desired output. So it is a hierarchical diagram that shows the actions. So you can see the diagram over here. So we can create an algorithm for a decision tree on the basis of the hierarchy of actions that we have set. So over here, you can see we are checking whether a person is fit or not. So the parameters are, the first one is, we'll check whether the person's age is greater than or less than 30. So if it is yes, then we check for eats a lot of pizzas. So if this condition is true, then the person is unfit. And similarly for this, if the person is greater than 30, it checks for exercises in the morning. And if it is yes, the person is fit. So this is the working mechanism of a decision tree. So let's head on to the next question. So we have to explain the difference between KNN and k-means clustering. So k nearest neighbor or KNN, it is a supervised machine learning algorithm. And in KNN, we give the identified or labeled data to the model. Then the model matches the points based on the distance from the closest point. So you can see over here, these are the matched points according to the centers. And for k-means clustering, it is an unsupervised machine learning algorithm. So in this, we give the unidentified or unlabeled data to the model. Then the algorithm tries to create the batches of points based on the average of the distances between the distinct points. So you can see over here, these clusters are formed. So this is the difference between KNN and k-means clustering. Now the next question is, what is dimensionality reduction? So in the real world, we build machine learning models on top of features and parameters. So these features can be multi-dimensional and large in number. Sometimes the features may be irrelevant and it becomes a difficult task to visualize them. So here we use the dimensionality reduction to cut down the irrelevant and redundant features with the help of principal variables. So these principal variables are the subgroup of the parent variable, and it conserves the feature of the parent variable. Now let's move on to the next question.
Just a quick info, guys. Test your knowledge of machine learning by answering this question. Which of the following are machine learning methods? A. Based on human supervision. B. Supervised learning. C. Semi-reinforcement learning. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Both being tree-based algorithms, how is random forest different from gradient boosting algorithm? So the main difference between a random forest and GBM is the use of techniques. They both use different techniques for implementing. So random forest advances prediction using a technique called bagging, and GBM uses boosting to advance the predictions. So let's check each one of them. So in bagging, we apply arbitrary sampling and we divide the data set into n samples. After that, we build the model by employing a single training algorithm. Further, we combine the final predictions by pooling. So bagging helps to increase the efficiency of the model by decreasing the variance for overfitting. Now let's see boosting. So in boosting, the algorithm try to review and correct the inadmissible predictions at the initial iteration. After that, the algorithm's sequence of iteration for correction continues until we get the desired prediction. So boosting assists in reducing bias and variance both for making the weak learners as strong learners. Now let's move on to the next question. Suppose you found that your model is suffering from high variance. So which algorithm do you think you could handle this situation and why? So for handling the issues of high variance, we should use bagging algorithm. So what it does is it splits the data into subgroups with replicated sampling of random data. And when the data is splitted into subgroups, we create rules using particular training algorithms. And finally, we use pooling for combining the predictions of the model. So you can see the diagram. The data is divided into subgroups as bootstrap 1, 2 till n, and the models are created as model 1, 2 according to the training algorithms, and finally they vote for the final prediction. Now the next question is, what is ROC curve and what does it represent? So ROC stands for receiver operating characteristic. So we use ROC curve to represent the trade-off between true and false positive rates. So in ROC, the area under curve gives us an idea about the accuracy of the model. So you can see the graph. So this graph shows an ROC curve. So the greater the area under the curve, better the performance of the model. So let's move on to the next question. So what is rescaling of data and how is it done? So in real world scenarios, the attributes present in the data will be in a varying pattern. So rescaling of the characteristic to a common scale gives benefit to algorithms to process the data efficiently. For example, if a student is gaining marks out of 100 as 60 in subject 1, out of 150, 120 in subject 2, and 180 out of 200 in subject 3. So after rescaling, the marks will be out of 10. So in subject 1, he'll get 6 out of 10. In subject 2, he'll get 8 out of 10. And in subject 3, he'll get 9 out of 10. So this is how rescaling gives us the benefit to rescale the data in a common scale. Now let's move on to the next question. So what is binarizing of data? So in most of the machine learning interviews, so this question is asked. So I'll give you an example. So first of all, converting data into binary values on the basis of threshold values is known as the binarizing of data. So the values that are less than the threshold are set to 0 and the values that are greater than the threshold are set to 1. So this process is useful when we have to perform feature engineering, and we can also use it for adding unique features. So here, if a student A in subject 1 gets 60 out of 100, in subject 2 he gets 20 out of 100, and in subject 3 he gets 70 out of 100. So if the threshold is set to 40. So if the marks are greater than 40, then the student is passed, or if it is less than 40, then the student is failed. So after binarizing, we'll get the output as 1 and 0, from which we can decide whether the student is failed or not. Now let's move on to the next question. So how to standardize data? So standardization is the method that is used for rescaling data attributes, and the attributes would likely to have a value of mean as 0 and the value of standard deviation as 1. So the main objective of standardization is to prompt the mean and standard deviation for the attributes. So we'll implement standardization using Python. So let's move on to our Jupyter notebook. So this is our Python code for standardization. So we have imported the NumPy library and matplotlib.pyplot and pandas. So we'll be using the pre-processing in Python. So we'll be importing it from Sckit-learn package. So basically, pre-processing is used. It is a package that provides several common utility functions and transformer classes to change raw feature vectors into a representation, and that will be more suitable for downstream estimators. So in general, learning algorithm benefit from the standardization of the data set. So this is the use of pre-processing. Then we'll load the data set. So I have loaded the data set using pd.readcsv. After that, we'll have a look at the original data. So the original data is over here. So it denotes the scientific values. So we have to do min-max scaling, or it is called rescaling of the data. So for this, we'll use min-max scaler. So we'll be storing it in min_max_scaler. So pre-processing dot min-max scaler, and the range of the feature will be from 0 to 1. So values will be stuffed in between 0 and 1. After that, we'll use this fit_transform to fit the value of the data and transform it into a format. So let's have a look at the values after min-max scaling. So you can see the values are between 0 and 1. So these are rescaled. Now we'll look at standardization. So we'll use standardization, and we'll use this object of standardization and store this standard scaler in it so that we can use it afterward in standardization. After that, for scaled feature, we'll use this object as x_ after standardization to store the values that are standardized. So after printing the values after standardization, the output would look like this. So the negative values are the values that are less than mean, and the values which are positive are greater than the mean. Now let's move on to the next question. So executing a binary classification tree algorithm is a simple task, but how does a tree splitting takes place? How does tree determine which variable to break at the root node and which at its child nodes? So Gini index and node entropy assist the binary classification tree to take decisions. So basically the tree algorithm determines the feasible feature that is used to distribute the data into the most genuine child nodes. And according to Gini index, if we arbitrarily pick a pair of objects from a group, then they should be of identical class and the possibility for this event should be 1. So to compute the Gini index, we should do the following. So we should compute the Gini for subnodes with the formula as the sum of the square of the probability for the success and failure. So that is p square plus q square. Then we have to compute Gini for split by weighted Gini rate of every node of the split. Now we'll see entropy. So entropy is the degree of indency that is given by the following. So this is the formula for entropy, where A and B are the possibilities of success and failure of the node. So when entropy is equal to 0, the node is homogeneous. And when the entropy is high, both groups are present at 50-50% in the node. Finally, to determine the suitability of the node as the root node, the entropy should be very low. Now let's move on to the next question. So what is support vector machines? So support vector machine is a machine learning algorithm that is majorly used for classification. So it is used on top of the high dimensionality of the characteristic vector. So we'll implement SVM using Python. So let's move on to our Jupyter notebook. So I've written this code. So first we'll import datasets from the Sckit-learn package, then confusion matrix, as we will be calculating the accuracy of the model, and train test split from Sckit-learn dot model selection, because we'll be splitting the dataset into train and test set. So we'll use the iris dataset for this. So I'll load the dataset and I'll store it in iris.data and iris.target. Then we'll be splitting the dataset into train and test set. So we have separated the data into data and target and stored it in A and B. So we'll be creating separate test and train dataset for it. So we'll be using train test split function for this, and we'll give the argument as A, B, and random state will be 0. After that, we'll import SVC from sklearn.svm to implement the model. So we'll build the SVM linear model by using the SVC function and store it in svm underscore model underscore linear, where kernel will be linear and will give the data as train dataset. After that, we'll predict the model's outcome using the predict function and give the argument as test. Finally, to calculate the accuracy, we'll be using the score function. So we'll be using this svm model linear dot score and give the argument as a underscore test and b underscore test. So after that, we'll get the confusion matrix. So we'll be using the confusion matrix function. So this will be our output. So this is our output that we get, and using this confusion matrix, we can calculate the accuracy of the model. Now let's move on to the last question of this machine learning interview questions tutorial. So we have to implement KNN classification algorithm. So the problem statement is classify the iris flower based on sepal and petal length and widths using KNN. So we already know that it is a supervised machine learning algorithm, and in it we give the identified or labeled data to the models, and then the model matches the points based on the distance from the closest point. So let's move on to our Jupyter notebook for implementing this. So this is our code for implementing the KNN classification algorithm. So we'll load the iris dataset from sklearn.datasets. Then we'll be importing k neighbors classifier, which will help us in implementing the KNN classification algorithm. We'll import numpy and then train test split, so that we can split the dataset into train and test dataset. Then we'll load the iris dataset and store it in iris underscore dataset. After that, we'll be splitting the dataset into train and test using the function of train underscore test underscore split. After that, we'll use k neighbors classifier and we'll store it in kn object. Then we'll fit the model on top of training data set, that is A underscore train and B underscore train. After that, we'll be creating a new array and store the values of the characteristics of the flower in A underscore new. Then for predicting, we'll use this predict function to predict the outcome using the A underscore new data set. After that, we'll be printing the predicted target value, predicted feature name, and the test score, which will give us the accuracy of the model. So the model has predicted that the feature name is Satosa and the test score is 0.97. That means the accuracy of the model is 97%.
Okay guys, a quick info, if you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below.
Okay guys, we've come to the end of this video. I hope this video was helpful, and if you have any queries regarding this video, please comment it out below and we'll love to help you out. Thank you.